Good morning, all of you. So, yesterday topic, in a system of particles and rotatory motion, we can explain the torque and angular momentum. So, we can explain the major problems on torque. But here, angular momentum, one small topic is remaining. Now, listen carefully. Now, yesterday, one small point you can explain, that is nothing but, what is that? When no external torque acting on the body, external torque acting on the body is 0, then angular momentum is conserved. Then L is conserved. Then angular momentum is conserved. So, angular momentum is conserved means L is equal to I omega. That value is the same or constant. L is equal to I omega is equal to constant. Okay, very important point. I1 omega 1 is equal to I2 omega 2. So, when no external torque acting on the body, when no external torque acting on the body, the angular momentum is conserved. Angular momentum is conserved means I omega is equal to constant. I1 omega 1 is equal to I2 omega 2. That is the one of the important point. Now listen. On the previous question, one of the previous question, now listen carefully. For example, Earth is rotates by itself by 24 hours. Earth rotation by itself is 24 hours. Earth radius is R. Earth radius is R, having a time period is 24 hours. If radius is half of initial, radius is half of initial without change its mass. Without change its mass. Without change its mass, then new time period is. Then new time period. Now listen carefully. Earth having the some time period, by the self rotation is 24 hours, they having the some radius. If the radius is half of the initial without change its mass, then what is the new time period? Earth rotation, sun rotation, they having the no external torque. There is no external torque means I omega value constant, angular momentum is conserved. I1 omega 1 is equal to I2 omega 2. Now listen carefully. L is equal to I omega. What is the moment of inertia of the earth? Moment of inertia of the earth. Earth is a solid sphere. For a solid sphere, what is the moment of inertia? 2 by 5 mr square. Mr square. Omega value 2 pi by t. That value is constant. That value is constant. Without change its mass value constant. 2 by 5 value constant. 2 pi value constant. What are the remaining values? R square by t value is constant. R square by t value is constant. So that is the main important formula. This formula based on 2025 also one question is given. Last year question. Last year I am taking here earth. So if the radius of earth, I am taking them here earth. And last year question taking as a sun. That sun having the time period is given, whose radius is half of the initial without change its mass. What is the new time period? 2025 question. Now how to solve this one? Initial radius r square how much time period Earth 24 hours. Next case radius is half of the initial half of the initial means r by 2 whole square. We don't know about the time period. So r square by 24 is equal to r square by 4 t1. These two are cancelled. 4 here 6 times. Therefore, t is equal to 6 hours. So, if the radius is half of the initial, radius is half of the initial without change its mass, and mass value constant. That's why here mass value is constant. That's why r square by t value constant. R square by t. Initial radius r, time period is 24. After that, radius is half, whole square, time period is t1. Now that value simplifying, we get 6 hours. That is the another important point. Now next point. Another point, the previous question. A disk is rotates, a disk is rotates. Initially the moment of inertia is I, whose angular velocity is omega 1. Another disk, like the same moment of inertia, but angular velocity is omega 2. But angular velocity is omega 2. Same disk, another angular velocity is omega 2. Now these two are joined. What is the new angular velocity? Now two are joined. Disk is rotates, one disk is placed, another one. What is the new angular velocity? Now again, conservation of angular momentum. Law of conservation of angular momentum. I1 omega 1, angular momentum of the initial is equal to angular momentum of the final. Angular momentum is nothing but I omega. What is the initial one? I omega 1. I omega 1. For example, this one I1, this one I2. Different. Let us assume different. I1 omega 1. For second one, I2 omega 2. After they are joined, both having the common angular velocity, I omega. So what are that I value, both are combined, I1 plus I2 into omega. Therefore, the new angular velocity is I1 omega 1 plus I2 omega 2 by I1 plus I2. So the new angular velocity I1 omega 1 plus I2 omega 2 by I1 plus I2. This is the another important model. Okay, Namma. Right. Initial the disk, moment of inertia, angular velocity. Another disk, moment of inertia, angular velocity. Now they are joined. They are placed one over the other. That's why what is the new angular velocity? They are joined. What is the total moment of inertia? I1 plus I2 nega. What is the new angular velocity? By the conservation of angular momentum, initial is equal to final. Initial I1 omega 1 plus I2 omega 2. Both are combined I1 plus I2 into omega. So that is the another important model, amma. Right. Now one more model, amma, on the previous question. Now listen carefully. Two disks of same moment of inertia are rotates about the axis passing through the center and perpendicular to the plane with an angular velocities are omega 1 and omega 2. Like this one. Angular velocity omega 1, moment of inertia I. Second one, moment of inertia I, angular velocity is omega 2. Same moment of inertia, but different angular velocities. They are brought in contact, face to face, coinciding the axis of rotation. Same problem. Like they are joined. They are joined, now one over the other, right. They are having the new angular velocity, omega. Right. What is asking, what is the loss of the energy in the process? What is the loss of energy in the process? Loss in energy. What is the loss in energy in this concept? This concept, is similar to that of in collisions. Now listen carefully. In collisions, first body mass m1, whose velocity u1. Second body mass m2, whose velocity u2. Both are combined. We get the common velocity. We get the common velocity. Like similarly here also. First one having the moment of inertia, angular velocity. Second one having the mass, here emo moment of inertia. Velocity, here emo angular velocity. Both are joined. Here also both are joined. Here emo common velocity. Here emo common angular velocity. Both are same mega. On that concept, what is the loss in energy? Now the loss in energy is m1 m2 by 2 into m1 plus m2 into u1 minus u2 whole square. That is the formula in collisions. Okay, here same formula amma. What is the loss in energy amma? Half, like m1, here I1, I2 by 2 into I1 plus I2 into V1 minus U1 minus U2 whole square. Here omega 1 minus omega 2 whole square. But here two are the different masses, here two are the different moment of inertia. But in a given question, both having the same moment of inertia. So I into I by 2 into I plus I, 2I omega 1 minus omega 2 whole square. One I value cancel amma. So I by 4 into omega 1 minus omega 2 whole square. That is the previous question like 2017 amma. 2017 question. They are having the same moment of inertia, having the angular velocities are omega 1 and omega 2. They are brought in contact. They are having the common angular velocity, but is asking the loss in kinetic energy. Loss in energy formula is the important one. Sometimes, what is the new angular velocity? How to find the new angular velocity? Already previous one I am explained. What is the new common angular velocity? I1 omega 1 plus I2 omega 2 by I1 plus I2 nega. Common angular velocity. First, I1 I2 both are same that's why I value common. I plus I2 I, here omega 1 plus omega 2. I value cancel, omega 1 plus omega 2 by 2. That is the common angular velocity. But in this problem is asking the only loss in energy. So that model is also important too, and already this model is the given previous NEET question. Here both are rotating on the same direction Sometimes one is rotate clockwise, another one is rotate anti-clockwise. What happened? Both are rotating in opposite direction Second one is rotating in opposite that's why I take the minus omega 2. That's why omega plus omega 1 plus omega 2. In case of opposite rotation, omega 1 plus omega 2. Right here also plus Now in this common angular velocity in opposite rotation, I1 omega 1 minus I2 omega 2 by I1 plus I2. And here take them minus in opposite direction. So this is the another important concept right. So another important question in 2016 question. In 2016 question, two rotating bodies A and B having the masses m comma 2m. Two masses m comma 2m having the moment of inertias IA and IB, but in bracket IB value is greater than IA. Having the equal kinetic energy of rotation. Having equal kinetic energy of rotation. Having equal kinetic energy of rotation. Then find the relation between the LA and LB. Relation between LA and LB. LA and LB means angular momentums. What is the relation between the angular momentums? This is also the previous question. Right kinetic energy and this is the angular momentum. What is the relation between the kinetic energy and angular momentum? Now listen carefully. In linear motion, kinetic energy is equal to p square by 2m. Already we know that. In linear motion, kinetic energy is equal to p square by 2m. But in rotatory motion, the rotatory kinetic energy is equal to p plus low L, m plus low I. Already we know that. Yesterday I will explain the points. Mass replacing a moment of inertia. Momentum angular momentum like this. So which one is the same Equal kinetic energy, and this value constant 2 value constant Therefore, what is the L square directly proportional to IA? That means L is directly proportional to root IA. Which value having the more moment of inertia? That one having the more angular momentum. Which one having the more moment of inertia? B. That's why LB is greater than LA. LB is greater than LA. So the answer is LB greater than LA. So another model, right? 2016 question. Next one. Okay, next one is the moment of inertia. Okay. Moment of inertia. What is the formula of the moment of inertia? A particle of mass m, some distance is r. This one is rotate about the axis. The particle is rotates about the axis. That's why what is the moment of inertia? Product of the mass and the square of the distance from the axis of rotation. I is equal to mr square. I is equal to mr square. Product of the mass and square of the distance from the axis of rotation is nothing but moment of inertia. Direct formula. Right. So just is the given again the previous NEET question. Previous question like that here is nothing but (2016) question Again the 2016 question. Two masses m1 and m2. Two masses m1 and m2 are separated by a distance r. They are rotating about their center of mass. They are rotates about center of mass. They are rotate about the center of mass. Then what is the moment of inertia? Then what is the moment of inertia of the system? Then what is the moment of inertia of the system? So this is the question. These two bodies m1 and m2. So in the given question which one is the given m1 and m2 masses are separated by a distance r, right? The axis is passing through the center of mass and perpendicular to the distance. Like the distance is r, this is the axis. But that axis is passing through center of mass. That axis is passing through center of mass. What is the moment of inertia? Right. Now listen carefully. This one is m1. This one is m2. What are the coordinates? Let us assume this one is origin. What is the distance? R. What are the coordinates? R, 0 nega. What is the position of the center of mass? Already we know that xm is equal to m1 x1 plus m2 x2 by m1 plus m2 nega. m1 x1 value is how much? 0 ga. m1 into 0 plus m2 into what is the value of x2 r by m1 plus m2. Okay, number. So that's why what is the value? m2 r by m1 plus m2 nega. Already yesterday concept, this one is complete ga. m2 r by m1 plus m2. From this point the center of mass location. This is the one of the method. And also we know that the another method. What is that one? Now listen carefully. Another method. This one M1. This one M2. The center of mass nearer to heavy mass. We don't know about the heavy mass. Let us assume this is the heavy mass. Like R1 no. Like this one X distance amma. What is the remaining value? R minus X ega. Already we know that the distance value is nearer to heavy mass ga, and M is inversely proportional to R ega. Already yesterday class lo we can complete them mass is inversely proportional to R. For heavy mass center of mass is very nearer to it. So M is inversely proportional to R. For M1 ki what is the distance X? Or simply inversely proportional to R means MR value constant. What is the MR value M1 no X. Other one M2 into R minus X. That's why M1 X, M2 R minus M2 X. Therefore, X value, this value take them in this side. What is the value? M2 R by M1 plus M2 nega. Already I am explaining that one nega. M2 R by M1 plus M2 nega. Right. So here what is this value Center of mass this one nega. M2 R by M1 plus M2. This one M2. This total value R ga, R minus this value we get M1 R by M1 plus M2. M1 R by M plus M2. This is the axis What is the total moment of inertia? I is equal to M1 into, what is the distance? MR square. M2 R by M1 plus M2 whole square plus, what is this mass M2 into, what is this distance M1 R by M1 plus M2 whole square. So on common values take them separate that's where we get I is equal to M1 M2 by M1 plus M2 into R square. So this is the one of the important model not only in a NEET mains law also 2-3 times they are given same model. Now listen again. Two masses M1 M2. An axis is passing through the center of mass That means they are rotating about center of mass. What is the total moment of inertia of the system? Okay. First M1 no M2. What is the location of the center of mass? We don't know. That's why how to solve that one. The center of mass is nearer to heavy mass. Let us assume this is the heavy mass. Nearer like X distance. Total distance R. In R lo X value is over remaining R minus X. Okay, that's why already we know that mass is inversely proportional to distance. Like MR is equal to constant. M1 X is equal to M2 into R minus X. That's why what is the value of X M2 R by M1 plus M2. Like this X value M2 R by M1 plus M2. What is the remaining value? R minus X R minus X value is how much? This value R minus this value we get like this. Here M2 R kadama, here M1 R. Terms are reversed. So this is the M1 and M2. Center of mass distance values are known. How to find the moment of inertia? I is equal to MR square, M1 into R square plus M2 into R2 square. That values are simplifying M1 M2 by M1 plus M2 into R square. Very very important model 1 or 2 times you can practice them on rough notebook. For example, same problem. The center of for equal masses, or sir, for example, same one, they are rotates about center. Now listen, they are rotating about their center. What is the moment of inertia? Like this one, M1, this one M2. About the center means this value R by 2, this value R by 2, this one is rotates. That's why what is the moment of inertia M1 into R by 2 whole square plus M2 into R by 2 whole square. So what is the value amma? R square by 4. Take them common amma, m1 plus m2. This one amma, they are rotating about their center. Now listen carefully. This is the rotating about their center. This model amma, they are rotating about their center of mass. About their center means in between the total distance half. Center of mass amma, the total system ki where the center of the mass, the total mass is acting at a point, that is known as the center of mass ka, that is the center of mass of this one amma. Both are the important models amma, we can practice them. Next one amma. Now listen carefully. This is the, for example, I am explaining about the ring. Here, this is the ring. An axis passing through the center perpendicular to the plane. I value is equal to mr square. Mass m or radius m. What is the moment of inertia? Mr square. Now, this is the ring. Just this body rotate about this axis ga. This body rotate about this axis. What is the moment of inertia? An axis passing through the one end of the body perpendicular to its plane. One end perpendicular to the plane. What is the moment of inertia? I is equal to actually this one is the parallel axis theorem. These two are the parallel axis theorem. In case of the parallel axis theorem, I is equal to Iz plus mx square. Iz means passing through the center and passing through the center perpendicular to the plane. How much? Mr square. Plus, what is the distance? R. Mx square. X square means R square. These all are the important formulas. No need for that derivation. We can practice the only formulas. One end 2mr square. Now other one. This is the axis about the diameter. About the diameter. Mr square by 2. About the diameter. Mr square by 2. This is the ring. This is the diameter. An axis passing through that one end parallel to the diameter. One end parallel to the diameter. What is the moment of inertia? Mr square by 2. This value mr square by 2 kada. What is the distance between them? R, like parallel axis theorem. Plus mr square. 3 by 2 mr square. 3 by 2 mr square. That's why these all points are the important for a ring. Similarly, one more point. After that, we can explain the some models. Disc. Like this one, disc. Axis passing through the center perpendicular to the plane. Mr square by 2. Mr square by 2. For ring ki mr square. For disc mr square by 2. About this one same for expression. Iz place lo here mr square ga. Now here mr square by 2 plus mr square. How much mr square by 2 plus mr square. 3 by 2 mr square. 3 by 2 mr square. Another important point. About the diameter. About the diameter. Mr square by 4. Diameter this one is parallel parallel. The moment of inertia is 5 by 4 mr square. In a disc compulsory in ring and disc formulas are the very important one. Okay, so this one about the diameter mr square by 2. This one for disc about the diameter mr square by 4. Now this one is axis passing through the one end parallel to the diameter. 3 by 2 mr square. Passing through the one end parallel to the diameter. Passing through the one end parallel to the diameter. 5 by 4 mr square. Very important formulas. We can note them with diagrams. With the diagrams, you can note them the important models. Now the previous questions also are there for these models. Only the ringo and the disc. Right. Now, one example, 2015 question, AIPMT question. So, these all are the three different error, all are the same mass and same radius of the disk. This is the axis. What is the moment of inertia of the system? Each one having the mass m, radius r. Each one having the mass m and the radius r. What is the moment of inertia of the system? Now listen, the total moment of inertia of the system, this one m, 1 m, 2, 3, I1 plus I2 plus I3. I1, now we can observe the this is the diameter gamma, axis is passing about the diameter. The axis passing through the diameter is nothing but how much? Mr square by 4 plus, like now we can see the second one. This is the diameter gara. Diameter, this one is the parallel ga. This axis is nothing but, this is the diameter. Diameter parallel. Diameter is nothing but a parallel. What is the value? 5 by 4 mr square. This one is also same gara. This is the diameter. Diameter ka parallel hai gara. 5 by 4 mr square. So what is that? LCM ra 4. mr square, 5 mr square, 5 mr square. 10 plus 1, 11. So 11 mr square by 4. 11 mr square by 4. That is the one of the important model. Main we can focus on a ring and a disc. Previous questions are is the mainly given on a ring and a disc. So one question in 2026 on May 3rd exam question like 2026 May 3rd question. A thin wire of length L and length L and linear density M and is bent in the circular ring at the center C. Like this is the wire that wire length is L. That wire length is L and mass is M and mass is M. That is bent into circle. This total one is the bent into circle. That's why in the given question axis like this one. Axis like this one. What is the moment of inertia? What is the moment of inertia is asking. Right this one is similar to that of, this is a ring. Wire is bent is into the circle means like a ring. Ring what is the about the diameter is how much Ring about the diameter is nothing but mr square by 2 nega. But in this question this is the diameter. Diameter ka parallel ga like this. This is the diameter. Diameter parallel ga. What is the moment of inertia? mr square by 2 plus mr square. 3 by 2 mr square. What is the formula? The moment of inertia I is equal to 3 by 2 mr square. Problem over. Directly is asking the formula. But in a given question the radius value is not given. Which one is given? Only length is given. That wire is bent into the circle. That means the total length value is L. That total length is nothing but circumference. Total length is circumference. L is equal to 2 pi r. Therefore, r is equal to L by 2 pi. 3 by 2 m into r square. L square by 4 pi square. So 3ml square by 8 pi square over. That is the 2026 question. All are you write the paper on May 3rd na? This question is the given. Why the length is L amma and the mass is m ra. That is bent into circle amma. That is bent into circle. That's why about this axis amma, what is the moment of inertia? Like this is the ring amma. Ring about the diameter value, how much amma moment of inertia? mr square by 2. Diameter that one is parallel ga. Diameter parallel, what is the moment of inertia? 3 by 2 mr square. Right. That moment of inertia 3 by 2 mr square. 3 by 2 m. R value don't know. But the total length is nothing but L ga. That total length of the wire is bent into the circle ga, and the length is nothing but 2 pi r. Therefore, R is equal to L by 2 pi. R plus low L by 2 pi. R square ga L square by 4 pi square. 3m L square by 4 2s are 8 pi square. That's where we get the total moment of inertia. That is the 2026 question amma. Next amma. Now one more model amma. Very important model amma. This model 2 times is the given on the previous NEET. 2 times. One, this is the 2016 I am explaining the problem is a 2016 question. For a disc, this is the disc of mass m and radius r. A hole of the diameter r, mass m and radius r, a circular hole of diameter r whose rim is passing through the center is cut. This is the one small portion like this one. One small portion is removed whose diameter is how much amma? Whose diameter is nothing but how much radius of the disc ga? This part is removed. How to remove that one? That part is passing through the center. That removed part passing through the center. Right. That's why what is the moment of inertia of the remaining portion of the disc? This mass is removed. The remaining portion is there. The remaining portion is asking the moment of inertia about an axis passing through the center perpendicular to the plane. Now this is the point amma. But overall in a given question is the given mass m radius r. Now listen, the total moment of inertia is I is equal to how many parts this one removed part, this one remaining, and what are the total one is removed plus moment of inertia of the remaining. Now listen carefully the total moment of inertia of the body is equal to moment of inertia of the removed plus moment of inertia of the remaining. But in a given question, what is asking amma? This part is removed is asking the only moment of inertia of the remaining. Therefore, moment of inertia of the remaining is equal to moment of inertia minus I removed. The total moment of inertia minus I removed. Now listen carefully. What is the total moment of inertia? Original. This is the original mass m radius r. What is the moment of inertia about this axis? mr square by 2 nega. I value, the total moment of inertia is nothing but mr square by 2. Now next. Okay, the total moment of inertia, mass is m and radius r. I am writing here. Mass is m, radius r. Like this one, what is the value of I is equal to mr square by 2 mr square by 2. What is the moment of inertia of the removed part? And like this one, what is the moment of inertia of the removed part? Now listen, the total mass is m. What is this part mass m? This part radius value r by 2 nega. Now listen carefully. Initial mass is m, whose area value is how much amma? Pi r square. Total one is pi r square. Whose removed part mass we don't know. What is the area? Pi. Radius value r by 2 whole square, r square by 4. Pi r square ante mass m ega. That value is equal to how much amma? M by 4. Like total mass is m, the removed part mass m by 4. Okay, that is a very very important point. Now listen. What is this removed part? Like this one ega. Okay, whose mass value is how much amma? M by 4 ga. Whose radius value is how much amma? R by 2 nega. What is the axis amma? Axis passing actual ga, this is the axis ga. Here ga the axis. This is the axis ga. This one passing through the center ga. Passing through the center mr square by 2. That one having the parallel kada, mr square by 2 plus mr square amma, like 3 by 2 mr square kada. So the total moment of inertia of the removed part, I removed is equal to 3 by 2 mr square formula. 3 by 2 mr square. 3 by 2, what is the mass value? M by 4 ga. R square by 3 by 2 m, r square, what is the value? R by 2 whole square, r square by 4. 3 m r square by 4 4s are 16, 16 2s are 32. Okay, this one is similar to that of like this one. About the center mr square by 2. That one end mr square by 2 plus mx square, 3 by 2 mr square. So 3 by 2, this mass value name m by 4, radius value name r by 2 whole square gar r square by 4. We get 3m r square by 32. Therefore, the total moment, the remaining moment of inertia, I minus I removed. What is the value of I? mr square by 2 minus, what is the I removed? What is the I removed value? 3 mr square by 32. What is the LCM amma? 32. 2 here how many times? 16 times. And 16 mr square minus 32 one time, 1 into 3 mr square. How much value we get amma? 16 minus 3, 13 mr square by 32. The total moment of inertia of the remaining is equal to I minus I removed. What is that value amma? I minus I removed gara 13 mr square by 32. 13 mr square by 32. This is the important model. That question is the given 2016. So important model. Right. Now another model. So the total moment of inertia I is equal to I removed plus I remaining. Therefore, I remaining is equal to I minus I removed. What is the total moment of inertia of the body about axis passing through the center perpendicular to the plane? Mr square by 2. So we can find the removed part like this one. How to find this mass amma? M mass ki area pi r square. So this mass m1, area pi r by 2 whole square means r square by 4. Pi r square means m gamma m by 4. So this one mass m by 4, radius r by 2. Okay, axis actual this is the total body ga. Axis passing this one kada. This one center this one center. This one parallel kada, like this one. So the moment of inertia passing through the one end perpendicular to the plane, 3 by 2 mr square. 3 by 2, mass value m by 4, r square r by 2 whole square, r square by 4, 3 by 32 mr square. I remaining is equal to I minus I removed we get 13 mr square by 32. That is the one of the model amma. Now, next point, amma. Now, this is the question 2021, amma. 2021. A circular ring of mass m and a radius r. Circular ring of mass m and a radius r are corresponding to a 90 degrees sector is removed. That's why the moment of inertia of the remaining part of the ring about an axis passing through the center and perpendicular to the plane is k times of the mr square. What is the value of k? Now listen, amma. In this one, amma, 90 degrees part is removed. Like this one. 90 degrees sector part is removed, amma. That's why the moment of inertia of the remaining part, axis amma passing through the center perpendicular to the plane. That what is the moment of inertia amma? K times of the mr square. That's why what is the value of k? Is asking the k value. Now listen. Here amma 90 degrees sector. 90 degrees part is removed. What is the moment of inertia? Now listen, amma. Actually, the total mass is m and the radius r. So in this one, amma, in that one, 1/4 of the mass is removed. What is the remaining mass, amma? 3/4 of the mass. 3/4 of the mass m. Original mass m, amma. In that one, 1/4 mass is removed. Amma. What is the remaining, amma? 3/4 of the mass. Like 3/4 m. One of the important point. In any body, some mass is removed. Moment of inertia value same. For example, amma, an axis passing through the center perpendicular to the plane, here value is how much, amma? Mr square kada. Here part is removed, the formula and like the moment of inertia same, and like I is equal to mr square. But what is the mass of this body, amma? Formula same. Then what is the mass of this body? 3/4. What is this mass, amma? Like m1 I am taking. What is this mass? 3/4 m. Radius as it is a gamma. But a comparison is 2 amma is the given the k times kada. What is the value of k? 3/4. K is nothing but 3/4. So is asking ammo this question amma on 2021 question. Now one more model. Two thousand 2019 question. A solid cylinder of mass m and radius r. Solid cylinder like this. Mass m 2 kg and radius 4 centimeter. Is rotating about this axis at the rate of 3 rpm. This one is a rotate amma. How much rotations are? 3 rpm. Initial 3 rpm. 3 rotations per minute amma. The torque is required to stop them in 2 pi revolutions. What is the torque is acting? To stop. To stop means final angular velocity value 0. How many rotations are there? 2 pi rotations. 2 pi revolutions. So 2 pi revolutions. 2 pi revolutions amma, he is stop. What is the torque acting on it? Now again amma, this type of the models number of times is repeat amma. Now listen. Initial this is the solid cylinder amma. Mass and radius r is given. Is the rotating amma. On your floor it is rotating like a pipe amma. Like not pipe amma, like iron rod. On iron rod amma. Solid cylinder it is rotating on a surface. How many rotations per minute? 3. So it is moving towards we can apply the opposing some torque is applied, they can be stopped kada. how much of the torque is applied, they can be stopped. Before stopping, how many rotations are there, amma? 2 pi rotations are there. That's why what is the torque acting on it? Now listen carefully. What is this one is nothing but a solid cylinder. What is the moment of inertia of the solid cylinder, amma? Mr square by 2. The solid cylinder, amma, about the own axis is nothing but mr square by 2. That is the first point, amma. Mass mr square by 2. Mass value is how much, amma? 2. R square. R value 4 centimeter. 4 square 16. Centimeter is converted into meter. 10 power minus 2 whole square by 2. 16 into 10 power minus 4 kg meter square. Moment of inertia value came. What is the initial angular velocity, amma? Already we know that omega formula 2 pi n by t. 2 pi n by t. 2 pi. How many rotations are there, amma? 3 rotations per minute and by 60. 3 2s are 6. 6 how many times, amma? 10 times and pi by 10 radians per second. The initial angular velocity like this. Final ga stopped ga. How many rotations are there, amma? 2 pi revolutions ga. For one rotation ki 2 pi. For 2 rotations ki 2 pi into 2. For n rotations ki 2 pi n. 2 pi n is nothing but 2 pi revolutions ka. Like 4 pi square radians. So how to find the alpha value from this data? V square minus u square 2as. Omega f square 0 minus omega I square pi square by 100. 2 alpha theta 4 pi square. So 0 ga leave it pi square cancel. What is the value of alpha? Minus 1 by 4 2s are 8. 8 can be taken in denominator. Minus 800 radian per second square. So alpha value came ga. Here moment of inertia value came ga. How to find the torque is applied, amma? Torque is equal to I alpha. Torque is equal to I alpha. What is the torque value, amma? Sorry, what is the value of I? 16 into 10 power minus 4. Like alpha value name minus. Why take the minus, amma? Initial velocity is there, amma. Final velocity is 0. That means retardation. Finally come to rest means they having a retardation. That's why a negative sign. So that one is removed. That's why what is the value of alpha? 800. This 8 value here 2 times. These 2 zeros take the numerator, amma, 10 power minus 6. The torque applied on them is 2 into 10 power minus 6 Newton meter. Newton meter. This is the previous question, the 2019 question. Simple model enamma. Just we can practice the 2-4 models. We have the simple models. All are solid cylinder, amma, rotating about the one axis. They are having the initial 3 rotations per minute, amma. 3 rotations per minute. So 3 rotations per minute slowly is moving, amma. We can opposing torque is applied, amma. Slowly it can be stopped. For 2 pi rotations are there. What is the torque acting? Moment of inertia of the solid cylinder is mr square by 2 formula. That values are substituting we get. What is the initial angular velocity? 2 pi n by t. Final ga stop. In 2 pi rotations kara, what is the value of theta? 2 pi n. V square minus u square is equal to 2as, we get the alpha. Now torque is equal to I alpha, we get the answer. So this is the one more model, amma, based on the moment of inertia concept. Next model. So again, amma, is nothing but 2019 question. 2019 that 2019 amma, 2 questions are given, amma, like another question. A disk of mass m and mass 100 kg and radius 2 meters. Disk mass value 100 kg, radius 2 meters. Rolls on a horizontal floor. Rolls on a horizontal floor. This is a horizontal floor, amma, like this one. Disk is rolls on a horizontal floor. Its the center of mass has a speed is 2 centimeter per second. Center of mass. How much speed, amma? 2 centimeter per second. How much of the work is needed to stop it? Initial 2 centimeter per second, gamma. Final after moving some distance, amma, whose final velocity becomes 0. How much of the work is there? How much of the work is needed to stop it? How much of the work is needed to stop it? Okay, Nama, sorry, right. What is the moment of inertia of the disk, amma? Mr square by 2. Mr square by 2. Moment of inertia of the disk. Mass value 100. R square, 2 square, 4 by 2. This value 200 kg meter square. Okay, now listen carefully. Final angular velocity. In final velocity 0 means angular velocity 0 nega. Final angular velocity 0. Already initial velocity is there, gamma. Initial velocity and radius value is there, gara. That's why what is the initial angular velocity? V by r. Already we know that V is equal to r omega. Therefore, omega value V by r. V value 2 centimeter per second, 10 power minus 2. By radius 2. How much value, amma? 10 power minus 2 radian per second. But already we know that moment of inertia, already we know that work done in, final angular velocity, initial angular velocity. How to find the work done, half I omega f square minus omega I square ga. Omega f value 0. So that's why half, what is the value of I, amma? 200. Omega I square, amma? 10 power minus 4. 10 power minus 4. So that's why 2 value cancel, we get 10 power minus 2. 10 power minus 2 joules. So that is the another model, amma. So 10 power minus 2 joules. Now listen. Initially that disk having the some velocity number. So finally it is come to rest. Finally it is come to rest. What is the work done is required. But this is the disk of mass m and radius is given, gara. That's where what is the moment of inertia? Disk, mr square by 2. Mass value 100, r square 2 square by 2. We get 200. Finally it is come to rest means so final velocity 0 ga, final angular velocity 0. Initially they having the velocity 2 ga and radius r gada. That's where what is the value of omega? V by r. V by r. So V is equal to r omega. Omega is equal to V by r. What is the value of V? 2 centimeter per second. 2 into 10 power minus 2. By radius 2 meters. 2 value cancel, 10 power minus 2 radian per second. So initial angular velocity is there, final angular velocity 0, moment of inertia value already we know that. What is the work done formula? Half I omega f square minus omega I square. Half I value 200. So omega f value 0, omega I value 10 power minus 2, whole square ga 10 power minus 4. 2 cancel, we get 10 power minus 2 joules. So this is the work done final expression, number 2019 question. Okay, 2 minutes. Okay, number. So this all the models are rotatory motion, number today concept and yesterday total ga rotatory motion, system of particles and rotatory motion is complete, number. And tomorrow topic gravitation. So in gravitation also every year 1 or 2 questions are given. But rotatory motion lo compulsory 2 questions. Okay, number. So on tomorrow we can start the gravitation. Right, number. Thank you.
right? Good morning, Amma. Now, today I am going to discuss about structure of atom. Already I discussed structure of atom yesterday, some of the concept. Now today, some of the important concept I am going to discuss. Compulsory, they are asking one question. Already yesterday what I explained concept, that concept compulsory 1 or 2 questions. Now this model, now today's concept is compulsory 1 question or 1 or 2 maximum, chances are there. So observe clearly what are those today's concept. Quantum numbers. Quantum numbers, after quantum numbers, next one is filling up the electrons in the orbital, that is called by using some principles are there, Abbo and Pauli's exclusion and Hund's principles are there. So what are those, what are the definitions, how to follow then rules, then we will see one by one. Before going that, first we are going to discuss about quantum numbers. Total quantum numbers are there, 4 quantum numbers are there. So what are those? One is principal quantum number, second one is azimuthal quantum number, third one is magnetic quantum number, fourth one is spin quantum number. These are 4 compulsory. They will ask one of the time, not one of the last year, one of the time they asked the question is what? Match the following based on the principal, based on the quantum number, they asked one of the question, match the following. Observe now clearly. So first one I am going to discuss about principal quantum number. Principal quantum, that is what? Number 1, 2, 3, 4. I am going to discuss about first principal quantum number. Principal quantum number is proposed by Niels Bohr. That means this principal quantum number is totally explained about Bohr's atomic model. So according to Niels Bohr, according to principal quantum number is represented by symbol is N. N indicates small n, not capital N. N indicate orbit, shell, also called energy level. Yesterday I told Bohr's atomic model, right? So represented symbol is N. N is equal to orbit, also called shell, also called energy level. So representation number N start from 1, 2, 3, 4 and so on up to infinity. N equal to 1 first orbit, second orbit, third orbit, fourth orbit and so on infinite orbit. In case of alphabets, K, L, M, N and so on infinity. That means K shell, L shell, M shell, N shell. Otherwise K energy level, L, M, N energy levels. This is the first point. And again important point is very important, that is called significance. Significance means, that means importance of the principal quantum number. Those only they are asked the question. So all principal quantum numbers significant. They are asking one time. One side they are given quantum numbers, other side they are given significance. Match the following. Last before here they ask the question. Now significance. What is the importance of this one? Principal quantum number indicates the size and energy of the orbit. This is a very important. What is the significance? What is the importance? Principal quantum number important is it indicates or it signifies the size and energy of the orbit. Yesterday I told one point, remember now. N is called orbit. Orbit number increases. Orbit number increases. What is increases? Energy is increases. Energy increases means what happens? Size also increases. So how? Yesterday I given one mathematical equation by using Bohr's atomic model, energy calculation. N is equal to minus 13.6 into Z square by N square electron volt I given. It is applicable for hydrogen and hydrogen like species I told yesterday. So N is equal to 1, 2, 3 I substituted. Z is equal to hydrogen atom I substituted, then I got different values. Based on those values I told, that means I given confirmation yesterday, orbit number increases. What is increases? Energy increases. Energy increases means what about size? Size also increases. Observe here first, this is the first orbit, second orbit, third orbit, fourth orbit, fifth orbit and infinite orbit. That means n equal to 1, 2, 3, 4. This is called nucleus. Nucleus means positive charge, proton, right? So nucleus here. This surrounding by what? Electron. Electron is revolving around the nucleus in a which path? Circular path. Circular path is called what? Orbit, also called shell, also called energy level. That means what happened? Orbit number increases. What about energy? Energy also increases, yesterday I told. What about size? Size means here, observe here. From here it is called distance. Center of the nucleus to the outermost orbit is called radius, also called atomic size. Again, from this is center of the nucleus to this is called size. Again, this is size, this is called size. What happened? Size. Orbit number increases. Size also called radius will be. Size or radius will be increases. This is the conclusion. Finally, what you have to say? Orbit number increases, energy is increases, size also increases. That's why it signifies what? Size and energy of the orbit. By using this, I am going to say the one important point. Total number or maximum number of electron in an orbit, maximum number of electron present in orbit is equal to 2n square. Very important. So maximum number of electron in an orbit, each orbit having how many electrons are there? Then how to find? 2n square, where n is equal to orbit number. For example, n equal to 1 I will substitute, n equal to 1, that is called first orbit. First orbit having how many electron? 2 into 1 square, that is equal to electron. That means here first orbit having 2 electrons. Now n equal to 2, 2 into 2, 2 square, that means 2 square means 4, 4 2s are 8 electron. That means here how many electrons are there? Second, 8 electron. 8 electron means already first orbit how many electrons are there? 2 electron. That means 2 electron, remaining how much is there? 6. That means here 2 comma 6. That is first orbit is only 2 electron. Second orbit is 8 electron, means that is splitting is 2 comma 6. Right, you will get it you. Now n equal to 3. N equal to 3 means 2 into 3 square. 3 square means 9. 9 into 2, 18 electron. That means third orbit is having 18 electron. 18 electron means already first orbit 2, second orbit 2 comma 6, 8, and remaining is third orbit is what? 10. Total splitting is 2 comma 6 comma 10. That means 2 comma 2 plus 6, 8, 8 plus 10, 18. Now fourth one, 2 into 4 square, that is called 32 electron. 4 4s are 16, 16 into 2, 32. That means how it is split? 2 comma 6 comma 10 comma 14, like this. This is only now maximum number of electron in any orbit is equal to 2n square. Very important. One of the time this is the question they asked, right? Next one, total number of orbital, orbit having the how many orbital, how to calculate, is equal to formula is n square. Total number of orbital present in the orbit is equal to n square. So n is equal to orbit number, now n square, that means n equal to 1, 2, 3, 4, 5, 6 like that, right? So up to infinite. Sir, why you are calculating 4 only? I can calculate 5, I can calculate 6. Okay, you can, no problem. So like this you have to do. Now 1, 2, 3, 4, first orbit, second orbit, third orbit, fourth orbit, infinite orbit. Orbital I am going to calculate. Orbital, n square means 1 square. 1 square means how much? 1 orbital. 2 square. 2 square means how many orbitals? 4 orbital. 4 orbital, like the splitting. So that means first orbit having how many orbital? 1. Second orbit having how many orbital? 4. 4 means 1 comma 3. Already 1 is there. 1 plus 3, total how much? 4. Now 3 square, that means how much? 9. 9, how it is split? Already first orbit 1, second orbit is 1 comma 3, that is called 1 comma 3. Next one is third orbit is 1 comma 3, means 1 plus 3, that is equal to 4. 4 plus total 5, that is equal to 5 plus 3, 8, 8 plus 1, 9. Now 4 square, 4 square means how much here? 16. 16 means splitting 1, 3, 5 and again 9. Sorry, 7. 3 plus 1, 4, 4 plus 5, 9, 9 plus 7, 16. 16. These are called orbitals, right? So based on this, how can what I have to say? One orbital. This is the orbital. This is called orbital having the orbit. Means orbit having the orbital. First orbit having how many electron? 2 electron. 2 electron means how many orbitals are there? 1 orbital. So orbital representation is like this, box type. That is called square box. So one box. Now my total how many boxes required here? 4. That means 1, 3 like this. Now here 1, 3, 5. Here 1, 3, 5, 7 like this. That means one orbital occupies how many electron? 2 electron. The total how many orbitals are there? 4. 4 means 4 into 2, 8. That means here 2, 2, 2, 2. That means each orbital can accommodate maximum number of electron is 2 electron. That is only final conclusion. Next, here total how many there? 9 orbitals are there. 9 orbital means each orbital is 2 electron. Total electron 18 electron. 18 electron, third orbit. Now here how many orbitals are there? 16. 16 means 16 into 2, 32 electron. 32 electron. Like this you have to do. Then last and final point of the what you call Bohr's principal quantum number. This principal quantum number is angular momentum. Angular momentum of electron is equal to, angular momentum means MVR is equal to integral multiples of h by 2 pi. This point already I told you in where I told Bohr's atomic model. Angular momentum means what you call MVR is integral means n multiplied with n, integral multiples of h by 2 pi. This is called quantization. These are the important points related to which quantum number? Principal quantum number. Next one, azimuthal quantum number. So these all are, every point is question number. So many times they ask a question. Every point is one type of question. Otherwise statement based question. Otherwise match the following question. Like that they will ask. So concentrate more. Next one is azimuthal quantum number. This azimuthal quantum number is proposed by Sommerfeld. It is proposed by symbol is L, means represented by symbol is L. There n, small n, here small l. Now here important is L value depends on n. L value depends on n. Without n value there is no L. That means, that is the meaning. L is depends on n. There is no n value, there is no L value. And again, L is range from, range from means L is start from 0, 1, 2 and so on to n minus 1. This is the important point. L is range from 0 to 0, 1, 2, 3 up to and so on n minus 1. But n is start from 1. N is start from 1, but L is start from 0. This L represent the various subshell, very, very important. L represent the various subshells. Various subshells means we are in the subshell, total 4 subshells are there. We are having L equal to 0, L equal to 1, L equal to 2, L equal to 3. L equal to 0 means what about n value? N equal to 1. How you know? 0, that means n value is 1, 1 minus 1, 0, that is L equal to 0. N equal to 2, n equal to 2 means 2 minus 1, 1, L equal to 1. N equal to 3, 3 means third orbit means 3 minus 1, that is equal to 2. N equal to 4, 4 minus 1, 3, that means, so n equal to 1, L equal to 0, that indicates which orbital? S orbital means S subshell. L equal to 1, that is equal to P subshell. L equal to 2, D subshell. L equal to 3, F subshell. L is equal to 4, some other subshell. S, P, D, F, G. It is not there. Okay, S, P, D, F. These are the subshells. 4 subshells, that is called 4 orbitals. Now, next point, next important point. Maximum number of electrons in a subshell. Maximum number of electrons in a subshell is equal to 2 into 2L plus 1, 2 into 2L plus 1, where L is equal to 0. Observe here, L equal to 0. L equal to 0 means what about N? N equal to 1. So L equal to 0 means how many electrons will occupy? L equal to 0. Substitute 2 into 0, 0 plus 1. That means plus 1 into 2, that means 2 electron. L equal to 0 means which subshell? S subshell. S subshell occupy how many electron? 2 electrons. Next one. L equal to 1. L equal to 1 means 1 substitute. 2 into 1, 2 plus 1, 3, 3 into 2, total how many electron? 6 electron. 6 electron means which subshell? So L equal to 1 means P subshell. P subshell are in the, already I told P subshell. That means L equal to 1 means what about N? N equal to 2. N equal to 2 means total how many electrons are there? 8 electron. 8 electron, how it is split? 2 comma 6. 2 is belonging to S subshell. 6 is belonging to P subshell. That P subshell having the how many orbital? 3 orbital. Those are called P subshell having the how many orbital? 3 orbital. The 3 orbital is each one is 2, 2, 2. That's why 6 electron. 6 electron. Next one. L equal to 2. L equal to 2 means which subshell? D subshell. So D subshell means how many electron? 2 into 2, 4, 4 plus 1, 5. That means that is equal to 10 electron. That is equal to which subshell? D subshell. Next one. Next one. L equal to 3, last one. L equal to 3, L equal to 3 means substitute here. 2 into 3, 6, 6 plus 1, 7, 7 into 2, 14 electron. That means L equal to 3 means 14 electron. 14 electron means which subshell? Which subshell means that L equal to 3 means F subshell. Observe here clearly. L is equal to 0, that means N equal to 1. N equal to 1 means first orbit. First orbit means how many electron? 2 electron. The 2 electron will occupy which orbital? Which subshell? S subshell. Now N equal to 2, total how many electrons? 8 electron. 8 electron means how many orbitals are there? 4 orbitals are there. 4 orbital means how many electron now? L equal to 1 means 6 electron. 6 electron means which subshell? P subshell. So that means 2 comma 6. 2 is belonging to S subshell. 6 is belonging to P subshell. Now N equal to L equal to 1. Sorry, L equal to 2. L equal to 2 means what about N? N equal to 3. N equal to 3 means total how many electron? 18 electron. 18 electron means this already completed. 2 is belonging to S, 6 is belonging to P, remaining 10 is belonging to D, D subshell. That means 10 electron means how many orbital is required? Orbitals are present D, 5 orbital. Next again, last one. L equal to 3, total 14 electron. Which subshell? F subshell. L equal to 3 means what about N? N equal to 4 because N minus 1, 4. Total how many electron? 32 electron. 32 electron means 2 is belonging to S subshell, 6 is belonging to P subshell, 10 is belonging to D subshell, remaining 14 is there. 14 is belonging to F subshell. F subshell. F subshell means how many orbital? 7 orbital. So 7 into 2, 14. Finally, what I have to conclude? Each orbital can accommodate maximum number of electrons are 2 only. That's all. Right? Next, important and significance of azimuthal quantum number. Principal quantum number indicates size and energy. Now this indicates shape, this significance. So azimuthal quantum number significance or indicates shape of the orbital. Orbital, different types of orbitals are different subshells are there. S, P, D, F. S orbital shape is spherical. P orbital shape is dumbbell. D orbital shape is double dumbbell. F orbital shape is somewhat complex. Till now they are not given the shape. Like that you have to say the shape. Different shape. Shape and orbital angular momentum. orbital angular momentum of an electron. Orbital angular momentum of electron. That means this indicates, which indicates, azimuthal quantum number indicates shape of the orbital and orbital angular momentum. So orbital angular momentum, how to calculate? This point based on that, one of the time they asked the question. Orbital angular momentum of an electron is equal to root over L into L plus 1 into h by 2 pi. That means h by 2 pi is outside of the square root. L into L plus 1 is inside of the square root. Root over L into L plus 1 into h by 2 is called orbital angular momentum of an electron. Just I will ask one question. What is the orbital angle? Which of the following option is correct for the orbital angular momentum of p subshell? That is the question. P subshell. What is the which of the following option is correct for the orbital angular momentum of p subshell? P subshell means here what is the formula orbital angular momentum? Root over L into L plus 1 into h by 2 pi. P subshell L value is how much? P subshell L value is 1. That means L equal to 1. Substitute 1 value. Root over 1 plus 1 into h by 2 pi. That means 1 plus 1 2. 2 into 1 2. That means root 2 h by 2 pi. This is the answer now. This is the answer now. Otherwise, sometimes they will give you multiply and divide by root 2. That means what happened? Root 2. 2 roots means root 2 whole square. That means 2 h by 2 into root 2 into pi. 2 into root 2 into pi. 2 cancel. Then what happened? H by root 2 into pi. Sometime like that they will give you. Multiply and divide by 2. Numerator and denominator multiplied by root 2. Root 2 means root 2 whole square. That means 2 only will be there. 2h. Then again what is there? 2 root 2 into pi. 2 cancel. H by root 2 into pi. Like that question they will ask. This is the information about what you call. This is the information about azimuthal quantum number. Next one, magnetic quantum number. Magnetic quantum number. Magnetic quantum number proposed by Landé. It is representative symbol is M or ML sometimes. M suffix L, that is M or ML. Right? Small m, not capital. All are small letters only. Next point. M is depends on. Next point. M is depends on L. L is depends on N. Without L value there is no M value. That's why M value depends on L. M is range from, this is the important point. M is range from minus L to plus L. M is range from minus L to plus L. That means M is range to minus L to plus L. For example, observe here, L equal to 0. What about M value? M equal to 0 because minus L to plus L, minus 0 to plus 0. Okay. Now L equal to 1. What is M value? M equal to minus L to plus L. That means minus 1 to plus 1. Minus 1 to plus 1 means that is the meaning. Minus 1, 0, plus 1. Next one. L equal to 2. L equal to 2 means M is minus 2 to plus 2. That means minus 2, minus 1, 0, plus 1, plus 2. L equal to 3, M value is minus 3 to plus 3. So, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Total how many values are there? 7 values. How to know, sir? So, total number of M values, how to calculate? Total number of M values is equal to 2L plus 1. This is the one of the formula. Total number of M values is equal to 2L plus 1. For example, L equal to 0. What is the M value? 0. Total 0. 0 into 1. 0, this plus 1. That means M value is 1. So, 1. That is 0. Now L equal to 1, substitute here, 2 into 1, 2 plus 1, 3, that means M value total M value 3, what are those? Minus 1, 0, 3, that is what? 3. Now when L equal to 2, substitute here, 2 into 2, 4 plus 1, 5, those are 5 values, minus 2, minus 1, 0, plus 1, plus 2, total how many values? 5. L equal to 3, 2 3 is 6, 6 plus 1, 7, what are those? Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, 4, 5, 6, 7, total 7 values. Like this you have to find. Those are M values, right? Now, I told you, this L equal to 1 means which subshell I told before, which subshell I told? P subshell, L equal to 1. L equal to 2 means which subshell I told? D subshell. L equal to 3 means which subshell I told? F subshell. P subshell having the how many orbitals? 3 orbital. That is what? Minus 1, 0, plus 1. What are those? Already we know. Px, Py, Pz. What are these? D. What are those? These already you know. dxy, dyz, dzx, dx square minus y square and dz square. These are called 5 orbital. 5 orbital. These are the 5 orbital. These are the 3 orbital. So those are what? Px, Py, Pz. So these values are independent. That means Px value is we don't know exact value. That's why you can say minus r plus 1. Py also minus r plus 1. But compulsory Pz value is 0. M value of Pz is 0. M value of Px and Py is minus r plus 1. Now in this case, M values dxy, dyz, dzx, dx square minus y square, dz square. Compulsory dz square or dg square is M value is 0. Remaining, what is there? Minus 1, minus 2, minus 1, plus 2 plus 1. That means this may be minus r plus 1, minus r plus 2. Otherwise, minus r plus 1. This also same. Minus r plus 2, minus r plus 1. This also minus r plus 2 or minus r plus 1. But dz square value is 0. Don't bother about this one. Then sometime one of the time they ask the question is what the M value of dz square? 0. What is the M value of Pz is 0. That you have to remember. So some other explanation is there, is not required now here. Okay, right. Now the significance, what is the importance? Importance or significance of magnetic quantum number is orientation. Orientation of the orbital in a space. Orientation of the orbital in a space. Orientation of orbital. Orbitals are there. What are these? S orbital, P orbital, D orbital, F orbital. So most of the orientation of the orbital observed in SP, DF orbital. Orientation means that is called direction. For example, P orbital I will take. P subshell having 3 orbital Px, Py, Pz. This which orientation? Orientation means direction. This is x direction, this is y direction, this is z direction. Both all three are different direction. That is called different orientation. Orientation, different direction is given by which quantum number? Magnetic quantum number. So in case of dxy, dyz, dzx, dx square minus y square and dz square. This orientation is in between x and y. This orientation is y and z. This orientation is z and x. This orientation is x in between x and y. This orientation is only z axis. That is called orientation. That is called direction. This is given by which quantum number? Magnetic quantum number. And last and final one, spin quantum number. The spin quantum number is represented by symbol is small s, not capital S, small s. That means all quantum numbers are represented by small values, small letters only, small s. This is proposed by Gaudsmit and Uhlenbeck. Gaudsmit and Uhlenbeck. Minus half, plus half and minus half. There is no relation. Both are independent. Okay. Now next point. Here important significance. The significance is spin orientation. It indicates spin orientation or spin direction. Otherwise direction of the spin. Direction of the spin in orbital. Direction of the spin, direction that is called orientation. What of orientation of the spin? That spin is, one is clockwise direction, other one is anti-clockwise direction. Clockwise direction means positive, that means upward direction, that is clockwise direction. This is called anti-clockwise direction. For example, I will take one orbital like this. Orbital can accommodate how many electron? 2 electron. I got 2 electron. The 2 electron means one is upward direction, other one is downward direction. Right? This upward direction is equal to plus half, downward direction is minus half. Not exact, that is not plus half minus half. That means this may be plus or minus half, this may be plus or minus half. That is the meaning of independent. Dependent means this compulsory plus a half, this is compulsory minus half. Not like that. That means independent means this may be plus or minus half, this may be plus or minus half, any value. That is the meaning of. That means this is clockwise direction, this is anti-clockwise direction. Upward is called clockwise direction, downward is called anti-clockwise direction. Right? This is called, these 2 electrons are there, one is upward, other one is downward. This is called a spin paired. Spin paired. This is only our requirement. This spin paired, upward and downward. Like this will be there sometime, like this will be there sometime. This is called, these two are called spin parallel. Spin parallel, this we will not consider. This we will consider, that is called spin paired. These are called spin parallel. Now this is called unpaired. Single electron is called unpaired. This already anyway you know, just again I am giving like information. Spin paired, opposite direction, same direction either upward or downward direction is called spin parallel. This one upward or downward but single electron, that is called unpaired electron. This is the information. So based on this you are going to calculate spin angular momentum. Spin angular momentum is equal to root over s into s plus 1 into h by 2 pi. Spin angular momentum of an electron is equal to root over s into s plus 1 into h by 2 pi. This is spin, this is called orbital angular momentum. Orbital angular momentum is L, spin angular momentum is S. This is small s. So spin angular momentum how to calculate? Capital S is equal to n into half. Spin angular momentum how to calculate? S is equal to n into half. What is n? Because half means plus a half minus a half. What is n? N is equal to not principal quantum number. Here in this case number of unpaired electron. Not paired. Unpaired electron. Unpaired electron means single electron, that is called unpaired electron 1. So for example, I will take like this. This is called p subshell. These are the 3 orbital. I am giving like this 2 electron. These 2 are the unpaired. Now n equal to 2. Here n equal to 1. N equal to 2 means substitute here. 2 into 1 by 2, that means s is equal to 1. That value you have to substitute here. Now n equal to 1. N equal to 1 means 1 into 1 by 2. Right? So 1 into 1 by 2. So this value you have to substitute here, then you will get the spin angular momentum. This is the information about quantum number, all 4 quantum number. So these all quantum numbers using some other concept I am going to say. After that concept I am giving some questions, then you have to do. Right. Now, energy of the orbital, next concept. Energy of the orbital, next concept. Energy of the orbital, that means electrons means I will take orbital. In this orbital, s orbital means s subshell, p subshell, d subshell, f subshells are there. On that subshells, how to fill the electron? How to fill the electron? That is only that explained by concept is energy of the orbital. That means filling of the electrons in the orbitals. We should follow some rules. What are those? 3 rules we are having. What are the rules? One is Aufbau rule, that means Aufbau principle. Second one is Hund's rule, that's why Hund's principle. Third one is Pauli's exclusion principle. Pauli's exclusion principle. One of the time match the following they are given. So now three principle, two principle definition they are given. Remaining two some other one they are given. Match the following they are one of the time. Right? So rules we should know first. Aufbau rule, Hund's rule and Pauli's exclusion principle. First one. This is mainly filling of the electrons. We should follow mainly total three rules. But by using these two rules are enough to filling the electron. It's just normal definition we want. Then observe clearly what is Aufbau rule, what is Hund's rule, what is Pauli's exclusion principle. Right. Aufbau rule first. In the ground state atom, filling of the electrons in an orbital, by their increasing order of their n plus L values or energy values. Energy value is called as n plus L value, is called as Aufbau rule. Once again observe clearly. In the ground state atom, filling of the electrons an orbital, filling of the electrons in an orbital by their increasing order of their n plus L value. N plus L value is called energy. That means increasing order of energy values. Increasing order means, that is the meaning, lower energy level to higher energy level. That is the meaning. Lower energy means lower n plus L value to higher n plus L value. That is the meaning of this point. That is the rule. So this can be explained by using one diagram. The diagram is called as Euler diagram. Observe clearly. Now this is very important. This is useful for every chapter. This is most of the important for D and W block element. Now if you know this one, D and W block periodic classification also. Sometimes they will have the electronic configuration, atomic number. So that's why that you want to know more compulsory, you should know this Aufbau rule. Right. Now n is equal to 1, first orbit. First orbit means just only s orbital is present, that is what, 1s. Now n equal to 2 means observe here 1, 2, 3, 4 and so on. First orbit, second orbit, third orbit, fourth orbit. First orbit what is present? Only s. Second orbit what is present? S and P. Third orbit what is present? S, P, D. Fourth orbit what is present? S, P, D, F. The fifth orbit S, P, D, F, G, like that. These are the subshells are present. That means n equal to 1 means just 1s is possible. N equal to 2, second orbit, 2s to 2p. N equal to 3, S, P, D, that means 3s, 3p, 3d. N equal to 4, that is 4s, 4p, 4d and 4f. Very important number. So many times they ask the question now. Very important. Increasing order of energy levels. You should know this one. Then how to do, how I am doing this. These only questions only now. Observe clearly. Now n equal to 5, that is what? 5s, 5p, 5d, 5f, again 5g, that is not there, that leave it now. 6, 6s, 6p, 6d, 6f, like that. 6d something is there, 6d, 6f something is there, that leave it now. 6h not f, g and h, leave it. Last one is 7s, like this, 7s, 7p, like this, that is enough now. Right. So what a rule? In the ground state atom, filling of the electron an orbital by their increasing order of n plus L value. First you should calculate n plus L value for all. N plus value. N means orbit, L is orbital, means subshell. Right. Here n equal to how much here? 1. L is equal to how much here? Because which orbital is there? Which subshell is there? 0. What do you call S subshell? S subshell value 0. So that means this value 1 plus 0, 1 plus 0, that means 1. Next one, this n plus L value, n value 2, L value 0 because S sub shell, that means 2. This one 2, n value 2, L value P sub shell because I will write once again. L equal to 0, L equal to 1, L equal to 2, L equal to 3. That is S, P, D, F. Before I told S sub shell, P sub shell, D sub shell, F sub shell. N values are number, principal quantum number, numbers now. So, P sub shell L value 1, 1 plus 2, 3. S sub shell L value 0, 3 plus 0, 3. This is 3 plus 1, 4. 3 plus 2, 5. What are these 3, 4, 5, n plus L value? Now here 4 plus L value 0, 4. 4 plus 1, 5. 4 plus 2, 6. 4 plus 3, 7. Now 5, n value 5, L value 0. 5 plus 0, 5. 5 plus 1, 6. 5 plus 2, 7. 5 plus 2, 8. Now here 6, L value 0, 6 plus 0, 6, 6 plus 1, 7, 6 plus 2, 8, 6 plus 3, 9. Now here 7 plus 0, 7. These all are n plus L value I written now, right? Now what is the rule? By their increasing order of n plus L value, that means lower n plus L value to higher n plus L value, that is the meaning. Lower n plus L value is the lower energy, higher n plus L value is the higher energy. That means lower energy to higher energy. First one, in this all, which one is lower n plus L value? This one. So, electrons are filling in the first one is lower energy, that is what? 1s. This is lower energy. Next one, 1s after next n plus L value is 2. Next one after 1s it is moving to 2s. I got 2s. In these two, 1s and 2s, which one is the lower n plus L value? 1s. Which one is the higher n plus L value? 2s. That means which one is lower energy? 1s is lower energy, 2s is higher energy. This is called increasing order. Next one. After 2, it is moving to next n plus L value 3. Observe now 3. Very important point here. N plus L values are same here. 2p and 3s. Clearly observe now. I am writing clearly. 2p and 3s. N plus L value how much here? 3. N plus L value how much here? 3. That means n plus L value. Both n plus L values are same now here. Then the electron enter into the which value? Means which orbital? That is the doubt. If n plus value, if both orbital having the both subshell having the n plus L values are same, then electron entering into the lower n value. Electron enter into the lower n value is the first. Lower n value. Lower n value is the lower energy. Higher n value is the higher energy. Now in these two, 3 n plus L value is same. Electron enter into the lower n value. N value observe now. Here n value is how much here? 2. Here n value how much here? 3. Which one is the lower n value? 2. That's why electron enter into 2p. Next one move to 3s. In these two, which one is the higher energy? Which one higher n value? N plus L values are same. We can't decide now based on the n value. Lower n value is 2, that is called lower energy. Higher n value is the 3, that is called higher energy. In these two higher energy, which one? 3s, like this. Now that means electron enter into 2p and 3s, 2p and 3s. Very important. Next one. It move to next n plus L value. 3 completed. Move to 4. 4 again. What is there? 4s to 3p. Because n plus L values are 4. 4. Which one lower n value? Both n plus L values are same. Electron enter into the lower n value. Lower n value is the lower energy. Higher n value is the higher energy. In this which one lower n value? This one. 3p. So electron enter into the 3p. Next move to 4s. So 3p is lower energy, 4s is higher energy, like that. Next one. 3p, 4s. Next two. 5, very important. So 5 what is there? 3d, 4p, 5s. These three are there, 5. That means these are all 3d, 4p, 5s. These are only questions. increasing order, decreasing order of energy level. These only questions. Like these different orbital or different subshell, they will give you. Write the increasing order, decreasing order of energy levels. So many times they ask the question. This is also chance is there now. Observe now. 3D, 4P, 5S. Write the increasing order of energy level. So first you have to find, first depends on n plus L value. If n plus L value is same, then move to n value. That is only point. First n not n plus L, not like that. First n plus L value followed by n only. If n plus L value is same, then move to n value, like that, right. N plus L value how much here? 5, 5, 5. That means n plus L values are same. Then that depends on n value. Lower n value is the lower energy, higher n value is the higher energy. 3D, 4P, 5S. 3D, 4P, 5S. Which one is the lower n value? 3D. That means electron enter into 3D first. Next to 3D after 3, next to 4, next to 5. That means next to 4P, next to 5S. In these three, which is higher energy? 5S is higher energy because higher n value. Which is lower energy? Because 3D, because lower n value. When n plus L values are same. That means, so 3D, 4P, 5S. Next 6. 6 what is there now? 1 second observe 6. Last I will tell you. 4D, 5P, 4D, 5P and 6S. That means this is 6, this is also 6, this is also 6, then plus L value 6. Lower n value which one? 4. That means electron enter into 4D first, next to 5P, next 6S. In these three, which is higher energy? 6S, because higher n value. Which is lower energy? 4D, like this. So this is the rule you have to follow. The next one 7, 7 like this. 7, 7, 7, 7. Which one lower n value? 4. Next to 5, next to 6, next to 7, like this. That means 4F, 5D, 6P, 7S. No need to remember. If you remember like this value, n plus L value. If n plus L values are same, electron enter into the lower n value first. Lower n value is the lower energy, higher n value is the higher energy. This is called which rule? Abbo rule. Next one, Hund's rule. Hund's rule. Hund's rule is applicable for degenerated orbital. One point, degenerated orbital. Degenerated orbital. What is meaning of degenerate orbital? Orbitals which are having the same n and L values. N and L values are same. Those are called degenerated orbital. Most of the degenerate orbital will observe in P, D and F subshells. That means for example 3P subshell having how many orbital? 3. What are those? 3Px, 3Py, 3Pz. Right? This n value how much here? 3. That means n is 3 for all. What about L value? Px, Py, Pz. L value is subshell, what do you call? L equal to 0. Sorry, L equal to 0 means S subshell. L equal to 1 means P subshell. L equal to 1 for all. That means n value is same, L value is same for all. That is called degenerate orbital. When degenerate orbital, filling of the electrons. First, for example, I will take like this. One of the degenerate orbital, that is called P subshell, Px, Py, Pz. These are having the 3 electrons are there and 4 electrons are there. P3, P4. First, what you have to do? In degenerate orbital, filling of the electron, first single electron will be occupied. I am saying the definition of this Hund's rule. Filling of the electrons in degenerated orbital, first single electron will be occupied, then after pairing will takes place, is called as Hund's rule. Once again, filling of the electrons in degenerate orbital, first half filled, then pairing will take place. First half filled means first each orbital can accommodate single electron, means single occupied one electron, and after pairing will takes place. That is only called Hund's rule. Observe here. P3, first one, these are all are in the same energy. That means we should give the priority for same only now. One electron here, one electron here, one electron here. This is one of the way representation. Second representation, observe now. 1, 2, 3. That means here pairing and again moving. So in these two, which one is correct? Which representation is correct? Like this diagram, they will, one of the time they are given diagrams. Which of the following representation is correct? They ask. So in these two, which one is correct? This one is correct. This one is wrong. Why? Because of Hund's rule. First half filled, then pairing will take place. In case of which orbital? Degenerated orbital. Observe now. Once again P4. P4 means 1, 1, 1. First single electron occupied. So half filled completed. That means P3, 3 orbitals are there. Fourth electron pairing will take place. This is only one of the representation. Second representation 2, 2. So this is not possible. This is possible like this. First half filled, then pairing will take place. In case of D, that is called D5 and D6. D is subshell how many orbital? 5. 1, 2, 3, 4, 5. dxy, dyz, dzx, dx square minus y square, dz square. 1, 2, 3, 4, 5. Other representation 1, 2, 3, 4, 5. This is correct, this is wrong. Because half filled, single electron occupied as per Hund's rule. Last one is, it is pairing is takes place, this is wrong. Like this D6 also. 1, 2, 3, 4, 5. Last one is, sixth one is pairing will takes place. Now 1, 2, 3, 4, 5, 6. This is possible, this is not possible. That is called which rule? Hund's rule. Next one, final one. Final one, which one? Pauli's exclusion principle. Just I will say the definition only now, right? No two electron in atom. Pauli's exclusion principle definition I am saying now. No two electron in atom can have no two electrons in an atom can have the same set of all 4 quantum numbers is called Pauli's exclusion principle. Once again definition. No two electrons in an atom can have the same set of all 4 quantum numbers is called Pauli's exclusion principle. So based on that, I am giving some question to you. Previous year questions based on this concept, very very important, right? Now I am giving one question to you, then do the question now. One of the year they ask, the number of electron present in, the number of electrons present in all the completely filled subshell having n equal to 4 and s equal to plus half. This is the question. What is the question they are asking? One of the time they ask one of the NEET. Number of electron present in all the completely filled subshell n equal to 4 and s is equal to half. Number of electrons how to calculate? By using n. So I told a formula 2n square where n equal to 4 here. 2 into 4 square, that is equal to 4 4 is 16, 16 into 2, 32 electron. Okay, that is correct only. But here some other hint is given. What they given? S is equal to plus half. 32 electron means how many orbital we need? 16 orbital we need. So each orbital having the 2 electron. 2 electron means one is plus a half, other one is minus a half. Plus a half and minus half, they are asking only plus a half. Plus a half means how many electron? 16 electrons. So answer is 16. Next question. Orbital angular momentum of an electron. Orbital, very important question is. Orbital angular momentum orbital angular momentum of an electron in 3s and 3p orbital. 3s and 3p, different question is. Now I am giving combining. 3s first you have to calculate 3s and 3p. 3s and 3p orbital, for 3s orbital is xh by 2 pi. For 3p orbital is root over x into h by 2 pi. What is the x value? Find the x value. That is the question. Observe question. Orbital angular momentum of an electron is electron of 3s and 3p. 3s is xh by 2 pi. 3p is root over xh by 2 pi. Find what is x for 3s and 3p. So, orbital angular momentum of an electron is formula root over L into L plus 1 into h by 2 pi, outside of the root h by 2 pi. Now, first one I am going to calculate 3s orbital. 3s orbital L value is 0, means anyway s orbital anyway 0 only, n value 3, we do not want n, substitute here. 0 plus 0 plus 1, so answer is what? 0 plus 1, 1, 1 into 0 total h by 2 pi, that value is what? Total 0. That means x h by 2 pi, this is x, x into 0 h 2 pi, the total value is 0. That means this x value is 0 in case of 3s. In case of 3p, 3p means L equal to 1, substitute 1 into 1 plus 1. So, 1 into 1 plus 1, 1 plus 1 2, 2 into 1 root 2, root 2 h by 2 pi, root 2 h by 2 pi, that means that is equal to what? Root x h by 2 pi. So, what is x? X equal to root cancel, x equal to 2. In case of this one x equal to 2, in case of this one x equal to 0. Like this you have to do the calculation. Right. Next one question. This is the question. 4D, sir, 4D, 5F, 6P, 4D, 5F, 6P and 5P. 5P. Write the decreasing or increasing order of energy levels. That is the question. Very important. So, decreasing order we have to write first. So, different orbital they are given. Increasing or decreasing order. This is follows above rule before I told. So, first we find n plus L value. N is equal to 4. So, n plus L value I am finding now. N value 4. L value. So, then if you do not know, then you can write L equal to 0, 1, 2, 3. This is S, this is P, this is D, this is F. Right. N value 4, okay. L value, which orbital? D orbital is there. D orbital means 2. 4 plus 2, 6. Now 5F. N value 5. F value 3. 5 plus 3. So, how much here? 8, this is 6. Next, 6p, 6, n value 6, p value L equal to 1, 6 plus 1 that is equal to 7. Next one, this is 5, p value 1, that is what? 6, right. In this n plus L values are 6, 8, 7, 6, that means n plus L value, different n plus L value. So, what is the rule? Increasing order of n plus L value. In this higher n plus L value, which one? 5F. Higher n plus L value is higher energy, lower n plus L value is lower energy. Okay. 6, 7, 8, which is highest n plus L value? 8. That's a 5F first. Next one, 8 belongs to 5F. Next one, 7. 7 belongs to what? 6P. In these two, which one? 5F is more energy level than 6P. Okay, this is over now. In this case, 4D and 5P, these n plus L values are same. Both n plus L values are same. What I told? Lower n value depends on n. Lower n value is the lower energy, higher n value is the higher energy. In these two, n value is 4. In here, n value is 5. Which one is lower n? 4D. Which one higher n? 5P. That's why higher energy which one? 5P. Lower energy which one? 4D. This is the answer. This is called decreasing order. Very, very important. Like this, you have to do the question. Right, last one point, Amma. Just one question I will tell you. Radial node and angular node. One of the time they ask a question. Radial nodes and angular node. Radial node, how to calculate? N minus L minus 1. Angular node, how to calculate? L. Radial nodes are N minus L minus 1. Angular nodes are L. So, one example I will give you. One of the example is 7s and 7p. Okay, these two example. Right. Radial node. How many radial node for 7s? So, radial node formula N minus L minus 1. What is N? N is equal to 7. What is L? L value for s orbital is 0. 7 minus 0 minus 1. How much here? 7 minus 0, that is what? 6. That is called radial node. How many radial node for 7s orbital? 6 is there. Now 7p observe now. 7p radial node, 7p, L value is 1 minus 1. So minus 1 minus 1 minus 2, minus 2 plus 7, that is equal to plus 5. These are called radial node. In case of angular node, 7s to 7p. Angular node formula L. So in this L value, s orbital L value 0. That means angular nodes are 0 for 7s orbital. 7p angular node, L value is p orbital is 1. That means 1. So this is the answer. These are called angular nodes. These are called radial node. One of the time they ask the question. Radial node and angular nodes. Like this, you have to do the calculation. Okay, ma? Today I will stop this. Now tomorrow I will start the remaining other concept. Okay, thank you.
So good morning students again. In the yesterday we have started the fresh chapter, that is photosynthesis in the higher plants and the related discussion going on. Yesterday I have covered the different scientists and their contributions and we have entered into the first phase of the first phase of the photosynthesis, that is light reaction. Related to the light reaction, I told you there are two types of ATP synthesis is there. One is a cyclic photophosphorylation, another one is a non-cyclic photophosphorylation. So what is meant by photophosphorylation? It is a synthesis of ATP in the presence of light, which is related to light reaction. And what is a light reaction? It is all about absorption of light, splitting of water, releasing of oxygen and synthesis of ATP and NADPH. So now if you focus on this, related to light reaction, I am saying the non-cyclic photophosphorylation. So this non-cyclic photophosphorylation, it is going to happen within the grana because it requires both photosystem 1 and photosystem 2. Imagine this is a thylakoid membrane. On the thylakoid membrane, the process going to be happen like this. The process is going to be happen here. So here first PS2, which is having P680 will be activated, transferred its electron to the pheophytin, which is located towards outer side of the membrane. This is going to give the electron to PQ. PQ is generally a hydrogen carrier, not an electron carrier. PQ, by accepting the electron and also the proton, it will become PQH2. How comes the proton from? The proton is coming from the stroma part. Remember, outside the thylakoid membrane, that is going to be the stroma. Inside the thylakoid membrane, this is going to be called as what? Lumen. Now, this PQH2, the electron will be given to the cytochrome B6F complex. After giving electron to cytochrome B6F complex, this is releasing protons into the lumen. Then again it will become what? PQ. PQH2, by releasing protons to the lumen and electrons to cytochrome B6F, it is becoming PQ again. So the cytochrome B6F complex releases its electron to a mobile electron carrier called as PC, plastocyanin. From this plastocyanin, electron will be given to the P700, which is photosystem 1. From here, it is going to accepted by primary acceptor of the PS1, that is FD, I mean by ferridoxin. The ferridoxin going to give its electron to FNR, ferridoxin NADP reductase, so that this is going to give the electron to the NADP plus. NADP plus with the help of FNR accepting two protons, so that it will become NADPH plus H plus. So here you have to understand what is the location of the FNR enzyme. The enzyme is located towards the stroma and synthesis of NADH also happening within the stroma. Now, this process results in the NADPH, okay. Where does the water splitting going to happen? That is related towards the lumen side, inner side of the membrane, that is located to PS2. So water splitting is associated with the PS2, where H2O will be broken down into 2H plus half oxygen. Now, this entire process going to create the synthesis of ATP. How the synthesis of ATP? This is going to explain with the help of chemiosmotic hypothesis. Chemiosmotic hypothesis. Now, this chemiosmotic hypothesis explains about synthesis of ATP by this process. So, it is all about creation of the proton gradient. Creation of the proton gradient and breakdown of the proton gradient. What is meant by proton gradient? It is a variation in the concentration. Below to the membrane, concentration of proton will be increased. Outside the membrane, concentration of proton will be decreased. So that what we can say here, the proton gradient formation and breakdown of proton gradient, that yields the ATP, which is going to be synthesized in that particular thing. Now, if you focus on this, how to create the proton gradient? Already 3 steps we have discussed. Those 3 steps in this connection we have to say here. Observe. First step in increasing the proton concentration, breakdown of water, this is a point A. which is below to this chemiosmotic hypothesis. 3 points are there in the textbook. The point A is breakdown of water that results in the release of H plus ions, which are protons into the lumen. This is first thing. Second thing, this is the point B, where with the help of PQ, because of movement of the protons, H plus ions from the stroma transferring into the lumen. There they said one point, the pheophytin transfers the electron not to electron carrier but to a hydrogen carrier. For every electron it is passing through, it is carrying one proton. Total how many electrons are moving? 2 electrons. So the 2 protons are getting transferred here. From the stroma, with the help of PQ, the protons are moving across the membrane and entering into what? Lumen. This is the point B. The point C is here. The FNR enzyme located towards the stroma, so that it is catching up the electrons to NADP plus, so that it is combining with the H plus ions, it will become NADPH. This is the step that decreases the H plus ions in the stroma. This is the step that decreases H plus ions in the stroma, increases in the lumen. This is a step that is contributes to the increase in the H plus ion concentration in the lumen. So that what we can say, concentration of H plus ions are increased in the lumen, concentration of H plus ions are decreased in the stroma. That results in changes in the pH. If you observe, the pH will be decreased because more H plus ions means more acidic concentration below to 7. So pH is decreased here. Outside the thylakoid membrane, pH will be increased. Now the gradient is formed. I told you gradient means variance in concentration. Here high concentration, here low concentration. Now how to synthesize the ATP? By breakdown of this gradient. How to break this? There is a complex called ATP synthase. I am repeating, ATP synthase. It contains 2 parts. One is CF0, another one is CF1. So CF0 is an integral membrane protein present within the thylakoid membrane. It is a peripheral membrane protein present outside the thylakoid membrane. So this CF0 is a transmembrane channel. Channel means it is a pipe that allows the movement of the H plus ions. And the catalytic site is a site where ATP is going to synthesize. The catalytic site is the CF1. So it is integrated in the membrane, acts as a transmembrane channel. It is a peripheral membrane protein. It is going to act as a catalytic site for the synthesis of ATP. Now these H plus ions will move through the CF0, passing through the CF0, they will enter into the stroma back. Why? Because of this movement that gives the conformational change in the CF1. Conformational change means it is going to rotate here and there, it is going to rotate. That gives the energy for the formation of the ATP. Because of movement of H plus ions, this undergo conformational change, which will donate the energy to the ATP from the ADP plus inorganic phosphate that leads to synthesis of ATP. Now this particular above thing, we call it as a Z scheme because of this characteristic shape. Where it is occurring? That is occurring on the thylakoid membrane, that involves PS2 and also PS1. So this is a non-cyclic procedure, and this entire procedure we call it as a chemiosmotic hypothesis. The chemiosmotic hypothesis explains about synthesis of ATP by the creation and breakdown of the gradient. This chemiosmotic hypothesis to synthesis of the ATP, it requires some properties. One is it requires a membrane, in this case it is a thylakoid membrane. It requires a gradient which is formed because of movement of electrons, and it requires a proton pump. The PQ is acting as a proton pump, and it requires a ATP synthase enzyme. These are the requirements for the chemiosmotic hypothesis. Next, let me move the non-cyclic photophosphorylation. This non-cyclic photophosphorylation is going to happen when light beyond 680 nanometers is available. Light beyond 680 nanometers. At that condition, only PS1 is functional. PS2 is non-functional because its maximum capacity is only below to 680 nanometers. And only PS1 is present location. The location is going to be the stroma lamella. The location is going to be stroma lamella. I told you in grana both PS1 and PS2 both are there. That's why in the grana what is happening? Non-cyclic photophosphorylation. But only PS1 is present. The location is stroma lamella. And one more thing, in this stroma lamella PS2 PS2 and FNR, NADP reductase enzyme, both are absent, such that it is going to undergo only cyclic photophosphorylation in the presence of PS1. How it is going to happen ma? PS1 is there when the light fallen on this, which light ma? 700 nanometers of light, which is beyond the 680 nanometers. The electron in the PS1, the reaction center chlorophyll A, will be excited and it is accepted by the primary electron acceptor, that is FD. Ma, this FD generally it has to give the electrons to FNR. FD in the general it will go to the FNR, but here in this condition FNR is absent because the location is stroma lamella. Instead of electron from FD entering into FNR, it will take the U-turn, again it is coming back to the PQ. Again it is coming back to the PQ. So PQ do the same procedure ma. PQ by accepting the electrons and protons from the stroma, it will become PQH2. This PQH2 is giving its electron to cytochrome B6F. After releasing the electrons, it is releasing protons into the lumen. This is stroma lamella. This from this cytochrome B6F, the electron will be gone to plastocyanin. From the plastocyanin, electron will come back to again the PS1. So PQH2 by donating electrons and protons, again it will become what ma? PQ. So overall this is the cyclic photophosphorylation that is occurring beyond 680 nanometers of light is available, where PS1 is the only functional photosystem without involvement of the PS2. The location is stroma lamella, where PS1 is only present. PS2 and NADP reductase enzyme is going to be absent. That is the thing. Now, in this entire procedure, PS1 electron will be excited by absorbing the light from the FD. Instead of entering into FNR, it will cycle back into the PS1. Now, if you compare both, in this both ATP and NADPH are synthesized. In this, here only ATP will be synthesized because of there is a formation of the proton gradient. Next, here PS1, PS2 both are involved. Here only PS1 is involved. Here there is a splitting of water and releasing of oxygen. Here there is no splitting of water and releasing of the oxygen. That is the logic. Then after saying that, these non-cyclic photophosphorylation helps in the synthesis of ATP and also NADPH. Here there is a synthesis of only ATP. So if you combine both, more who is synthesized, more ATP or more NADPH? If both are occurring simultaneously, ATP will be synthesized more than the NADPH, because the more ATP is required in the dark reaction. So I told you the products of light reaction will be utilized in the dark reaction. So the next step to discuss, in the textbook there is a heading, where does ATP and NADPH are utilized. So ATP and NADPH are utilized in the stroma of the chloroplast, where dark reactions are going to be happen. So I told you yesterday, dark reaction is a this biosynthetic phase that results in the synthesis of organic compounds like our glucose. Let me talk about the dark reactions. Dark reactions. But these dark reactions are also called biosynthetic phase reactions. Now if you observe, ATP and NADPH both are going to be utilized in dark reactions. These reactions are going to happen within the stroma of the chloroplast. And these reactions are also called as biosynthetic phase. Then after saying this, these dark reactions are of many types. For the first time, the person who has identified the pathway of the carbon within the plant body is Mr. Melvin Kelvin. So Mr. Melvin Kelvin is a scientist by using a radioisotope called carbon 14 in the experiment called algal photosynthetic experiment. algal photosynthesis experiment, he had explained this, and he told that first product in the dark reaction is a organic acid, that is a 3-carbon acid, 3-phosphoglyceric acid, and he worked out the entire pathway with respect to him, that is named as a Kelvin cycle. As the first product contains the 3 carbons, the cycle is going to be called as what ma? C3 cycle. Later there is extensive research happened and found that along with the 3-carbon compound producing plants as a first product, there are another group of plants are there which is producing 4-carbon compound. Those plants are called as C4 plants. So ultimately in the nature, majorly they are observing C3 and the C4 plants. Let me discuss about the C3 cycle. But the C3 cycle is a main pathway present in all photosynthetic plants. It is an important point. C3 cycle happens in C3 plants and also C4 plants and also any other group of plants. There is another group is there, CAM plants are there. So whatever the plant, if it is doing photosynthesis, the main pathway in the photosynthetic organisms to produce a glucose, that is going to be the C3 pathway, occurs in all photosynthetic plants. Remember this. In this, the main CO2 acceptor was ribulose bisphosphate, ribulose 1,5 bisphosphate. It is a kind of sugar, pentose sugar. This ribulose 1,5 bisphosphate is a primary CO2 acceptor, It is going to undergo the C3 cycle. It is containing 3 steps. One is carboxylation, reduction and regeneration. In the carboxylation step, the main enzyme that is going to involve here is rubisco, ribulose bisphosphate, carboxylase and oxygenase. Remember this rubisco enzyme having a active site, it can bind with the oxygen and also it can bind with carbon dioxide. That's why carboxylase and oxygenase activity is there. If it is binding with the carbon dioxide, it is doing carboxylase activity. If it is binding with oxygen, it can do what? Oxygenase activity. So who will bind? What will be decided? Who is more in concentration? If more CO2, it will bind. If more oxygen, it will bind to the rubisco. If both are in equal concentration, rubisco having more affinity towards what? Carbon dioxide. So in the C3 cycle, our rubisco enzyme combining with carbon dioxide, along with that in this reaction water is utilized, that leads to synthesis of a 3-carbon compound, that is a 3-phosphoglyceric acid. 3-phosphoglyceric acid. But this 3-phosphoglyceric acid contains a 3 carbons. So that it is a 5-carbon pentose sugar. 5 carbon plus 1 carbon, total 6 carbons. To balance that, here we are taking 2 molecules. So 2 molecules of 3-phosphoglyceric acid is synthesized. It is a first product. First acid is a 3-carbon organic acid. Remember this. Next, this is undergoing second step. The second step is called, this above step particularly is called as carboxylation. Carboxylation related is the most crucial step in the Kelvin cycle, that is involved in the fixation of the carbon dioxide. The next step, second step, is going to be called as reduction. Second step going to be called as reduction. In this reduction step, ATP is utilized and also NADPH is utilized. Somewhere we have seen this, no? These are the products of the light reaction and the process of C3 cycle happening in stroma. That's why observe the logic. ATP is synthesized towards the stroma, NADPH also synthesized towards the stroma. Water splitting happen within the lumen, remember that. So both products of light reaction, ATP and NADPH, are synthesized in stroma so that they can easily enter into the dark reaction. Especially here we are talking about the C3 cycle. So for every CO2 entering into the process, it is going to utilize 2 ATP and 2 NADPH. So the 2 ATP will become 2 ADP and 2 NADPH will become 2 NADP plus. These two are again entering into light reaction, that is a different story. So the point you have to remember, in the second step, that is reduction, for each carbon dioxide entering, 2 ATP and 2 NADPH are utilized for the process. This is for phosphorylation and this is going to be for reduction step. Next, that leads to the formation of a 3-carbon triose phosphate, that is glyceraldehyde 3-phosphate. What is going to form? Glyceraldehyde 3-phosphate will be formed in the next reaction. This is also a 3-carbon compound. So it is present in 2 copies. 2 copies of the 3-carbon compound is formed. Total 6 carbons. So this is the product of the reduction. In the textbook they mentioned it as a triose phosphate. Now this G3P will be utilized for the synthesis of glucose. G3P will be utilized for the synthesis of glucose. That glucose will be stored in the form of starch or transported in the form of sucrose. It can be stored in the form of starch or transported in the form of what? Sucrose. Now this G3P, glyceraldehyde triphosphate, will be utilized in the 3rd step, that is going to be called as what? Regeneration. So remember, it is a cycle where it has started, again it has to be entered into the same phase. So where it started with RUBP, again it has to regenerate. So in this regeneration step, there is a utilization of ATP. ATP utilized to form what? ADP. For one RUBP to synthesize, one ATP is utilized. So totally, how many carbon dioxide enter? 1 carbon dioxide. How many NADH utilized? The NADPH utilized are only 2. How many ATP are utilized? 3. So remember the 1, 2, 3 formula. For 1 CO2, 2 NADPH and 3 ATP. For 2 CO2, 4 NADH, 6 ATP, like that. Now if you observe the reaction properly, from this 6-carbon compound, at one cycle only 1 carbon is fixed. Only 1 carbon is fixed. For the glucose to form, 6 carbons are required. 6 carbons are required. For each cycle, 1 carbon is releasing. From the 6, 1 is releasing. How many remaining? 5. 5 will be regenerated here. I am repeating. Observe, G3P contains 3 carbons. 3 carbons, how many molecules? 2 molecules. So that how many carbons are there? Totally 6 carbons. 6 carbons in the 5 carbons will be utilized for the regeneration step. How many remaining? 1 carbon. For each cycle, 1 carbon is fixed. Like that, to synthesize the glucose which contains 6 carbons, how many cycles are required? 6 cycles are required. 6 cycles nalli 6 CO2. 6 CO2 utilized for the synthesis of 1 glucose molecule. 6 CO2 molecules means 6 turns of the cycle to required for the synthesis of 1 glucose molecule. At the same time, how many ATP? 18 ATP. How many NADPH? 12 NADPH are required. So for the synthesis of 1 glucose, these are the requirements. So this is all about the C3 cycle. Next, after saying that, C4 cycle is the next pathway. This C4 cycle occur in a special group of plants called as C4 plants. And remember, C4 plants are living in the high light intensities, high temperatures, and they are living in dry tropical regions. I am repeating, dry tropical regions which are high temperature regions containing high light intensities. So this C4 plants example, I told you a formula, mass. What is this mass? Maize, amaranthus, sorghum and sugarcane. I am repeating, maize, amaranthus, sorghum and sugarcane. Especially questions arise from this. Maize and sugarcane based on questions are most common. So remember, these are the examples for the C4 plants. In this C4 plants, what are the special features are there? So C4 plants special features, these are living in high temperatures, so that they can tolerate high light intensities. They can tolerate high light intensities. At the same time, they are having the special leaf anatomy. Special leaf anatomy is there. And along with that, these are having high productivity. High productivity. And these are having with no photorespiration. No photorespiration, that's why they are having the high productivity. So assertion and reason statement, C4 plants are showing high productivity because they lack the photorespiration. What is this special leaf anatomy? The special leaf anatomy in this case, it is called as Cran's anatomy. It is called as Cran's anatomy. What is mean by this Cran's anatomy? Cran's anatomy means if you take a vascular bundle that contains xylem and phloem. I have very consciously written above towards xylem, below is phloem, because I am talking about the leaf. In the leaf, these vascular bundles are surrounded by a special group of cells called as bundle sheath cells. Bundle sheath cells. These bundle sheath cells are arranged in the form of a ring. So, ring-like arrangement is there. So, surrounding to these bundle sheath cells, next group of cells are also surrounded. These are called as mesophyll cells. So, mesophyll cells forming a ring-like arrangement surrounding to this bundle sheath cells. This is called as what? Cran's anatomy. So, Cran's means ring-like arrangement. Ring-like arrangement of the mesophyll cells surrounding to the bundle sheath cells. This arrangement is going to be called as what? Cran's anatomy. This Cran's anatomy. Now, after saying this, the Cran's anatomy is a special leaf anatomy in case of the C4 plants. Now, after saying that, these bundle sheath cells are having some special features. Bundle sheath cells are having some special features. What are the special features of the bundle sheath cells? They are arranged without intercellular spaces. Without intercellular spaces. First thing. Second thing, they are having, thick walls impervious to gases exchange. Thick walls impervious to gases exchange. No gas will go inside, no gas will come outside. And these are having agranal chloroplast. This is very important point. These are having agranal chloroplast. Means in this bundle sheath cells, grana is absent, but inside the chloroplast only stroma will be there. That shows the chloroplast present here undergoing only dark reaction without undergoing the light reaction. That is the thing. Next. These bundle sheath cells are having thick wall without intercellular spaces, and they are having agranal chloroplast, and they are more in number. So, this is about the introduction. Let me see the process, how it is going to happen. So, this process here in this occurs in the two cells. Occurs in two cells. One cell is going to be the, bundle sheath cell. Another one is going to be the mesophyll cell. So, mesophyll cell and the bundle sheath cell. So, this is the first one is the mesophyll cell. And this is going to be the bundle sheath cell. So, in this mesophyll cell, C4 pathway will occur, whereas in the bundle sheath cell, C3 pathway will occur. Remember my point, C3 pathway occurs in all photosynthetic organisms. Whether it is a C3 plant or C4 plant, that doesn't matter. So, C3 is common for all. So, you can, I can say this in this particular way. C3 plants are undergoing only C3 pathway, but C4 plants are undergoing C3 pathway along with the C4 pathway, like this. So, C4 pathway occurs in the mesophyll cells, C3 pathway occurs in the bundle sheath cells. Now, in this C4 pathway, I forgot to mention, it is also called as a Hatch-Slack pathway, because they discovered it. Hatch-Slack pathway. In this mesophyll cell, the primary CO2 acceptor is phosphoenol pyruvic acid, PEP. This phosphoenol pyruvate, it is going to be primary CO2 acceptor, and it is a 3-carbon compound. Now, from the atmosphere, carbon dioxide is entering into this mesophyll cell, and it will become HCO3-. Both are undergoing fixation in the help of an enzyme that is called pepcase. Pepcase is the enzyme. Generally in this we are seeing Rubisco, but here it is undergoing what ma? Pepcase. So PEP, phosphoenol pyruvate, which is an acid, 3-carbon organic acid, is the first CO2 acceptor combining with HCO3 minus with the help of pepcase enzyme. That results in the formation of a 4-carbon compound called as oxaloacetic acid. As the first product in this process is the 4-carbon compound, that process is called as a C4 pathway or C4 cycle or Hatch and Slack pathway. This oxaloacetic acid will be converted into malic acid or aspartic acid. Malic acid or aspartic acid. Just if you think a little bit deeply, I am giving a connection here. In the C4 pathway, the first product is oxaloacetic acid. In Krebs cycle, the first member is oxaloacetic acid. In Krebs cycle, malic acid forms the oxaloacetic acid, but here oxaloacetic acid forms the malic acid. Don't confuse ma, focus on this first, later on we will look after that. So oxaloacetic acid is converted into either malic acid or aspartic acid within the mesophyll cells. These two are also C4 acids. This mesophyll cell, from that malic acid will be transported into bundle sheath cells. Malic acid will be transported into bundle sheath cells with the help of a connection. The connection is called as a plasmodesmata. So remember, formation of malic or aspartic acid occurs in mesophyll cells, and oxaloacetic acid is not entering into bundle sheath cell. Malic acid or aspartic acid will be transported. We call it as a C4 acid. This C4 acid undergo decarboxylation, removal of carbon dioxide, so that CO2 will be released. That leads in the formation of a C3 acid. That is nothing but pyruvic acid. Pyruvic acid is formed. This pyruvic acid later transported back into the mesophyll cells. And here it undergo regeneration, formation of the PEP. During this conversion, 2 ATP are required. That 2 ATP will be forming 2 ADP. That results in the formation of the PEP. Now come back, this C4 acid after releasing CO2, it is becoming C3. So what is the fate of this CO2? This CO2 is entering into cycle, which pathway? C3 pathway, where in this Rubisco enzyme is present. Rubisco enzyme will accept this with the help and combining with the RUBP, that leads to synthesis of what? Glucose. So glucose will be synthesized in mesophyll or bundle sheath cell in the bundle sheath cell. Let me compare this. Two kinds of cells are there. One is mesophyll cell, another one is bundle sheath cell. Here C4 pathway, here C3 pathway. Important area. Comparison is very, very important. This is the area more possibly question is going to get arised. Now here the enzyme present is PEP. The enzyme present is pepcase, whereas enzyme present is Rubisco. Here the acceptor is a phosphoenol pyruvate, which is a 3-carbon organic acid. Here the acceptor is RUBP, rubulose 1,5 bisphosphate, which is a 5-carbon keto sugar. Here the first product is oxaloacetic acid. Here the first product is a 3-phosphoglyceric acid. How come? Already I have explained there. Next, here in this glucose is synthesized, here glucose is not synthesized. Here granule chloroplast is there, here agranule chloroplast is there. That is the logic. Now I am combining with this with the photorespiration concept. Listen, first dark reactions are of two types, C3 cycle and C4 cycle. C3 cycle happens in all photosynthetic plants, but C4 cycle occurs only in the C4 plants. The C4 cycle is also called as a Hatch and Slack pathway. Then let me move ahead. The next concept to discuss is going to be the photorespiration. To be simple, what is photorespiration? This is a process in which it is going to absorb the oxygen and release the carbon dioxide in the presence of light. So generally, first step of the C3 cycle ma RUBP combining with oxygen to forms 2 molecules of 3-phosphoglyceric acid. That is the thing. Now in this C4, in this photorespiration pathway ma, the main character is revolves around this Rubisco enzyme. I told you it can bind with oxygen, it can bind with carbon dioxide, but if high oxygen is there and low carbon dioxide is there, in this condition the Rubisco binds with the oxygen. So I told you it can bind with both. If high oxygen is there, it will bind with the oxygen. High carbon dioxide is there, it will bind with the carbon dioxide. If both are in equal concentration, the Rubisco is going to bind with the carbon dioxide because it is having more affinity towards the carbon dioxide. That is the logic. Now, this if high oxygen is there, low carbon dioxide concentration is there, Rubisco binds with the oxygen. So that RUBP, instead of converting into 2 molecules of 3-phosphoglyceric acid, it will become, this is a 5 carbon, it will become 2 plus 3, that is phosphoglycolate. Phosphoglycolate, first thing. Second one is 3-PGA. It is a 3 carbon compound, it is a 2 carbon compound. From here another reactions will come, no need to worry much about them, which is out of the NCERT. Here what we have to understand, in this process it is absorbing the oxygen and it is going to release in the middle carbon dioxide. And one point which is very crucial you have to remember, the organelles involved here is a chloroplast, mitochondria and peroxisome. Chloroplast, mitochondria and peroxisome are the 3 organelles which are involved in this procedure. Now, if you observe, Rubisco, instead of binding with the carbon dioxide, if it binds with the oxygen, instead of formation of 2 molecules of 3-PGA, it is forming 1 phosphoglycolate and 1 3-phosphoglyceric acid. That is the thing. Now, this procedure is generally considered as a wasteful process. Still we don't know the significance of this photorespiration. Why it is considered as a wasteful process? No synthesis of ATP, no synthesis of NADPH, and there is no synthesis of glucose. Nothing is going to get synthesized. But instead it is using the oxygen, releasing carbon dioxide and utilizing the ATP. ATP in turn is utilized. Actually the purpose is to synthesize the glucose, but it is not producing glucose, instead it is synthesizing what? ATP. That is the logic. So this is about the photorespiration, very simple. If oxygen is bind, it is going to release the carbon dioxide and 2 different compounds are formed, in which condition high oxygen and low carbon dioxide. It is a wasteful process because no ATP, no NADH and no glucose, but instead it is using the oxygen and utilizing the ATP. So this photorespiration is found only in the C3 plants, but it is not there in the C4 plants. Why? Because, come to this diagram, when it is going to show the photorespiration, when there is surrounding the Rubisco high CO2 and low O2. Rubisco the Rubisco is present here within the bundle sheet cells. In this bundle sheet cells, Rubisco is not surrounded by oxygen. Why? Because I told you bundle sheet cells are agranule chloroplast. Here grana is absent, no light reaction, no oxygen is released. Oragade in the outside, in the anything from the outside entering into this bundle sheet cells? No, because the cells are having thick walls without, they are not going to allow the entry of oxygen or carbon dioxide. Then how come carbon dioxide entering here? There is a mechanism to increase the CO2 concentration by transporting the C4 acids into this here. So surrounding to the Rubisco, it is manipulated, the only CO2 concentration will be high, there is no very minute amount of oxygen. So that Rubisco significantly, automatically, without any other option, it is binding to the carbon dioxide and undergoing the C3 cycle, which is without undergoing the photorespiration. That's why in the C4 plants, because of this special mechanism to increase the CO2 concentration, the C4 cycle, C3 cycle occurs without photorespiration in case of C4 plants. In case of C3 plants, such mechanism is not there, so that they are undergoing the photorespiration. As C3 plants are undergoing photorespiration, their productivity is less. In C4 plants, they are not undergoing photorespiration, that's why the productivity is more, highly efficient in the photosynthesis part. So this is about the photorespiration. After saying that, let we move ahead to explain the factors affecting photosynthesis. The factors affecting photosynthesis, there are many factors are there. Internal factors and the external factors. Internal factors include internal CO2 concentration, genes that are present, number of leaves, size of the leaves, age of the leaves, number of chloroplast, chlorophyll concentration and all this. But in this particular area, we are highlighting the effect of external factors on the photosynthesis. To explain these external factors, there is a rule called as Blackman law of limiting factor. Blackman law of limiting factors. So what is this Blackman law of limiting factor means? Suppose if a process is affected by more than one factor, then the rate will be controlled by one factor which is present in low concentration. How come we explain this? Suppose there is a plant. This plant is absorbing the water from the soil, sunlight from the sun and carbon dioxide from the atmosphere. For these enzymes to function, proper optimum temperature is there. The photosynthesis is affected by light, water, carbon dioxide and temperature. So the statement here is, if a process, I mean by photosynthesis, affected by more than one factor, then its rate of this process will be affected by one factor which is present in low concentration. For example, everything was available but sunlight was not there. Early morning 4:30, 5 o'clock time. Water is there, carbon dioxide is there, temperature is there, but the plant is not doing photosynthesis because light is not there. So the factor which is present in low concentration, that is going to determine this. Or let me remove this. Sunlight is there, water is there, carbon dioxide is there, but temperature is very low. In such condition, who will be the controlling factor of the entire process? Temperature. Why? Because that is the rule of law of limiting factor. The factor which is present in low concentration, minimal value, suboptimal value, that is going to be called as what? Limiting factor, which is going to control the process. I am repeating, Blackman law of limiting factor says that if a chemical process is affected by more than one factor, then the rate of this process will be determined by one factor which is present in low concentration. That is the thing. Here, the first factor that we have to discuss is going to be the light. Many people having many doubts related to this light. So light, how much light is required for the plant to do photosynthesis? Plants require 10% of optimum light, 10% of total sunlight. 10% is optimum. This is called as a photosynthetical active radiation. In that only 10% is required. So you have to understand, less than the 10%, less than 10%, we call it as a low light intensity. More than the 10%, it is called as what? High light intensity. First you have to understand this point. Plants require how much of the total sunlight? 10%. Less than 10%, we call it as low light intensity. Less than, more than 10%, it is called as high light intensity. So that what we can say, if you draw a graph against the light to photosynthesis, light to rate of the photosynthesis. Early morning, let me take it as a story. Early morning 5:30 time, light is low, photosynthesis is also low. Slowly 5:30, 5:40, 5:50, 6 o'clock, slowly sunlight is increasing. Rate of photosynthesis also increases until it reaches what? 10%. At the 10%, rate of photosynthesis is maximum of the sunlight. So here what we can understand, below to 10%. This is the low light concentration. At the low light intensity, rate of photosynthesis directly proportional to light. We call it as a linear relationship. Textbook statement ma linear relationship. Linear relationship means directly proportional between rate of photosynthesis to light. At which condition? At low light intensity. When the light is low, rate of photosynthesis is directly proportional to light. What is low light? Below to 10%. At the 10%, it is called as saturation point. More than 10%, it is going to be called as what? High light intensity. So, we can call it as a point A. At the point A, light is a limiting factor. Yes or not? Yes. Why light is a limiting factor? Because it is less than 10% available. At the point B, from here to here, this is a point A. At the point B, light is sufficient, but factors other than light becomes limiting. At the point B, light is sufficient, but factors other than light is limiting. Suppose water is limiting, carbon dioxide limiting, or temperature limiting. So, the point B is where photosynthesis is not anymore increasing because light is not the limiting factor. Factors other than light is a limiting factor. From here, if you do the thing, this is a point C. At the point C, we can consider it as a high light intensity. Light is no longer a limiting factor. And if you draw a horizontal line towards the y-axis, this is called as a point E, and this is going to be called as point D. What is point D? Point D is a saturation point, light saturation point 10%. At the point E is a maximum rate of photosynthesis, which is intersecting with the x-axis at the 10%. So, this is the thing. At the point A, light is a limiting factor. Point B, light is not a limiting factor. Factors other than light is becoming limiting. Point C, light is no longer a limiting factor because more than 10% is available. Point D is a saturation point of the light. Point E is the photosynthesis. So, maximum rate of photosynthesis. So, below to 10% linear relationship between incident light and the rate of photosynthesis. After 10% there is no such relationship. If you increase the light, there is no increase in the rate of photosynthesis because factors other than light becomes the limiting. So, light is rarely a limiting factor. Light is rarely a limiting factor. Why? Because every day more than 10% is available. Light is rarely a limiting factor except for the plants living under shade or dense forest. If a plant is living in dense forest or under the shade, these plants light is a limiting. Except these plants, remaining all conditions, light is rarely a limiting factor because more than 10% is available. But there is a problem with the light. More high intensity of the light, after such a point, it will damage the chlorophyll A. I said you, photooxidation, breakdown of chlorophyll A. Who is protecting the chlorophyll A from breakdown? Accessory pigments like chlorophyll B, xanthophylls and the carotenoids. That is the thing. So, this is about the light. After that, second thing we have to discuss is the carbon dioxide. Carbon dioxide is a major limiting factor. Carbon dioxide is the major limiting factor. Why it is major limiting factor? Because it is present in low concentration. How much low concentration? 0.03 to 0.04%, which is present in the atmosphere. If you convert it into microliters, 380 microliters per liter. 380 microliters per liter, which is present in the nature. So, assertion CO2 is the major limiting factor. Reason is going to be it is present in low concentration. If increase the CO2 concentration, if we increase the CO2 concentration, what will happen? So, understand the point. CO2 is generally a limiting factor. That's why if you increase the CO2 concentration up to 0.05, we can't go beyond this because beyond this point it is going to damage. We have given high CO2 concentration and looking at the plant in two different situations. One situation is low light intensity. Low light intensity. At the low light intensity, even though high CO2 concentration is there, C3 and C4 both are not responding. Not responding. Why? Neither group responds. Why? CO2 is not a limiting factor in this situation. CO2 is okay, it is high concentration, but who is a limiting factor? Light. At low light intensity, if high CO2 concentration is there, C3, C4 both are not going to be responded. Ade high light intensity, light is high along with that CO2. C3 and C4 both are showing increased rate of photosynthesis. Increased rate of photosynthesis will happen at high CO2 concentration and high light intensity. And there is a statement in the textbook, increased CO2 concentration, C3 and C4 responds differently. How? Let me see. I am repeating my statement. At high CO2 concentration, C3 and C4 responds differently. How responds differently? Let me see about this. So, there is a point called as a saturation point. Point called as a saturation point. What is mean by this saturation point? Here, C4 plants require 360 microliters per liter of carbon dioxide to show the maximum rate of photosynthesis. Ade C3 plants require 450 microliters per liters of carbon dioxide. Who require more? Again I am saying saturation point means the point they are going to show maximum rate of photosynthesis. C4 plants to show maximum rate of photosynthesis, they require only 360 microliters. But in C3 plants, they require more. For them to show maximum rate of photosynthesis, they require 450 microliters. So, therefore, what we can say? Availability of CO2. Availability of CO2 is limiting for what? Limiting for C3 plants. So, for C3 plants, availability of CO2 is a limiting factor. Why? Because observe, compare this with this one. That's why I have written this. In the nature, how much is there? 380 is there. What they require? 450. Availability of CO2, current availability which is in the nature, whatever CO2 available, that is not limiting for the C4 plants. Why? C4 plants require only 360. In the nature already 380 is available. You have to carefully understand this point. C4 plants to show maximum rate of photosynthesis, they require 360 only. Already nature is providing him 380 microliters. But for the C3 plants to show maximum rate of photosynthesis, they require 450 microliters, which is not available in the nature. So that the textbook statement current availability, present availability of CO2 will be limiting in case of the C3 plants, not in case of the C4 plants. That is the thing. Then after saying this, in this what can you say? If you increase the CO2, see, greenhouse crops are there. There are some crops called as greenhouse crops. What are these greenhouse crops? These are C3 plants. C3 plants. For example, let me take two examples. One is a tomato, another one is bell pepper. Tomato and bell pepper. These are the two crops which are C3 plants. If we increase the C3 concentration towards them, what will happen? Means if we supply the 450 microliters, they are also going to show the, so if they give them high CO2 concentration, these plants will show high productivity. High productivity. So entirely all the dots let me connect. C3 and C4 who are showing high rate of productivity, C4 plants are showing high rate of productivity because C4 plants require only 360 microliters of the carbon dioxide which is already available in the nature, so that they are not undergoing photorespiration. Happily they are showing the high rate of productivity. But in case of the C3 plants, they require more concentration of carbon dioxide that makes them to involve in the photorespiration. That's why their rate of productivity will be less. But if you give a chance to the C3 plants with high CO2 concentration, they are going to show high rate of productivity because they are not going to involve in the photorespiration. If high CO2 is there, Rubisco enzyme is not going to bind with the oxygen. It is going to bind with the carbon dioxide, so that productivity automatically increases. So this is about the CO2. I am saying again, CO2 is a major limiting factor because its concentration is less. So if you increase the CO2 concentration and provide the low light intensity, either it is a C3 or C4, nothing going to respond because light is a limiting factor here. If you increase the CO2 concentration under high light intensity, C3 and C4 both are going to respond by showing the high rate of photosynthesis. And in this area, what we can say, there is a basic statement, C3 and C4 not going to respond similarly to the increased rate of photosynthesis. If you increase the CO2 concentration, C4 plants not going to respond much. Why? Because they are already saturated. C4 plants require 360, nature providing 380, already they are saturated. They are not going to show any further increase in case of the photosynthesis if you increase the CO2 concentration. Whereas if you increase the CO2 concentration surrounding to the plants like C3 plants, which are greenhouse crops like our tomato and the bell pepper, they are showing high rate of productivity because they require high CO2 concentration. Then next thing to discuss, it is about the temperature. The third factor which is affecting the rate of photosynthesis is going to be the temperature. Temperature is going to affect the light reaction of the photosynthesis, and it is also going to affect the dark reaction of the photosynthesis. But who is more sensitive, more affected or more sensitive is going to be the dark reaction. The light reaction is also sensitive, but it is less affected than in the case of dark reaction. The reason behind this is, in the dark reaction completely it is dependent on enzymes. For example, our Rubisco enzyme. So in the first PUC biomolecules chapter I told you, for an enzyme to function, optimum temperature is required. Less than optimum, rate of enzyme activity decreases. Higher than optimum, rate of enzyme activity decreases. So what we can understand here, dark reactions are being enzymatic reaction. They are more sensitive than the light reactions. But the light reactions are not much affected. I am not saying they are not affected. They are affected, but lesser extent when compared to the dark reactions. And there is another concept called as temperature optimum. So for the C3 and C4 plants, different kinds of temperature optimum is there. For C3 plants, the temperature optimum is 20 to 25 degrees Celsius. Whereas C4 plants, I told you, they are living in a dry tropical regions, high light intensities, high temperatures. They require 30 to 40 degrees Celsius. So the temperature optimum will be high for the C4 plants. Temperature optimum will be less for the C3 plants. There is another point, temperature optimum will be differs based on the habitat they are living, place where they are living. So the plants which are living in low temperatures, we call them as temperate regions. Such plants are having low temperature optimum. Plants which are living in high temperatures, they are having the high temperature optimum. Last factor to discuss, that is the water. Water not going to affect the photosynthesis directly. Rather, it is affecting the plant, so that indirectly it is affecting the photosynthesis. Suppose there is a water stress, low water concentration. What will happen? First, the plant will close the stomata. Stomata will be closed by the hormone abscisic acid. Because of closure of stomata, low CO2 availability. Low CO2, when low CO2 availability, photosynthesis will be stopped. And here another thing, if we are placing the plant in water stress, leaf will undergo wilting. Leaf will undergo wilting, means leaf will be curved like this. So that it is going to do what? Reduce in surface area. Reduce surface area. Because of reduced surface area, photosynthesis will be affected. So water is not going to affect the photosynthesis directly. It is indirectly affecting the photosynthesis, either by closure of the stomata or by wilting of the leaves. So these are the factors, light, carbon dioxide, temperature and the water. So there completes the chapter. Tomorrow we will go with the another chapter of the plant physiology, that is respiration part. Meet you tomorrow.
Hi my dear students, yesterday we have completed electric charges and fields. So now today let us start potential and capacitance. Now that today topic is potential and capacitance. So just formula and along with that some problems let us discuss today, and potential and capacitance. So capacitance let us discuss later. First of all, let me go with the potential concept. So what is the meaning of the potential? Already you know that the topic is potential and capacitance, and now firstly let us discuss some concepts and problems on the potential. Then after let us go through capacitance concept. What is the potential? So as I told you yesterday, every charge when you are keeping in space, it produces some electric field around it. This electric field will be measured by two important physical quantities. One is electric field intensity. Yesterday we have discussed E bar is equal to F bar by Q naught. So that electric field intensity is a vector quantity which explains the effect of electric field produced by any point charge or any charge distribution. Now, so another physical quantity which gives the strength of the electric field or effect of electric field is electric potential. So what is the meaning of electric potential? Now, for example, this is the charge which is fixed in the free space. Around this electric field will be produced. Now we are bringing another test particle or another test charge bringing from infinity. When it is coming to the any point inside the electric field, for example, you are bringing it from infinity, right? Now that charge I am taking, that Q naught. Now the separation between them, for example, I will take that is the R naught. Now this charge you are bringing from where? From infinity you are bringing that. Therefore, to bring from infinity, so against the electric field, because both are the same charges, repulsive force will be act. Due to that repulsive force, we have to do some extra work to bring the Q naught closer to the Q. So the amount of the work done to bring a test particle per unit charge is called as potential at this point. That potential is given by, so V is equal to what I told you, the amount of the work done. So to per unit test charge means what? So V is equal to W by Q naught. This is the potential at any point. This is not a potential difference, it is only potential. Therefore, that potential at any point inside electric field is given by V is equal to W by Q naught. Otherwise, if they will ask what is the meaning of potential difference, therefore now you can take, for example, here one charge I am taking that as usual, that is the Q. Now here, so I am taking that. So at this point the potential is V1, and at this point the potential is V2. Now you are bringing the test particle from a point of potential V1 to another point of potential V2. So in this case, now the potential difference is given by, so delta V is equal to final potential minus initial potential, that is equal to change in work done by test charge. Therefore now what? Potential at a single point is different, potential difference is different, and this potential difference is also called voltage. Potential difference is also called as a voltage. This is potential at any single point. That point you can take anyone at this point. And so while coming from infinity to nearer to the charge, whenever you move from one point to other point, the work done per unit charge from infinity to any point is called as potential at that point, and the work done per unit charge to bring it from one point to another point inside the electric field produced by any another charge is called as what? Potential difference, and that is the voltage. Therefore now, so V is equal to delta W by Q naught, that is the potential difference is also called as a voltage. And you know that what is the unit of it? Joule per coulomb. That joule per coulomb is nothing but volt. Volt is the SI unit of the potential or potential difference. Now, so potential due to a point charge. Okay, this formula V is equal to work done by charge q naught means what? So the V is equal to potential at any point. So in terms of the q naught only I have given, but potential due to point charge means what? In terms of the q, what is the potential at this point? I don't want potential due to potential in terms of the test charge. I want potential in terms of the given source charge q, and that potential is given by V is equal to 1 by 4 pi epsilon naught q by r. So this is the expression for potential due to a point charge at any point. So q is the amount of the given charge, r is the distance of the point at which you want to measure the potential. Therefore at this point the potential is given by what? V is equal to 1 by 4 pi epsilon naught q by r is the potential. But here important point is that as we discussed yesterday, electric field is a vector quantity. The direction of electric field due to a positive charge at any point is away from the charge, and the direction of electric field due to negative charge at any point is towards the charge. But there, in case of the electric field intensity, to calculate net electric field or to calculate electric field due to any point, direction compulsory, and that direction already I told you. And there, in case of the electric field intensity, to find out electric field intensity value compulsory, we need to substitute only positive values, not need to substitute negative values to find out magnitude. First of all, we have to find out the magnitude, then after we have to decide the direction, either which charge it is, either positive charge or negative charge. But in case of the potential, what will they provide? If it is positive charge, please substitute here positive charge. If it is negative charge, you have to substitute here negative charge. Therefore, potential at any point may be positive, may be negative. So therefore, a positive charge produces the positive potential, a negative charge produces the negative potential. So therefore, now potential may be positive, may be negative, and may be infinity also, because may be zero also. Why? Because when the point is taken at infinity, when from the given charge, when the point of measurement is taken at infinity, therefore now what? Here r is equal to infinity. When r is equal to infinity, V is equal to 0. Therefore, potential due to a charge or charge distribution may be positive, may be negative, may be 0. That 0 is only possible at what? At infinity for the single charge. Next, so let us solve one problem like this. For example, what I am taking that, this is I am taking that is a charge is q, I am taking that, and so this is I am taking that is one more charge that is also plus q only, this is plus q, and the separation between them, for example, r, I am taking that. The separation between them I am taking what? R. Therefore now what? Here plus q, that is also plus q. Now at the center, what is the net potential? What is the net potential we want? Therefore at the center, what is the meaning of it? Now at this point we have to find out. Therefore the distance of the first charge is given by r1 is equal to r by 2. The distance of the second particle is from the center to second particle distance how much? R2 is equal to r by 2. Therefore potential due to first charge V1 is equal to small k. In place of the 1 by 4 pi epsilon naught, I am taking that k. Therefore, k into q1. q1 ಏನದದು? So q by, so r1. r1 value how much? r by 2. That you know that 2k q by r. And potential due to second charge V2 is equal to, you are getting the same answer because same charge is there and same distance is there. Therefore now what? We want the total potential at the point O. Therefore the total potential at the point O is given by V1 plus V2, that is equal to, so 2k q by r plus 2k q by r. After simplification you can get 4k q by r. This is the total potential. Okay na? So for the measurement of the potential, we need not to check the direction because potential is a scalar, electric field intensity is a vector. But only one thing is that if they will give the positive charge, in the formula we have to substitute only positive charge. If they will give the negative charge, you have to substitute only negative charge. Don't confuse in this case. So this is the problem. Next what? In the same question, instead of positive charge, for example, if they will give that minus q. If they will give the minus q, therefore now the potential due to the positive charge is given by kq by r by 2, therefore 2kq by r. Therefore potential due to negative charge k into, here Don't forget what I told you, if the given charge is negative, so we have to substitute negative only to measure the scalar quantities, therefore minus q by r by 2. If you substitute, therefore you are getting what? Minus 2kq by r. Therefore the total potential at the center of line joining the two charges is given by V0 is equal to V1 plus V2, and that after substituting that is equal to what? 0. Therefore as I told you, potential may be positive, potential may be negative, potential may be 0. Like this we can get the answer. And one more important point is that, so two negative charges never produces the 0 potential, two positive charges never produces the 0 potential. So to produce the potential at any point is 0. Therefore now what? The charges must and should be so both negative and positive. See, this is positive charge produces the positive potential. This is negative charge produces equal amount of the negative potential. Therefore now what? The sum of them is equal to 0 at this point. Now let us solve one problem. Now here I am taking that, for example, this is the, so here I am taking that this is the 2 microcoulomb and this is the minus 6 microcoulomb, and both are separated by a distance, for example 16 centimeter. Question is what now? So 2 microcoulomb and minus 6 microcoulomb are separated by a distance of 16 centimeter. Now the question is find, so where find the point at which V net is equal to 0, net potential is equal to 0. And if it is 2 microcoulomb, this is minus 2 microcoulomb, exactly at the center net potential is equal to 0, because previously we have discussed that point only. And if it is plus 6 microcoulomb, already it is a minus 6 microcoulomb, therefore at the center potential is equal to 0. But in this case, so potential at the center not equal to 0. Why? Because charges are not equal in magnitude. Therefore now what? So for example from the, so distance given 16 centimeter, I don't know this point, I am taking that at this point from the first charge the potential I will take x, right? Now the potential, so at a distance x is equal to 0. At this point V net is equal to 0. If it is x, therefore this distance compulsory becomes what, Nana? R minus x, because R is equal to 16 centimeter. This value we can take R is equal to 16 centimeter. So condition what? V net is equal to 0. We have to find out x value at what distance from 2 microcoulomb. In the question they will mention either from 2 microcoulomb or from minus 6 microcoulomb, they will mention in the question, and you can follow and you can find that. Therefore according to that, the total potential is equal to 0, means what? V net is equal to sum of the two potentials produced by the 2 microcoulomb and minus 6 microcoulomb, that is equal to, so V net is equal to 0. V1 what you can take, so what I am taking that Q1 nothing but 2 into 10 power minus 6 by, so because microcoulomb or this is also microcoulomb, not need to substitute, just use take that, so 2 into, therefore now what? K into 2 by, so distance how much? Now I am taking that x, here what? Plus K into, don't forget it is a minus 6 microcoulomb. I am not substituting 10 power minus 6, already I told you, that is what? Minus 6 by, so what? That is so R minus means what? 16 minus x. 16 minus x. Therefore if you simplify, now 0 is equal to what? That is equal to 2k by x minus 6k by 16 minus x. Right now after simplification you can get that answer. So 2k by, so x is equal to, so 6k by 16 minus x on both sides. So 2k ones are and 2k threes are, correct? Because 2 threes are cancel and kk cancel. After simplification what we got? Now, so after that, so you can get, so what? 1 by x is equal to, so 3 by 16 minus x. If you take the cross multiplication, 16 minus x is equal to 3x. Therefore, finally 4x is equal to 16, and after simplification, you are getting that x is equal to 4 centimeter from where nana? From 2 microcoulomb. Therefore, at x is equal to 4 centimeter from 2 microcoulomb, the net potential is equal to 0. Therefore, now what? X is equal to 4 centimeter from 2 microcoulomb. Otherwise, in the question if they will ask, from minus 6 microcoulomb, where the net potential becomes 0. Therefore, already this you have taken, x is equal to 4 you got, means what? Remaining distance means what? Therefore, from 6 microfarad, from, so minus 6 micro coulomb, therefore now what? That is, so r minus x, that is equal to 16 minus 4 is equal to 12 centimeters. Therefore, this is the question, and one more point is there, you can find out this is the internal point. This is the internal point. Therefore, for any given two charges of opposite nature, one is plus charge, one is negative charge. So, there are the two, at 2 points the potential becomes 0. One is internal point is over. One more is there. So, outside also net potential becomes 0 beta, and you can find out that, okay, this is the only internal case. Therefore, for any two cases there are the 3 points. What is that? One is the internal point and one is the external point, means what? Outside the line joining, and one is at infinity. At these 3 points net potential is equal to 0. One is the internal point, means what? In between the line joining the two charges. External means what? That is outside of the line joining, and one is what? So, at infinity, already I told you, for every given point charge the potential at infinity is always equal to 0. Therefore, now I hope you may find out external case. Therefore, in case of the external, means you have to change the diagram. Therefore, now what? For example, again I am taking that. So, this is the at this point, for example, from the first chart, this is the x, I am taking that, and you know that this becomes what? R plus x already. So, x value they have given. If you substitute here, so you are getting what beta? It is equal to same procedure. You take V net is equal to V1 plus V2. Therefore, for outside point, at this point I am taking that V net is equal to 0. Again same story, 0 is equal to V1. V1 value how much now? K into 2 by, that is the x. So, this is direct I am taking that K into 6 by, so R plus x, nothing but what? 16 plus x I am taking that. So, if you simplify, again you are getting that after solving that. So, this is that 2k1 2k3 is the, means what? 1 by x is equal to, so that is the 3 by, so 16 plus x. Therefore, if you simplify, now what? That is the 16 plus x is equal to 3x, and after simplify you are getting that x is equal to 8 centimeter from which one? From the 2 microcoulomb. From 2 microcoulomb. So, this is the 8 centimeter distance. Therefore, for the internal point it is at a distance of 4 centimeter, already we have calculated, and for the external point it is 8 centimeter from the 2 microcoulomb. Therefore, now here one more point is what? At infinity. Already internal we found, external we found, already infinity. And one more important point, the net potential 0. The 0 potential point is always closer to the charge of smaller magnitude, irrespective of the nature. Adu positive, negative, so nodabekalla. So, what we have to check that? Only magnitude. Idu smaller charge, that's why null point or 0 potential point is always closer to the charge of smaller magnitude, irrespective of nature of the charge. Okay, na? Therefore, don't think of the plus minus, think only value. Therefore, here 2 is smaller than the 6. Therefore, now what? Here the null point is closer, here also null point is the closer to the smaller charge of smaller magnitude amount. Next. So, these are the potential due to, so due to these charges, and remaining potential problems are very simple only, you may solve it. Next, potential due to a spherical shell. If you take the spherical shell, this is a spherical shell I have taken, the charge present on the spherical shell the charge present on the spherical shell Q, I am taking that the radius of the spherical shell or a hollow sphere, I am taking that capital R, or conducting sphere, hollow sphere, spherical shell, all same. Therefore, I will take the 3 important points. One point is outside, one point is on the surface, one point is inside the spherical shell. Therefore, for the first point, for the outside point means what? The potential due to outside point is given by KQ by R, where R is the distance of the point from the center of the spherical shell. Next, one more point I am taking, that point I am taking on the surface. When you take the point on the surface, potential is given by just small r is equal to capital R, you substitute, you can get the answer KQ by capital R. This is the potential on the surface of the spherical shell. And if you take a point inside, now what? This distance I am taking that small r, but this is not a matter, because for the internal point the potential is given by Vi is equal to KQ by capital R only, even though they will give the distance, inside the cell. So don't take that distance, because it does not depend upon the distance amount, because this can be derived by using the relation between electric field and potential. Therefore now what? Potential outside V0 is equal to KQ by R, potential on the surface is equal to KQ by R. Potential at each and every point, you can take at this 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 point, including center also, means what? Potential at the center also, Vc is equal to KQ by R. Therefore remember this value and let us solve based on this simple problem. So let us solve simple concept, let us solve one problem right now. So outside, on the surface, inside at any point including center. Therefore finally you can remember only one point. So potential on the surface, potential at the center, potential at any internal point is always equal to KQ by capital R. Depends only on radius, not depends upon the distance given inside the spherical shell, but that depends only on outside point as stay, right? Therefore this is the small point, this is what? Potential due to a spherical shell. And based on this, let us solve one problem. Now here two spherical shells I am taking that. First spherical shell, the charge I am taking that Q, and the radius, for example, I am taking that R beta. And so the second cell I am taking that, one more concentric cell I am taking that. So this is the one more spherical shell which is concentrating with the first one, and the radius, for example, I am taking that is a 2R, and the charge I am taking, for example, 2Q only. Charge I made it double, means what? The charge on this one is Q and the radius is R, and the outside the radius is 2R and the charge is 2Q. Question is, what is the potential on the first surface? V1 is equal to how much, and what is the potential on the surface of the spherical shell, second spherical shell? These two questions let us solve right now. Means what? What is the total potential on the sphere, on the surface of the first sphere, and what is the net potential on the surface of the second sphere we have to find. First of all, I want to go for the what is that? So V1 is equal to, means total potential on the surface of the first sphere I want. Tell me this point, where this point is present on the surface of the first sphere, and this point is internal point for the second sphere. So this point is present on the surface of the first sphere, and so this point for this sphere acting as internal point. Therefore now what we can say, now potential due to first sphere. Therefore now what? So potential due to first sphere. So now what I am taking that this is the, so how can you write? Therefore now that is equal to, see, can you say what you can say? That is the K Q by on the surface R I am taking that. Okay na? Next what? Plus now this point for this sphere acting as internal. For the internal, what I told you, charge on the sphere into what? Radius of the sphere. Don't take the distance. Again 2 get cancelled. Therefore the net potential on the surface of the first sphere is given by KQ by R. KQ by R, that is equal to 2KQ by R. This is the net potential on the first sphere. I hope you may understand. See, once again I am saying that first of all, at which point they are asking the net potential, you check it first of all. So at this point, means on the surface of the first one, we have to find out the net potential. This point is acting as surface point for the first sphere and acting as internal point for the second sphere. Therefore now what? Therefore KQ by R, so KQ by R. Therefore now what you can get now? 2KQ by R. Let's go for the second one. What is the second one now? Now potential net potential on the surface of the second sphere is given by V2 is equal to, now tell me at this point we have to find out the net potential, right? Now for this one, first of all I am calculating potential due to outside sphere. So potential due to outside sphere what nana, that is equal to K into, so charge on it 2K by what is the radius of it is, that is a 2R, completed. Now plus next CM, here what is that, this point. This point is present outside of the, so in this sphere. So right now the first sphere is there, no, this point is acting as outside point because it's the radius only up to this one. Therefore what we can say now, that is a K into charge on this one. Don't take charge on this one because we are measuring potential due to this one. Therefore KQ by formula what am outside point, for outside point V0 is equal to KQ by R. So charge already we are discussing potential, okay na, at this point supplied by what, this one. Therefore K, charge on this one Q, R is what, R is, so here to here, therefore here to here how much this is R, R is equal to 2R, therefore here I am taking that what, 2R, therefore if you substitute what you can get now, V2 is equal to, so 2KQ by 2KQ plus KQ by what, that is 2R, and V2 is equal to, you can say 3KQ by 2R is the potential, which potential? Net potential on the second sphere. Therefore like this questions they will ask, and sometimes they will give outside also. Therefore for example they will give like that. Now what, at this point what is the total potential, they will give the distance of the point is 3R. Same, now tell me this point acting as outside point for the first sphere and outside point for the second sphere, for both of them. So R small r is equal to 3R, but on this one charge is Q, on this one charge is 2Q, you can find out anything. And in this one more model is what is the potential difference between the two spherical shells, they will ask. This difference how much, delta V is equal to how much, they will ask. What is the potential difference between, what is the potential difference between, so inner sphere and outer sphere. Therefore now the potential difference between inner sphere and outer sphere is equal to, between what I mentioned, inner to outer, not outer to inner. Potential difference between inner spherical shell to outer spherical shell is what, inner spherical shell I am taking that V1 minus V2, and V1 we got what, that is equal to 2KQ by R. Right now, and here V2 how much you got, that is equal to minus 3KQ by, so 2R we got it. Therefore if you simplify you can get the answer. Now this is the 2 2s are 4, 4KQ by, so 2R minus 3KQ by 2R. Therefore now 4KQ minus 3KQ is equal to what, it is equal to KQ by 2R is the potential difference, and we got plus. Okay, here be careful, potential differences sometimes in the option they will maybe mention positive value, negative value, because so what I mentioned, potential difference between inner spherical shell to outer spherical shell, therefore we got positive. We got positive means what, the potential on the inner sphere is more than potential on the outer sphere, that's why we got positive. Otherwise if they will ask what is the potential difference between outer spherical shell to inner spherical shell, in that case so what, that is we can take a reverse sum of V2 minus V1, you will get here minus KQ by 2R. So we can say, so the inner spherical shell having more potential compared with the outer spherical shell. Therefore this is the procedure, just to check the point at which they are asking the net potential, at that point or that point acting as what, outer pointer, internal pointer, spherical pointer, like that. Okay, therefore now, so this is one more model in case of the potential. Next, relation between electric field, just let us discuss one problem, then after let us go for the capacitance. Relation between electric field vector and potential difference. So next one, this one is simple, but only into integration differentiation part is that. So therefore relation between electric field and so potential difference. So generally when a potential difference is function of For example, V is equal to function of what, Nana? So x comma y comma z means what? Potential difference is expressed in terms of the x comma y comma z in the space. Then the electric field at any point is given by, so E bar is equal to minus of here dou V x by dou x I cap plus dou V y by dou y j cap and plus dou V z by dou z k cap. Therefore, this is the electric field at any point. Therefore, so dou V x by dou x means what? This is the partial differentiation. Means what? By keeping the y and z are constant, we have to differentiate only x terms. By keeping the z and x are constant, we have to differentiate only y terms. By keeping the x and y constant, we have to differentiate only z terms. Therefore, now what? Here I cap, j cap, k cap, y, because electric field is a vector quantity. Therefore, now you can say, so electric field is always equal to potential gradient of, so what? Electric field is always equal to negative potential gradient of potential difference. Therefore, now what? That is the formula for it. So, now what? This is a very simple, and because only the integral differentiation is there, based on that, let us solve one problem. Now, let us go for the simple problem. Now, the potential at any point is expressed as V is equal to 8x or 6x square. 6x square. So, what is the potential at x is equal to, so 2 meter they are asking. What is the electric field? Now, the potential is given as a function of V is equal to 6x square means what? Potential is varying only along the x axis. Now, at point at x is equal to 2 meter, what is the direction, what is the electric field they are asking? Electric field is equal to how much? So, as I told you, what is that? So, E bar is equal to minus dou V x by, so dou x I cap. That's it. There is no change. Why? Because so y terms, z terms are missing. Where y term, z term they are not given, only x. Therefore, or if they will give the single value, now you can take direct that is equal to what? So minus dv by, so dx khatam, and differentiate. What you can get now? V is equal to 6x square. Therefore, dv by dx value how much? dv by dx is equal to 6 into, so what? Differentiation of 2x, x square nothing but what? 2x, that is equal to what? 12x, and at what value? Therefore, at x is equal to 2 meter, nothing but what? 24, correct? Therefore, now what? So, that is a 24, because x is equal to 2 meter and 2 into 12 is equal to 24. We got dv by dx. Therefore, you substitute there. What you can get now? So, electric field E bar is equal to, so minus dv by dx I cap. Already we have, so dv by dx is equal to minus 24 into I cap. Means what? The direction of electric field is acting along the negative direction, and it is a magnitude how much? Therefore, magnitude E is equal to 24 Newton per Coulomb or 24 volt per meter. Okay, na? A very simple model. So, whenever potential is expressed in terms of the x, y, z, you follow this method, you can get, and be careful. Sometimes they may ask magnitude of electric field, or sometimes they may ask also direction. Therefore, the direction what we can express? Now, that is equal to 24 into minus I cap. Therefore, the direction of electric field is acting towards the negative x axis, because we have taken minus I cap here. Right now, so now, one more last, because 3 terms at a time if they will give. For example, now the potential is given by, here I will give that potential. So, what? V is equal to xy plus xyz plus z square x. Z square x. Now, they will ask at point what? 1 comma 1 comma 1. So, what is the magnitude and direction of electric field? E bar is equal to how much? Same procedure we have to follow. Therefore, when they will give like that, therefore, in this question what am I? First of all, I am calculating. So, dou V x by dou x. Individually, we have to find out the better. So, that is equal to what? Dou V x by dou x is equal to. So, we have to differentiate only x terms. Here what is there? So x comma y. So dou v x by dou x what ma? So your first term becomes what? Y plus here what? X. So differentiation of x with respect to x is what? 1 into yz. So yz. So next what? Last one. So z square into x. Nothing but what? X only, z square only. Therefore now what? At what point at 1 comma 1, x is equal to 1, y is equal to 1, z is equal to also 1. Therefore now what we can get? 1 plus, so 1 plus 1 is equal to how much? 3 we got. Similarly, dou v y by dou y is equal to, tell me, dou vy. So means this term we have to differentiate with respect to y only. But here what is there? X. As I told you, it is a partial differentiation. We have to differentiate only y by keeping the x is constant. Therefore, dou v by dou y is equal to what? 1. So you are getting what? X remaining. So here what? X, y, z. Again you are getting what? X, z. But here there is no term from the y. Y is not there. Therefore, this is constant. I already told you. So partial differentiation means what? With respect to what axis they are differentiating. With respect to that axis, remaining other axes are constant. Here x and z are constant. The constant of any differentiation constant is always equal to what? 0. Therefore, now what? That is equal to 0. Here this is 1 and 1 into 1 is equal to what? That is equal to, we got 2. Finally, last one. What is the last one? Dou v z by dou z. Dou v z by dou z. So with respect to z, therefore now what? This becomes what? 0, because with respect to the z, x is constant, y is constant. Here z is there. So differentiation of z, dou v z by dou z, dou z by dou z, dou z cancel is equal to what? Therefore this is a first term becomes 0. This is only, so x into y. Last one is what? Z square is there. What is the z square? Differentiation of z square with respect to the z axis, 2z you will get. Therefore 2z into what? Into x, because with respect to the z, x is constant. Again you substitute. So 1 comma 1 comma 1, what you can get? X into y, 1 into 1, 1 plus 2 into 1 into 1, total value 2, and this is also what? 3. Now finally, the electric field is what? Electric field is given by E bar is equal to, so minus dou v x by dou x I cap plus dou v y by, so dou y j cap plus dou v z by dou z k cap. Therefore take the, so minus in front of it because it is there in the formula. After substituting what you can get? Minus 3 I cap, so plus 2 j cap and plus 3 k cap. That's it. This is the, so electric field vector at that point in vector form. If they will ask what is the magnitude is given by, don't use the symbol for vector form. E is equal to what? Under root of x square plus y square plus z square. So 3 square matlab 9. So 2 square means 4 and 3 square means what? Again 9. Therefore total what? That is equal to root 22. So Newton per coulomb is the answer. And one more model is there in this. At this point, if you keep a charge, Q is equal to 2 microcoulomb. Q is equal to 2 microcoulomb. What is the force acting on that particle? Yesterday I told you, at any point if you know the electric field, the force acting formula what? F is equal to Q into E. I have given yesterday formula. Therefore, at the point 1 comma 1 comma 1, S2 electric field root over 22 Newton per coulomb, and you multiply with Q. Therefore, 2 into 2 root 22 and micro Newton is the, so force acting on that one. Okay, na? So be careful. Not only electric field, not only its magnitude. Sometimes at this point they will keep one charge particle. On that charge particle, what is the force acting? We can find out. F is equal to Q into E. And let's go for the capacitance. Capacitors or capacitance first. What is the capacitance? What is the capacitor? And before the going to the what is the meaning of capacitor, I will discuss. So every conductor having some ability to hold some amount of the charge. That ability of any conductor to store some electric charge is called as a capacitance. Okay. Therefore, now the charge given, for example, you take one spherical conductor. I don't know what is the nature of it, aluminum or zinc or copper or whatever it is. So what is that? Whenever you apply some potential difference, automatically charge rises on atom. Means what? So to remove the electron or to add the electron, compulsory we have to supply some potential difference. Therefore, the charge on this is Q and the radius I am taking that orbital. Now we have to find out, this is what one spherical conductor, hollow sphere I have taken, and just now I told you on the surface of the spherical cell what is the potential now. So before that one point I will say. Now so your what you have taken the potential difference V you have given that. Therefore now if you apply more potential difference, more charge will be developed on the surface. If you apply less potential difference, less charge will be developed on the surface of the sphere. Therefore now the amount of the charge supplied to any conductor is directly proportional to potential difference applied. More is the potential difference, more is the charge stored in it, and lesser is the potential difference, less charge stored will be practically we can find out. Therefore, by removing this proportionality, we are getting one constant Q is equal to CV. Therefore, here C is called as capacitance of any conductor. I am not talking about the capacitor, I am talking about a single conductor, because inside the capacitor there are the two conductors are there. I will discuss later. So C is equal to Q by V. So here one question arises. So whenever you see this formula, you may think that charge is in the numerator, potential difference is in the denominator. Therefore, when the charge becomes double, capacitance also becomes double. When the voltage becomes off, the capacitance also becomes off. That is the wrong gamma. Why? Because here, what is the principle behind it? So charge given to any conductor is directly proportional to potential difference. So to get charge becomes a double, automatically potential also becomes a double. That is only called as proportionality. Therefore now what? So if you think when the charge becomes double, capacity becomes double, then this is not correct. Therefore now what? So when the charge becomes double, potential also becomes double, or when the potential becomes off, charge also becomes off. Therefore capacitance always constant. Even though in this expression capacitance is equal to charge by voltage, but capacitance of any conductor or capacitance of any capacitor does not depend upon the charge stored or potential supplied. Okay, therefore it depends upon geometrical properties. Okay, now what? Therefore is one. Next, what is that unit? Therefore charge coulomb. Potential difference is voltage. Coulomb for volt is nothing but farad. All those are, I think you know that, so not need to discuss here. Now, so this is one single spherical conductor. If you take one single spherical conductor, now if the R is the radius, charge is the Q, voltage is the V, what is the capacitance of that one? Just now, before 5 to 10 minutes we have discussed the spherical conductor potential on its surface. What I have given therefore for any spherical conductor, what is the formula? K, Q by R we have given. Therefore, K is what? That is equal to 1 by 4 pi epsilon naught Q by R. Correct? Now, what I am taking that? So, here this you can write once again Q by 4 pi epsilon naught R. This 4 pi epsilon naught R you bring this side and bring the V this side. Therefore, now what you can get now? That is equal to, so what? 4 pi epsilon naught R is equal to Q by V. Are yaar, 4 pi epsilon naught R is equal to Q by V. Matlab already Q by V is equal to what? Capacitance. Therefore, now you can say, see, therefore, now the capacitance of any spherical conductor of radius, so R is given by 4 pi epsilon naught into R. Therefore, this is the formula for spherical conductor capacitance. And purely, I told you, here you have given charge Q, you have applied potential V, but here in this expression there is no charge, there is no potential difference. Therefore, now what? C is equal to 4 pi epsilon naught R. It is purely depends upon geometry, means what? Length, radius, distance between the conductors and diameter, etc. These are all called as the dimensional factors or geometrical factors. Therefore, capacitance of any conductor or capacitance of any capacitor just depends upon the geometrical factors, not any charge and voltage. Therefore, here what? 4 pi epsilon naught, you know that 1 by 4 pi epsilon naught, that is R. Therefore, C is equal to 4 pi epsilon naught into R. And here this is also depends upon the medium. So in between inside the spherical conductor, if you keep any dielectric material, now instead of 4 pi epsilon naught, we have to take 4 pi epsilon only. Therefore now, so this is the spherical conductor. Next parallel plate capacitor. Parallel plate capacitor. So inside the parallel plate capacitor, so let's go somewhat fast because it is a positive charge I have taken, and this is equal amount of negative charge we have taken, and this is the plus q and this is the minus q. The area of the each plate is A and the separation between them is D, parallel plate capacitor. And here just only few important points let us discuss. And the first and most important point is that what is the electric field between the two plates? The electric field is given by E is equal to Q by 2A epsilon naught is equal to sigma by 2 epsilon naught also you can write, because sigma is equal to charge per unit area, and this is the first point of electric field. And second point is what? Potential difference between the plates of the capacitor. V is equal to E into D. Because so already we have discussed electric field formula what E is equal to minus dV by dx if you take and for the uniform electric field you can take E is equal to so V by D, where D is the distance between the plate. Therefore this is for non-uniform, this is for the uniform. E is equal to V by D. Therefore because inside the plates of the capacitor the electric field is the uniform, E is equal to V by D. It is completely air only. If it is the air, now the capacitance is given by what? Epsilon naught A by D. Not need to discuss. But if it is completely filled, with a dielectric medium, now in that case, the C is equal to formula K. So epsilon naught A by D is equal to K into C naught. Therefore, capacitance C is equal to K into C naught. Capacity increases by how many times? K times capacity increases, right now. Therefore now, so keeping the dielectric completely in between the plates of the capacitor, C is equal to K into C naught. As I told you yesterday, dielectric constant value is always greater than 1. Therefore in this case you can say what? C always greater than C naught. Therefore the benefit of the introduction of the dielectric is so that it always increases the capacitance, right? Now, the third point is that, now in this only, now what is that? If it is partially filled, means what I am taking here. So, if the dielectric is partially filled like this, if the dielectric is partially filled like this and the thickness I am taking the TM and the dielectric constant, every dielectric material having one property, that is the dielectric constant. In such case, the effective distance is given by R is equal to D minus T plus T by K. Yesterday also in case of the force we got between any two charges, if you keep any dielectric material, the effective distance yesterday is different, today is a little bit different. D is the initial separation between the two plates of the capacitor, T is the thickness of the dielectric material given, and K is dielectric constant. Therefore now what? Here also you can write that is equal to D minus T into 1 minus 1 by K. 1 minus 1 by K we have given, and with partially filled, this is not fully filled. For the fully filled, what we have taken? C is equal to direct formula K into C naught. Not need to use this formula, but in this case it is not fully filled, means what? The dielectric is not fully filled, only the somewhat area we have used. Therefore in this case the capacitance C is equal to given by epsilon naught A by, in place of the D we have to take what? R. So that is equal to epsilon naught A by, so D minus T into 1 minus 1 by K. So expression very, very important. Here now tell me, here also capacity increases. Why? Because initially, so with air what we have taken? With air we have taken C naught is equal to epsilon naught A by D. Here the numerator is epsilon naught A, here also numerator epsilon naught A, but here what is that? Distance is D, here D minus something means what? From the distance you are deleting something, means denominator decreases, automatically capacitance increases. But in this case exactly how many times the capacity increases I don't know, but if it is a fully filled we can say yes, when a dielectric metal is fully filled, the capacity increases by K times. Therefore, C naught is equal to epsilon naught by AD. Therefore, this is the with partially filled. Now, let us discuss one numerical based on this. Now, here the capacitance with air is given by 10 microfarad. The distance between them D is equal to 4 centimeter and the thickness of the dielectric is equal to 2 centimeter, and so the dielectric constant K is equal to 2 I have given. Now they are asking what is the new capacitance and what is the percentage change in the capacitance. What we want? Two questions are there in the single. So now, C naught is equal, means what? Before introducing the dielectric, so C naught is equal to 10 microfarad and the separation between the two plates is equal to 4 centimeter and T is equal to 2 centimeter, K is equal to 2 Now in this case we have to find out what? So what is the new capacitance we have to find out, and also percentage change. See, everywhere whenever final value is given, along with that we have to find out percentage change also. Therefore, now what here I am taking that. Now first of all, new distance I want. What is the new distance? R is equal to D minus T plus so T by K. You substitute there, what you can get? D is equal to 4 minus 2 plus so 2 by so K. Therefore what? 2. Therefore now what you can get now, that is equal to 1. So means what? 4 minus 2 plus 1, that is equal to what? That is equal to 3 centimeter is the new distance. Right. Therefore now what? So here from the formula C naught is equal to adu epsilon naught A by D, and C is equal to what? C is equal to epsilon naught A by R. A by R, correct? Take the ratio. C by C naught is equal to, it is inversely proportional. Therefore now what you can get now? So D by R, I am taking that. Therefore now what? D by R, correct? Inversely proportional. Therefore now you substitute there, what you can get now? D is equal to how much now? 4, and R is equal to how much? That is a 3. Therefore C is equal to what now? So 4 by 3 into C naught is equal to 10. Therefore the new capacitance is equal to what? 40 by 3 microfarads. Right now the new capacitance we got what? So 40 microfarads. But one thing, if it is fully filled, what is the new capacitance? If it is a fully filled, the new capacitance is equal to what? C into, so what? The new capacitance C is equal to what? K into C naught, K value 2, C naught is equal to 10. Therefore that is what? 20 microfarad. So that is a more value, but this is how much, Nana? 40 by 3 means what? So I think 13.33 something. Therefore now 13.33 microfarads. Therefore this is the new capacitance. But what I am asking here now, what is the percentage change? Percentage change. Therefore yesterday we have discussed one problem. Therefore now what? Final value minus initial value into 100, right? Now minus 1 into 100 gives what? Percentage change. If it gives plus, therefore you can think that final value is more, means what? Capacitance increases. If this value is negative comes, therefore we can confirm. So this value, I mean capacitance decreases. Therefore C by C naught, that is what? 40 by 3 by, so 10 minus 1, so into 100. Therefore 40 by 3 means what? 40 by 30 minus 1 into 100. Therefore that is the 0 0 cancel. 4 by 3 means what? 1 by 3 into 100, that is equal to what? 33.3 percentage. Means what? We got plus or minus a plus, means what? Capacitance increases. Therefore this is one of the model in that case. Next. Now, one model for a multiple number of the dielectric cases. So, how to get multiple number of the dielectric cases? Now, so problem with multiple number of the dielectric cases. Right? Now, for example, see, I am taking that this is a capacitor. This is one capacitor. Its area is A and the separation between the plates of the capacitor D, and the capacitance without any media is given by what? Epsilon naught A by D. Keep aside equation number 1. Now what they will do that? What they will do that? For example, now here they will separate the gap between the two plates with the two dielectric medium. First one is K nana, second one is what, 2K, and here what, this distance is given by, so D by 2, here the distance is given by D by 2, and the area is the same, the area is A, here also area. Now what is the divided amma? Distance is divided, area divided, distance is divided because these two plates, I mean these two dielectrics are dividing the distance between the two capacitors into different parts. This is the D by 2, this is the D by 2. One thing you keep in mind, when distance is divided, those are in series. Means what? So here this dielectric forms one capacitor, another dielectric material forms another capacitor. Number of dielectrics is equal to number of capacitors. Initially only one capacitor. We will know ಎಷ್ಟು capacitor. So now what? One is K, one is 2K. Two different dielectrics always forms the different number of the capacitor. Therefore, two dielectrics are introduced. Therefore, two capacitor form. Those two capacitor what? They are in series form. And if the area is divided, now those are in parallel combination. Remember. So area divided first and distance divided. You check it. And D series and A parallel. Like that you remember. Therefore, now let's go individual capacitance. Now in this question what is the C effective? Total effective capacitance how much I want, and what is the effective dielectric also I want. Of course, you know this one, but how to find out the effective dielectric constant, let us discuss now. First of all, I will go for the first capacitance. So this forms first capacitance C1 and this forms second capacitance C2. Now tell me C1. C1 is equal to what? C1 is equal to its dielectric constant K, because it is acting as a fully filled case. Therefore, K into epsilon naught A, because area is the same. Distance how much? D by 2, that is equal to, this goes upside. Now what? 2K epsilon naught A by D. Right? But epsilon naught A by D, what we have assumed? Epsilon naught A by D we have assumed C naught. Better to take, because simplification becomes easier. So 2K C naught I have taken. Second one is what? So C2 is equal to its dielectric constant how much? 2K. Therefore, you substitute there in the formula 2K epsilon naught A by again D by 2 is equal to what? You can get 4K C naught, because again epsilon naught A by D is equal to 2K C naught. Now tell me, those are in series or parallel? Now here the distance is D by 2, here the distance is D by 2. So now as I told you, when the distance is divided, those are compulsory in a series. Therefore, now the effective formula what? Effective capacitance formula in series combination. C effective is equal to what formula? That is equal to C1 C2 by C1 plus C2, because 1 by Cs is equal to 1 by C1 plus 1 by C2. If you simplify, you are getting that C effective is equal to C1 C2 by C1 plus C2. That is equal to C1 value how much? That is 2K into C naught plus 4K into C naught by C1 plus C2, 2K C naught plus 4K C naught, total 6K C naught. Right now, 1 C naught cancel, 1 K get cancel, here 1 2 ones and 2 3s. Finally, what is the answer here? So 4K C naught by what? That is a 3. Therefore, this is the new capacitance of the system given in the figure or given in the diagram. What that? 4K, any mistakes? Therefore, now what here 2 3s are. Therefore, K is there, 4K C naught by, so 3 is there. Therefore, now what? So 3. Therefore, K cancels, C can. Therefore, this is the effective capacitance. But now what I am asking, that not only effective capacitance, I am asking what? Effective dielectric also. One thing you keep in mind, whenever always you compare C effective is equal to K effective into C naught. This is formula. So if you compare this one, C effective is always equal to what? K effective into C naught. So here what is there? If you compare, so C effective is equal to, in place of the K effective, what is there? Now 4K by 3 into what? Into C naught. Therefore, now you can compare, if you compare this one, K effective is always equal to, so what? That is equal to 4K by 3 is the answer for that. Therefore, not only need to find out the effective capacitance, you have to find out so effective what? Dielectric constant also. Right now, so this is one model, and you can solve like this also. You can take a multiple number of capacitance also, like this also you can find out. For example, same question Same question, but what I will change here exactly I am taking that this is the k and this is the 2k I am taking that. So one is the k, one is the 2k, and therefore here what is divided among area divided, therefore this is the a by 2 and this is also a by 2. In this case distance is divided, in this case area divided. When area divided, those are in parallel. So in this case individual means what, initial values you have to find out. C1 value estimate, C1 is equal to, so what, that is equal to k into epsilon naught a by 2. So you see area is a by 2 by what, by d, and after simplification you can get what, k epsilon naught a by 2, a by 2 nothing but what, that is equal to, so what, that is k epsilon naught a by, so 2d, and C1 is equal to given by, so k C naught by 2. Similarly, here what you are getting this one, how much, C2 is equal to k, which we get 2k, so epsilon naught a by 2 by d, this 2 cancel, and C2 is equal to k into C naught. And again both are in parallel because here area is divided, so this parallel combination is easy. Therefore Cp is equal to just C1 plus C2 only, and that is given by what? That is given by C1 plus C2 is estimate, that is equal to k C naught by 2 plus k C naught, that is equal to 3 by 2 k C naught. Therefore that is the effective, so effective capacitance when the capacitors are arranged like this. Therefore in this case is what is the effective dielectric constant, as I told you. So what, C effective or Cp is equal to, so 3 by 2 k into C naught, and C effective is equal to, so that is what, that is equal to k effective into C naught. Therefore in place of the k effective, what is that, k effective is equal to 3 by 2 3k by 2. So this is the answer for that. Okay, na? Therefore now this is the capacitance sum, and still so tomorrow let us discuss about the current electricity. Thank you all.
Okay, right. Good afternoon, dear students. Today we will discuss some more important concepts from organisms and populations. Among them, first one about growth models. Two types of growth models are there, right? One is exponential growth curve. Exponential growth curve. So, two types of growth curves we can see. Among them, the first one is exponential growth curve. Exponential growth curve occurs generally when resources are unlimited. Exponential growth curve occurs when resources are unlimited. That means when a food and space is abundant for any species, those species utilizes that unlimited resources and increases their population very huge in a short period of time, because no factors restrict the growth of such kind of population. So generally we can see such type of exponential growth curve in the case of some laboratory populations, and also in the case of some insects populations also we can see exponential growth curve. Here laboratory populations means what? So generally you can take the microbes which are growing, culturing in the laboratory on a culture plate on a specific nutrient medium are called laboratory populations, like bacteria, fungi, so called, right. So here just you can take a bacteria which is obviously multiply their number or reproduces young ones by the process called binary fission. It is one type of asexual process, right ma? So by the binary fission, one paramecium can produces 2 paramecium again 4, 8, 16, like that. So in a geometric fashion, the population size will be very huge in a short period of time. Atara imagination ಮಾಡ್ಕೊಳ್ಳಿ 1 hour ಗೆ 1000 parameciums na produce ಮಾಡಿದೆ by binary fission ಅನ್ಕೊಂಡ್ರೆ after 2 hours, so that may be multiplies, after 3 hours, after 4 hours. So the population size will be very huge and exponential. Understand? So here exponential growth curve will occurs when resources are unlimited. Resources means what here? Unlimited resources means like food and shelter will comes under resources. When food and shelter is unlimited, any species can be increases their population exponentially and within a short period of time, because there is no competition, etc. Then in which kind of populations we can see such type of exponential growth curve? Means we can see exponential growth curve in some laboratory populations and also in case of some insects. Other than that, in the natural populations which are present on the earth, like mammals, reptiles, birds, amphibians, in such type of populations we can't see exponential growth curve, because for these species resources are unlimited, not limited resources. So under limited resources exponential will be not happens, okay. And the third one, suppose see if you plotted a graph for exponential growth curve. So this is an x-axis, it is an y-axis. On x-axis what we will take? We will take a time. On y-axis population density. Population density. Yeah, or population size. Here initially, actually what happens in the exponential growth curve means if you can take some laboratory population like paramecium or any insects population so called. Initially, as the time gone, the size of the population is also slowly growing. See, in the initial stages, the growth curve will be not straight immediately. It will be a slope, we get it, right. So this is called lag phase, we call it. What do we call it, ma? Lag phase. Lag phase means during this phase or nothing but initial population of any species do not multiply rapidly. It will take time to adjust that new environmental conditions, so called the growth rate in the case of lag phase is very slow growth. So in the lag phase, what will be the growth rate ma? Very slow. Why the growth of the population in lag phase is very slow? Because during lag phase, the organisms, they need to adjust, cope with that environmental conditions. If once they adjusted such type of new environmental conditions, then by utilizing unlimited resources, the population increases in a geometric fashion. This is called second phase of exponential growth curve, that is called as log phase, or also known as exponential phase. Exponential phase ಅಂತನೂ ಕರೀತಾರೆ. ಈ ಲಾಗ್ ಫೇಸ್ ಎಕ್ಸ್ಪೊನೆನ್ಷಿಯಲ್ ಫೇಸಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ, ಈ ಲ್ಯಾಬೊರೇಟರಿ ಪಾಪ್ಯುಲೇಷನ್ಸ್ ಒಮ್ಮೆ ಆ ನ್ಯೂಟ್ರಿಯೆಂಟ್ ಮೀಡಿಯಮ್ಗೆ ಅಡ್ಜಸ್ಟ್ ಆಗಿದೆ ಅಂದ್ಕೊಳ್ಳಿ, ಆ ನ್ಯೂಟ್ರಿಯೆಂಟ್ಸ್ನ ಯುಟಿಲೈಸ್ ಮಾಡಿಕೊಂಡು ವೆರಿ ರ್ಯಾಪಿಡ್ಲಿ ವಿತಿನ್ ಸೆವರಲ್ ಅವರ್ಸ್ ಒಳಗಡೆ ಅದ್ರ ಪಾಪ್ಯುಲೇಷನ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಾ ದರ್ ಪಾಪ್ಯುಲೇಷನ್ ವಿಲ್ ಬಿ ರೀಚಸ್ ಎನಾರ್ಮಸ್ ವಿತಿನ್ ಎ ಶಾರ್ಟ್ ಪೀರಿಯಡ್ ಆಫ್ ಟೈಮ್. ಅಂದರೆ ಈಗ ನಾವು ತಗೊಳ್ಳಿ, ನಮ್ಮಿಂದ ನ್ಯೂ ಜನರೇಷನ್ಸ್ ಬರಬೇಕಂದ್ರೆ ಸಮ್ ಥೌಸಂಡ್ಸ್ ಆಫ್ ಇಯರ್ಸ್ ನಾವು ವೆಯ್ಟ್ ಮಾಡಬೇಕು, 10-20 ಜನರೇಷನ್ಸ್ ಬರಬೇಕು ಅಂದರೆ. ಬಟ್ ಇನ್ ದ ಕೇಸ್ ಆಫ್ laboratory populations like paramecium or any bacteria or any other unicellular organisms, within several hours their population into millions. Okay, so the growth curve will be exponential like this. If we observe carefully, the shape of the growth curve is, obviously it will represent J-shaped curve. This is called as J-shaped curve we obtained. So in the exponential growth curve, what is the shape of the growth curve means J-shaped. J-shaped curve will be obtained. Okay, what will be the reason for J-shaped curve ma? Because of unlimited resources. Under unlimited resources, the population will be multiplies very rapidly within a short period of time. And you remember, in the exponential growth curve, two phases are involved. How many phases are involved? Two phases. Two phases are involved. The two phases, one is lag phase, another one is log phase. In the lag phase, it is an initial population. That population growth will be very slow. And second one is called log phase. In the log phase, it is the population will be exponential or very rapid growth we can see in it. These are the two phases we can generally observe in the exponential growth curve. Okay, and then there is one graphical equation is available for J-shaped curve. So what is an equation means? That is dn by dt is equal to Rn. This is called a graphical equation for exponential growth curve. So how this equation actually got means, if you think, if any population, if birth rate is B, then the death rate will be D, right? And the number of, the population is increased or decreased will represent dn by dt. Then we can get this equation. Dn by dt is nothing but what ma? It represents the population size may be increased or decreased. That is called dn by dt. Then R stands for what means B minus D. B minus D andre illi birth rate minus death rate. In any population, number of births minus number of deaths is equal to actual increase of rate of population size is called R, and N andre illi normal population density of the any species. Okay ma? So this is called a graphical equation of exponential growth curve. dN by dt is equal to Rn. ಈ equation ಇಲ್ಲಿ R stands for what ma? R stands for B minus D. B minus D is equal to R. dN by dt stands for what ma? The population size increased or decreased. The size of the population whether increases or decreases depends upon what? Birth rate minus death rate. R value will decide the population size after a period of time. Understand? And this is an equation, graphical equation we use for the exponential growth curve. And along with this equation, one more equation is also available for exponential growth curve. That is very, very important. Integral form of equation. Exponential growth curve having an integral form of equation for exponential growth curve, that is n t is equal to n naught e to the power of RT. Dear students, n t is equal to n naught e to the power of RT. Here n t stands for what ma? Population density after time t. What n t stands for ma? Population density after time t. So after time t andre after 1 hour or after several minutes later, after some days, after several months, after several years, whatever it may be. So after sometimes what will be the actual population annadana idu represent madutte. Second one, n naught means here population density at time 0. Population density at time 0. It represents present population size. And third one, E stands for base of natural logarithms. Base of natural logarithm. That means it has a specific logarithm value like 2.7168 anta. So this log value is very, very essential to calculate some problems regarding exponential growth curve. Okay, and last one, R stands for the rate of natural increase of population. Rate of natural increase of population, or also we can say that intrinsic rate of natural increase antanu helbodu navu. Intrinsic rate of natural increase will be R value, or also we can say that birth rate minus death rate, B minus D antanu helbodu. R stands for birth rate minus death rate, or B minus D, or intrinsic rate of natural increase, or rate of natural increase of population will represent. Okay na? And last one, the T stands for time. So this is what an integral form of exponential growth curve equation ma. And then is there any carrying capacity is operated in the exponential growth curve means no. Why? Because here no carrying capacity is operated because resources are unlimited. Under unlimited condition, population will be exponential. And next one, the growth curve is not realistic one. Not realistic one. The growth curve is not a realistic one. That means we cannot predict J-shaped curve all the time, forever. Why? Because suppose today we are growing a paramecium population in our laboratory on a petri dish plate. So up to here the population is increases. Now suddenly we stop giving nutrient for that paramecium. As a result, the paramecium population will stop here only. Do not increases their population. So it is unpredictable curve, so called not a realistic one. Exponential growth curve or J-shaped growth curve is not realistic one because ಯಾವಾಗಲೂ ಜೆ ಶೇಪೇ ಬರುತ್ತೆ ಅಂತ ನಾವು ಹೇಳೋಕ್ಕಾಗಲ್ಲ. ಯಾಕಂದರೆ ಸಡನ್ಲಿ ನಾವು ಆ ಅನ್ಲಿಮಿಟೆಡ್ ರಿಸೋರ್ಸಸ್ನ ಕೊಡೋದು ಸ್ಟಾಪ್ ಮಾಡಿದ್ದೀವಿ ಅಂದ್ಕೊಳ್ಳಿ, ಅದರ ಪಾಪ್ಯುಲೇಷನ್ನು ಅಲ್ಲೇ ಸ್ಟಾಪ್ ಆಗುತ್ತೆ. ಬಟ್ ನಾವು ನೇಚರಲ್ಲಿ ಆ ಥರ ಎನಿ ಪಾಪ್ಯುಲೇಷನ್ನ ಕಂಪ್ಲೀಟಾಗಿ ಸ್ಟಾಪ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ಸೊ ದಿಸ್ ಈಸ್ ಒನ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್. ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ ಐ ಯೂಸ್ಡ್ ದ ವರ್ಡ್ exponential growth curve we can see in some laboratory population and also some cases of insects too. Insects alli also, for example nodi, during rainy season alli because of rain water all the plants grow very nicely, leaves, fruits and all plant parts are very abundant and rich. So insects will get sufficient food for them. As a result, the insects population during rainy season will increases like an exponential. We got J-shaped curve. But suddenly after rainy season, what happens? The plant parts loses all their greenery, right? So because of lack of food, insects population is completely decreased, vanished. So in such conditions, which shaped curve we can see andre J shaped curve maatrane, yakandre rainy season ga maatrane curve replicable agutte. Sir, why not logistic growth sir andre ಇಲ್ಲಿ ರೈನಿ ಸೀಸನ್ ಆದಮೇಲೆ ಪಾಪ್ಯುಲೇಷನ್ ಕಂಟಿನ್ಯೂ ಆಗಲ್ಲ, ಪಾಪ್ಯುಲೇಷನ್ ಟೋಟಲ್ ಡಿಕ್ಲೈನ್ ಆಗುತ್ತೆ. ಪಾಪ್ಯುಲೇಷನ್ ಕಂಟಿನ್ಯೂ ಆಗಿದ್ದರೆ ನಾವು ಲಾಜಿಸ್ಟಿಕ್ ಗ್ರೋತ್ ಎಸ್ ಶೇಪ್ಡ್ ಕರ್ವ್ ಅಂತ ಹೇಳ್ಬೋದಾಗಿತ್ತು. ಬಟ್ ಬಿಕಾಸ್ ಆಫ್ ಲ್ಯಾಕ್ ಆಫ್ ಫುಡ್ ಪಾಪ್ಯುಲೇಷನ್ ಕಂಪ್ಲೀಟ್ಲಿ ಕೊಲ್ಯಾಪ್ಸ್ಡ್. ಸೊ ಕಾಲ್ಡ್ ಜೆ ಶೇಪ್ಡ್ ಕರ್ವ್ ವಿ ಅಬ್ಟೈನ್ಡ್ ವೆನ್ ವಿ ಪ್ಲಾಟೆಡ್ ಎ ಗ್ರಾಫ್ ಫಾರ್ insects during rainy season. You note this point, dear students, very very important. And also here I said R value, R stands for B minus D. This R value is not same for all the species, and even R value will changes from one country to another country, one state to another state sometimes. How means, for example, some R values, you can take R value for Norway rats is equal to 0.015. What is the R value for Norway rat ma? 0.015. And R value for Norway floor beetles, it is 0.12. Similarly, an R value for human population in India in the year of 1981, that is 0.0205. If you observe carefully, dear students, see R value is not same for different species. From one species to another species, even in the same country, floor beetles one type of R value is there, and rats is also having one type of R value, and human population. That means for species to species, for country to country, even within the country from region to region, R value will be changes. For competitive purpose, you must remember these R values ma. So that is about exponential growth curve. Okay na? So we'll discuss the problems at the end of logistic growth curve. Okay. Second one, logistic growth curve. Logistic growth model or growth curve. Logistic growth curve is also known as Verhulst-Peer logistic growth because this uncle proposed this concept. Here it is completely different from the exponential growth curve. For example, logistic growth curve we can see in only natural populations. That means other than laboratory populations and some insects or any small body sized insects and organisms bittu. Yakandre small body size organisms, less lifespan organisms ge carrying capacity almost iralla. Yakandre iga mosquitoes tagoli ಅದಿರೋದೇ ವೆರಿ ಸ್ಮಾಲ್ ಬಾಡಿ ಸೈಜ್, ಅದಕ್ಕೆ ಬೇಕಾಗಿರೋಷ್ಟು ಫುಡ್ ರಿಸೋರ್ಸಸ್ ಅಬಂಡೆಂಟ್ ಆಗಿರುತ್ತೆ ಈ ವರ್ಲ್ಡಲ್ಲಿ. ಸೊ ಅಂಥ ಸ್ಪೀಸೀಸ್ ಎಕ್ಸ್ಪೊನೆನ್ಷಿಯಲಿನೇ ತೋರಿಸುತ್ತೆ. ಬಟ್ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಅದರ್ ದೆನ್ ದಿ ಸ್ಪೀಸೀಸ್, ಯಾವುದೇ ಸ್ಪೀಸೀಸ್ ನಮ್ಮ ಅರ್ಥ ಮೇಲೆ ಯಾವುದಕ್ಕೂ ರಿಸೋರ್ಸಸ್ ಅನ್ಲಿಮಿಟೆಡ್ ಇರಲ್ಲ, ಲಿಮಿಟೆಡೇ ಇರುತ್ತೆ. ಅದು ಸ್ಪೇಸ್ ಆಗಿರ್ಬೋದು, ಫುಡ್ ಆಗಿರ್ಬೋದು. ಸೊ ಇನ್ ದಟ್ ಕನ್ಸರ್ನ್ ದ ಲಾಜಿಸ್ಟಿಕ್ ಗ್ರೋತ್ ಕರ್ವ್ occurs when resources are limited. When resources are limited. Here resources means, dear students, you must remember that includes food and shelter or space. That means when resources are limited, we can take a graph. So this is x axis, y and x. Here we will take time t, here we will take population density PD. So in the logistic growth curve, and what shape of curve and how the curve will be grow, we'll see now. So any population in the nature, natural population, they have limited resources. Under limited resources means what here? For example, you can take in the graph, this is represents limited resources, nothing but K. For any natural population in the nature, carrying capacity is operated. Carrying capacity means the maximum number of individuals of the population supported by the environment with sufficient resources. The maximum number of individuals of the population supported by the environment with sufficient resources is called carrying capacity or K value ಅಂತ ಕರೀತಾರೆ. ಅಂದರೆ ಒಂದು ಎನ್ವಿರಾನ್ಮೆಂಟಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಸ್ಪೀಸೀಸ್ ಪಾಪ್ಯುಲೇಷನ್ ಗ್ರೋ ಆಗೋದಕ್ಕೆ ಎಷ್ಟು ಜನಕ್ಕೆ ಬೇಕಾಗಿರೋ ಸಫಿಷಿಯೆಂಟ್ ಫುಡ್ಡು ಶೆಲ್ಟರ್ನ ಆಫರ್ ಮಾಡುತ್ತೋ, ಸಪೋರ್ಟ್ ಮಾಡುತ್ತೋ, ಅದನ್ನೇ ಕ್ಯಾರಿಂಗ್ ಕೆಪಾಸಿಟಿ ಅಂತ ಕರೀತಾರೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ದಿಸ್ ಕ್ಲಾಸ್ ರೂಮ್ ಕ್ಯಾರಿಂಗ್ ಕೆಪಾಸಿಟಿ 80 ಮೆಂಬರ್ಸ್ ಅಂದ್ಕೊಳ್ಳಿ. ಅಂದರೆ 80 ಮೆಂಬರ್ಸ್ ಕೂತ್ಕೊಳ್ಳೋದಕ್ಕೆ ಪ್ಲೇಸ್, ಲೈಟ್, ವಿಂಡೋಸ್, ಎವ್ರಿಥಿಂಗ್ ಈಸ್ ಅವೈಲಬಲ್. More than 80 members, what will happen, sir? No seats for sitting and fans and shelter, front benches are so called, right? What will happen? Because of limited resources, competition existed between the organisms. Here also same thing will happen. Within that competition, a stronger one survive, weaker one will be eliminated. Then the population will be stable. Okay? So similarly, I'll try to explain. In the logistic growth curve, under limited resources, what happens? Any natural population initially will take time to grow, because these organisms needs to adjust that new environmental conditions initially, so called, they do not divide rapidly. It will take some time. So that sometime is called a lag phase, we call it. Lag phase. In the lag phase, what will be the growth status of population, ma? Very slow. It is a initial population, it is a slow growth we have. And second leads to, if once that organisms are adjusted to the environment, then the population multiplies very rapidly and increases like in a geometric fashion. So this second rapid growth phase is called log phase, also known as acceleration phase. Acceleration phase, also known as exponential phase. In natural populations also, until carrying capacity, exponential phase is available, okay, not forever, okay na, but at early growth stage we can see exponential growth curve. Now if once the population is increases enormously in a log phase or acceleration phase, because still the population size is not reaches to the limited resources carrying capacity. Until to reach carrying capacity, they divides very rapidly and increases their population into lag phase or exponential phase or acceleration phase, right? And when that population is increases and closer to the carrying capacity, that means the sufficient resources for that population is already completed. Then what will happen? When resources are limited, population size is increases, then the competition occurs between the organisms. So under limited resources, what happens ma? The competition occurs between the organisms. Among them, superior one or stronger one survived and weaker one will be eliminated. That is what happens. Andre, within this competition, within this fight, some individuals are died. As a result, population size will slowly started to decrease like this small curve. This is called deceleration phase. Deceleration phase. Yeah. Deceleration, acceleration opposite. In the acceleration phase, population size will be accelerated, increases. In the deceleration phase, because of limited resources, competition existed between the organisms. Because of that competition, the population size will be decreases. Okay, when the population density, yellow color line, carrying capacity, white color line, when these two becomes equal, that means K is equal to N. When K is equal to N, andre carrying capacity mattu population size yavage equal agutto avage population growth will be 0. Andre ಇದು ಆದಮೇಲೆ ಎಷ್ಟೇ ಜನ ಪಾಪ್ಯುಲೇಷನ್ ಹುಟ್ಟಲಿ ಅದರಲ್ಲಿ ಕಾಂಪಿಟೇಷನ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಿ ಬಿಕಾಸ್ ಆಫ್ ಲ್ಯಾಕ್ ಆಫ್ ಫುಡ್, ಲ್ಯಾಕ್ ಆಫ್ ಶೆಲ್ಟರು, ಲ್ಯಾಕ್ ಆಫ್ ಮೆಡಿಕೇಷನು, ಲ್ಯಾಕ್ ಆಫ್ ಅದರ್ ನೀಡ್ಸಿಂದ ಡೆತ್ ಆಗಿಬಿಟ್ಟು ಪಾಪ್ಯುಲೇಷನ್ ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ದ ಲಾಸ್ಟ್ ಫೇಸ್ ಈಸ್ ಕಾಲ್ಡ್ asymptote phase. Asymptote phase andre in the asymptote phase zero growth of the population. When it is happens, sir, when carrying capacity is equal to population density will be 0. ಯಾವಾಗ k plus n ಈಕ್ವಲ್ ಆಗುತ್ತೋ ಸಮಾನ ಆಗುತ್ತೋ ಅವಾಗೆ ಪಾಪ್ಯುಲೇಷನ್ ಗ್ರೋತ್ 0 ಆಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗಲ್ಲ, ಡಿಕ್ರೀಸು ಆಗಲ್ಲ. ಸೊ ಅದರಿಂದ ಆ ಕಂಡೀಷನ್ನ ಅಸಿಂಪ್ಟೋಟ್ ಅಂತಾರೆ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾ? ಸೊ ಆಸ್ ಅ ರಿಸಲ್ಟ್ ವಿ ಗೆಟ್ ಎ ಕರ್ವ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಶೇಪ್ಡ್ ಕರ್ವ್. ಲಾಜಿಸ್ಟಿಕ್ ಗ್ರೋತ್ ಕರ್ವ್ ಈಸ್ ಎಸ್ ಶೇಪ್ಡ್ ಕರ್ವ್ ಆರ್ sigmoid curve we will be obtained forever. ಯಾವಾಗೆ ಯಾವ ನ್ಯಾಚುರಲ್ ಸ್ಪೀಸೀಸ್ಗೆ ಎಲ್ಲಾದರೂ ನೀವು ಗ್ರಾಫ್ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡಿರಿ ಎಸ್ ಶೇಪೇ ಬರುತ್ತೆ, ಬರಬೇಕು, ಬರಲೇಬೇಕು. ಯಾಕಂದರೆ ಇವೆಲ್ಲ ಸ್ಪೀಸೀಸ್ಗೆ ರಿಸೋರ್ಸಸ್ ಲಿಮಿಟೆಡ್ ಆಗಿರೋದ್ರಿಂದ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾ? ಸೊ ದಟ್ ಈಸ್ ಎಸ್ ಶೇಪ್ಡ್ ಕರ್ವ್. ಆ್ಯಂಡ್ ಹಿಯರ್ ಇನ್ ದ ಲಾಜಿಸ್ಟಿಕ್ ಗ್ರೋತ್ ಕರ್ವ್ carrying capacity plays very crucial role. Am I right ma? So K is must be operated. Andre after carrying capacity population size do not increases, up to carrying capacity population size will be increases. Understand? As a result in the carrying capacity, I mean logistic growth curve, total we can see in 4 phases. In the logistic growth curve we can see how many phases ma? 4 phases. What are that? Number 1, lag phase. In the lag phase, it is the initial population growth is very slow. Second one is called what ma? Log phase. It is the second phase where the population size will be very rapid and exponential. And the third one is deceleration phase. Deceleration phase. In the deceleration phase, population size will be decreases. And last one is called asymptote. Asymptote phase. Here the population growth curve will be 0. Population will be 0 ma. That means no increase and no decrease will be takes place. These are the 4 important phases. Observe very carefully. You may chance to get a question from these topics. So be clear. And next one, the logistic growth curve equation. So we can represent with dn by dt is equal to Rn K minus n by K. What is an equation? We use it for logistic growth curve means dn by dt is equal to Rn into K minus n by K. You already know that R stands for intrinsic rate of natural increase, n population density, K carrying capacity. Understand? And so the growth curve, logistic growth curve will be more realistic one. More realistic one. You know why? Why logistic growth curve is more realistic one ma? Because it is predicted curve. Okay? ಯಾವ ಪಾಪ್ಯುಲೇಷನ್ ನಾವು ಗ್ರಾಫ್ ಡ್ರಾ ಮಾಡಿದ್ರು ಎಸ್ ಶೇಪೇ ಬರುತ್ತೆ. ಯಾಕಂದರೆ ಇವರೆಲ್ಲರಿಗೂ ರಿಸೋರ್ಸಸ್ ಲಿಮಿಟೆಡ್ ಆಗಿ ಇರೋದ್ರಿಂದ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಮೋರ್ ರಿಯಲಿಸ್ಟಿಕ್ ಒನ್. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ನೌ ಲೆಟ್ ಅಸ್ ವಿಲ್ ಸಿ ಅ ಫ್ಯೂ ಪ್ರಾಬ್ಲಮ್ಸ್ ರಿಗಾರ್ಡಿಂಗ್ exponential growth curve and logistic growth curve. Okay ma? Right. Next, problems. Okay. First, problem number 1 regarding exponential growth curve. Okay. First one, in 2005, in the year of 2005, there are 14 millions people present in a country. How many people present in a country ma? 14 million peoples are present in a country in the year of 2005. And also in that country nearly 0.0 0 to 8 members were born. That means 0.028 born means what we have to take birth rate. B is equal to 0.028, comma D death rate is equal to 0.008. This is happens in 1 year. In a year. Then by using exponential equation, already you know that exponential equation, right? Exponential equation, the number of, how many number of peoples present in 2015 is predicted as. Yeah, this is the question, dear students. So question is very clear. In 2005, in the year of 2005, in a country, the population size is 14 million. And that country birth rate is 0.028 they given, death rate 0.008 also they given, and by using exponential equation, that is called dn by dt is equal to rn, is the exponential growth curve equation. How many number of peoples present in 2005 predicted ಅಂತ ಎಷ್ಟು ಜನ ಇರಬಹುದು ಅಂತ ಪ್ರಿಡಿಕ್ಟ್ ಮಾಡ್ರಿ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಇದಕ್ಕೆ ಫಸ್ಟ್ ನಮಗೆ ಕ್ವಶನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋ ವ್ಯಾಲ್ಯೂಸ್ ನೋಡಿ. ದ ಆನ್ಸರ್ ಈಸ್ ಫಸ್ಟ್ ಸ್ಟೆಪ್. ಸೊ n is equal to n 2005 is equal to 14 millions they given. This is n. Second, R value also they given, because B minus D, R is equal to what ma? B minus D, B 0.028, D 0.008, together comes R value, that is 0.02. This 0.02 is a normal R value, right? So what is the R value ma? 0.02 is the right one. So 0.02 ಹೇಗೆ ಬಂದಿದೆ ನಮಗೆ ಇಲ್ಲಿ? B minus D, birth rate they given, death rate also they given. Birth rate minus death rate is equal to 0. R value nothing but 0.02, and also they given time duration T is equal to ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? n 2015 minus n 2005 is equal to 10 years. ಹೌದಮ್ಮ? ಸೊ ಈಗ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ನಂಬರ್ 1, we have to find out dn by dt. dn by dt formula what? dn by dt is equal to rn. ಇದನ್ನೇ ಈ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, is equal to dn by dt. R value how much ma? 0.02 into n ma? N how much? 14 millions is equal to dn by dt per year. That means 2005, in the year of 2005 to 2006, in 1 year R value will be 0.28 millions. ಇದು 0.28 ಅನ್ನೋದು ಹೇಗೆ ಬಂದಿದೆ? ನಾರ್ಮಲ್ ಆರ್ ವ್ಯಾಲ್ಯೂ ಪರ್ ಇಯರ್ ಇಂಟು 14 ಮಿಲಿಯನ್ ಪಾಪ್ಯುಲೇಷನ್ ತಗೊಂಡ್ರೆ ವಿತಿನ್ ಈ 1 ಇಯರಲ್ಲಿ ಇಷ್ಟು ಜನ ಇನ್ಕ್ರೀಸ್ ಆಗಿದ್ದಾರೆ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆರ್ ವ್ಯಾಲ್ಯೂ ಫಾರ್ 1 ಇಯರ್ ಫಾರ್ 14 millions. You understand? Now ಎಷ್ಟು ಇಯರ್ಸ್ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? 10 ಇಯರ್ಸ್ಗೆ. ಸೊ 1 ಇಯರ್ಗೆ 0.28 ಮಿಲಿಯನ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆದರೆ 10 ಇಯರ್ಸ್ಗೆ ಸ್ಟೆಪ್ ನಂಬರ್ 2 dn is equal to R value for 1 year 0.28 millions into how many years? 10 years is equal to 2.8 millions. 2.8 millions. Ma 2005 ಇಂದ 2015 ಈ 10 ಇಯರ್ಸಲ್ಲಿ ಎಷ್ಟು ಪಾಪ್ಯುಲೇಷನ್ ಹೊಸದಾಗಿ ಇನ್ಕ್ರೀಸ್ ಆಗಿದ್ದಾರೆ ಅಂದರೆ ಇವರು 14 ಮಿಲಿಯನ್ಸ್ ಮೇಲೆ ಇಷ್ಟು ಜನ ಈ 10 ಇಯರ್ಸಲ್ಲಿ ಜಾಸ್ತಿ ಆಗಿದ್ದಾರೆ ಆ ಕಂಟ್ರಿಯಲ್ಲಿ. ಓಕೆ, ದಿಸ್ ಇಸ್ 10 ಇಯರ್ಸ್ ಆರ್ ವ್ಯಾಲ್ಯೂ, DN ವ್ಯಾಲ್ಯೂ. ದೆನ್ ಇನ್ ದ ಕ್ವಶನ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ವಾಟ್ ಈಸ್ ದ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಪಾಪ್ಯುಲೇಷನ್ ಪ್ರಿಡಿಕ್ಟೆಡ್ ಇನ್ ದ ಇಯರ್ ಆಫ್ 2015. ಅಂದರೆ ಅವಾಗ ಈ 10 ಇಯರ್ಸ್ ಗ್ರೋತ್ ಪ್ಲಸ್ 2005 ಪಾಪ್ಯುಲೇಷನ್ ಒರಿಜಿನಲ್ ಪಾಪ್ಯುಲೇಷನ್ ಆ್ಯಡ್ ಮಾಡಿದರೆ 2015 ಪಾಪ್ಯುಲೇಷನ್ ಬರುತ್ತೆ. ಹೇಗೆ ಅಂದರೆ ಥರ್ಡ್ ಸ್ಟೆಪ್ ವಿಲ್ ಬಿ n 2015 is equal to dn plus n 2005. So substitute the value dn 2.8 millions into 2005 population 14 millions is equal to approximately 16.8 millions or approximately 17 millions will be the predicted population in the year of 2015. You got it, ma? So this is one of the important problem regarding exponential growth curve. And next one, problem number 2. So here is the problem number 2. Okay, if a population of 50 paramecium, if a population of 50 parameciums, okay, present in a pool, a population of 50 parameciums present in a pool, present in a pool, comma, then this population is increases into 150 after 1 hour. So in the first statement, a population of 50 paramecium present in a pool, ma, after 1 hour, how much population of parameciums are increased? 150. What is the time duration? 1 hour. Then what would be the growth rate of population? What is the growth rate of population? Anta kelta idare. Okay, this is the question. Here will be the answer. First 50 ಅನ್ನೋದು initial population final population ma, this is called n initial population alva. So ni is equal to 50 parameciums. Then final population is n small f is equal to 150 parameciums. Then dn by dt ತಗೊಂಡ್ರೆ n final population minus initial population, substitute the values, 150 minus 50 is equal to 100 individuals. Here R value how much ma? 100. then they are asking about what is the growth rate. That means dn by dt, dn by dt, dn what population 100 by dt, what is the time duration 1 hour, 1 hour. So what will be the result of growth rate? 100 individuals only. So this is the correct answer. Okay. So if a 50 parameciums present in a pool, after 1 hour that population will be increases into 150. What will be the growth rate andre? So 100 individuals per hour, 100 individuals per hour. In that scenario, the population of paramecium will be multiplies and increases. You got it, ma? Yeah. And the third problem is problem number 3. Problem number 3. Yeah. The question is, if B birth rate is equal to 85 and death rate is equal to 55, comma, population size will be 200, then find out the dn by dt and the question kelta ide. If in a population of any or any laboratory population, if birth rate is 85, if death rate is 55, the population size is 200, what will be the dn by dt? So what is the formula? Dn by dt is equal to Rn, alva. So here the answer is dn by dt is equal to Rn. Illi R estimate R value they given B and D, right? So R is equal to B minus D. That means 85 minus 55 is equal to 30. So we have to find out first R value 30 and also N how much ma? 200. So 30 R into 200. So is equal to approximately 6,000 will be the population size we can expected after some times. Okay. So these are a few examples for exponential growth curve, and then I will give one examples for logistic growth curve. So logistic growth curve problem number 1. Here is the question. In a population carrying capacity is 500 individuals, I mean carrying capacity is 500. The population size, that population size will be 400 and the R value for that population is equal to 0.01 and asking you to find out what is the dn by dt. So they are asking. So here what is the formula we use to calculate logistic growth curve for problems? That is dn by dt is equal to Rn into k minus n by k. Correct? So here dn by dt is equal to R value how much they given 0.01 into n, population size 400 into k value 500 minus 400 divided by 500. What will be the answer ma? That is 0.8. You understand? So these are a few problems regarding logistic and exponential growth curve. Okay. Now another important topic from organisms and population interactions. Among that population interactions, mainly you feel difficulty in competition and predation. Okay. So first I will try to explain competition. Competition. So here you know that already population interaction means an interaction takes place between the organisms of two different species. Organisms of two different species in which maybe two species are benefited, or maybe two species are harmed, or maybe one species is benefited, other species is unaffected, or maybe one species is benefited, other species is harmed, or maybe both the species are neutral. ಆ ಥರನೂ ಆಗೋಕೆ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಓಕೆ, ಅಮಾಂಗ್ ದೆಮ್. ಸೊ ವೆನ್ ವಿ ಆರ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ಕಾಂಪಿಟೇಷನ್ನು, ಇನ್ ದಿಸ್ ಕಾಂಪಿಟೇಷನ್, ಸೊ two different species of organisms are involved. Among them, species A, in this interaction, species A is not benefited, that is minus, and also even species B is also minus, not benefited. Okay, competition means it is an interaction between two different species of organisms. In that interaction, two species are harmed, no one is not benefited. So minus and minus. Minus means beneficial, detrimental ma? Detrimental interaction ಅಂತ ಕರೀತಾರೆ. ಡೆಟ್ರಿಮೆಂಟಲ್ ಅಂದರೆ ಮೈನಸ್, ಮೈನಸ್ ಅಂದರೆ ನಾಟ್ ಬೆನಿಫಿಟೆಡ್, ಇಟ್ ಈಸ್ ಹಾರ್ಮ್ಡ್ ಅಂತ ಅರ್ಥ. and plus means beneficial interaction, and 0 means neutral interaction. And here when we talk about competition, you know that the oldest definition for competition is the competition occurs between closely related species for limited resources is called competition. Okay, when the competition occurs between closely related species or same species, the competition occurs between closely related species or same species, then we call it as intraspecific competition. I repeat again, intraspecific competition occurs between closely related species or totally unrelated species. Means closely related species, that is also when resources are limited. When resources are limited. This is the oldest definition for competition. We can also call it as intraspecific competition. And the second one is competition not only occurs between closely related species, it is also occurs between unrelated species, between two unrelated species. Dear students, here unrelated species means different species. The competition not only occurs between the same species of individuals, will also occurs between the individuals of two different species for unlimited resources, not only when resources are limited, competition occurs. Even resources are unlimited. If resources are unlimited, then also competition will be occurs between unrelated species. For example, to prove this statement, see, two unrelated species in shallow South American lake, flamingos visiting flamingos. These are the bird species, and also resident fishes. Resident fishes means already the fishes which are living in shallow South American lake. These two different species, ಇಲ್ಲಿ bird fishes ಒಂದಕ್ಕೊಂದು comparison ಇಲ್ಲ. Two different species, unrelated species compete for the same food in a lake called zooplanktons. Zooplanktons means a smallest animal species ಈ ಸ್ಮಾಲೆಸ್ಟ್ ಝೂ ಪ್ಲಾಂಕ್ಟನ್ಸ್ ಆ ಲೇಕಲ್ಲಿ ಅಬಂಡೆಂಟಾಗಿ ಇದೆ. ಅಬಂಡೆಂಟಾಗಿ ಫುಡ್ ಇದ್ರೂ ಇಲ್ಲೇನಾಗ್ತಾ ಇದೆ ಅಂದರೆ ಈ ಫ್ಲೆಮಿಂಗೋಸ್ ಕಾಂಪಿಟೀಟ್ ಆಗೋದ್ರಿಂದ ಫಿಶಸ್ಗೆ, ಅಂದರೆ ಇವ್ರ ಮುಂದೆ ಹೋಗ್ಬಿಟ್ಟು ಇವ್ರಿಗಂತ ಮೊದಲೇ ಈ ಫ್ಲೆಮಿಂಗೋಸ್ ಅದನ್ನು ತಿಂದಾಗುತ್ತೆ. ಅದರಿಂದ ದಿ ಸ್ಕ್ಯಾರ್ಸಿಟಿ ಅನ್ನೋದು ಇದಕ್ಕೆ ಸಿಗೋಕ್ಕೆ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನು ಪ್ರೂವ್ ಮಾಡುತ್ತೆ ಅಂದರೆ ಫ್ಲೆಮಿಂಗೋಸ್ ಮತ್ತು ಫಿಶಸ್ ಟು different species, unrelated species compete for the same food known as zooplanktons. That means even resources are unlimited in that lake. Zooplanktons are unlimited, but the competition will occur to different species. This is also a definition for competition. And what type of competition it is, sir? Andre interspecific competition anta karitare. What do you call it, ma? Interspecific. Intraspecific competition means competition occurs between the same species. Interspecific competition means competition occurs between the two different species or between unrelated species. Okay, and the third statement is competition will be existed in different modes. For example, competitive interference. Here, what is competitive interference in the sense? The feeding efficiency of one species may reduced or may decreased in the presence of interference or inhibitory species of others, even resources are unlimited. Best example, same example here, see, zooplanktons is the unlimited food in the shallow South American lake. But here what happens when resident fishes are present? There is no competition. Resident fishes will depends upon the zooplanktons. Suddenly the flamingos are visited to this lake for the food of zooplanktons. As a result, here flamingos interferes with the fish food. As a result, feeding efficiency of fish will be decreased in the presence of another superior species or interference species. Understand, ma? So this is called competitive interference. And last, fourth one is competitive release. Here competitive means competitor, release means absence. So this statement explains that in the presence of superior species, the inferior species population will be decreases or very less. For example, if this superior species is experimentally removed, anಕೊಳ್ಳಿ, in the absence of this superior species, the inferior species population will be increases dramatically. Yakandre, it is not only applicable for these populations. If any population, when the superior is available, all the inferior species should be under the control, because the superior species will control the inferior species population. If they come out of their comfort zone, that superior species will go and kill them. As a result, their population will be very less before. If for experimental purpose, whether to prove this statement, if you removed all the superior species in that particular zone, inferior species within a short period of time increases dramatically their population all over the sea coast. So, best example done by Connell's elegant uncle. So, he was explained very perfectly regarding this topic. In the Scotland sea coast, there are two species of Balanus is available. Superior barnacle Balanus is the dominant one, and inferior barnacle Cathamalus is the recessive one. So, the superior barnacle Balanus in that sea coast dominated over the inferior species Cathamalus. As a result, Cathamalus population is very less and restricted to the small geographical area. If this scientist, Connell's elegant uncle, removed all the superior barnacles from that sea coast within a short period of time, Cathamalus population increases enormously all over that sea coast. Okay, that means competitive release. Andre in the absence of competitor, this is happens. Okay, so the remaining topics will continue. Time up. Thank you.
Hello all. As a part of discussion today, we are going to talk about the chapter called Solutions, in which we will discuss certain questions. So, I am starting from the first question. Here we have two statements, the statement 1, and these statements are all about the osmosis process, where there is semi-permeable membrane in between chamber 1 and chamber 2, where the first chamber contains 18 grams glucose in 100 milliliter of solution. In the second chamber, there is 30 grams of glucose in 250 milliliter of solution. Now, the statement 1 is water goes from chamber 1 to chamber 2. Second statement is osmotic pressure. Osmotic pressure of solution of a solution prepared by dissolving milligrams of potassium sulfate, molar mass is given 174 gram per mole, in 2 liter water is 0.0107 bar. This is the question. We have to identify if the statements are true or false. Let us start with the first statement. Osmosis ಯಾವ ಚಾಂಬರ್ದಿಂದ ಯಾವ ಚೇಂಬರ್ಗೆ ಹಾಕ್ತಾ ಇದೆ ಅನ್ನೋದು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ಅಂತಂದರೆ ಈ ಟೋಟಲ್ ಪ್ರಾಸೆಸ್ನಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಎಷ್ಟೆಷ್ಟದಾವೆ ಅನ್ನೋದು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ಫಸ್ಟ್ ನಾನು ಸ್ಟೇಟ್ಮೆಂಟ್ 1 ವೆರಿಫೈ ಮಾಡಲಿಕ್ಕೆ ಚೇಂಬರ್ 1ನಲ್ಲಿ ಎಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇದೆ ಅನ್ನೋದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಈಕ್ವಲ್ಸ್ W by M into 1000 divided by volume of the solution. Mass given is 18, molar mass is 180, 1000 divided by volume of the solution is 100. 100 in 1000 cancels for 10 times, which means the concentration is 1 mole, 1 molar in chamber 1. So moving to the chamber 2, what do we have here? Concentration equals weight 30, again glucose 180 into 1000 divided by 250 milliliter, which means this in this for 4 times, here 4 times, and this in this for 6 times. 4 by 6 is 2 by 3, which is 0.6 and 67 molar. So chamber 1 and chamber 2 ನಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಅನ್ನು ನಾವು ಐಡೆಂಟಿಫೈ ಮಾಡಿದರೆ ಚೇಂಬರ್ 2 ನಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ತುಂಬ ಕಮ್ಮಿ ಇದೆ, ಇದರಲ್ಲಿ ಜಾಸ್ತಿ ಇದೆ. therefore water travels from or water goes from second chamber to first chamber, but not from first chamber to second chamber. ಇದು ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ವಿಷಯ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದು. therefore statement 1 is false. whatever is given is false. ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಗೆ ಹೋಗೋಣ. ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು for the given data. So pi equals R. R value is in bar, therefore 0.083 into, it is potassium sulfate. Potassium sulfate ಆಗಿರೋದ್ರಿಂದ ಅದೊಂದು ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಬಂದಾಗ ವ್ಯಾಂಟ್ ಹಾಫ್ ಫ್ಯಾಕ್ಟರ್ ಖಂಡಿತ ಆಗಬೇಕು, ಅದು 3 ಆಗುತ್ತೆ. Temperature is actually given to be 300 Kelvin. I'll verify the temperature once again. Yes, the temperature is given to be 300 Kelvin, and then concentration of the solution. Concentration of the solution calculate ಮಾಡಬೇಕಂದ್ರೆ C concentration is W by M into 1000 by V. W is given to be 50 milligram, 50 into 10 to the power minus 3 into 1000 divided by molar mass of potassium sulfate is 174 into in 2 liters of water. So 1 by 2 can be written here. Instead of writing 1000 by V, you can write it as 1 by V in liters. Therefore it becomes 1 by 2. ಇದನ್ನೇ ನಾನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದರೆ 50 into 10 to the power minus 3 divided by 174 into 2. ಇದೆಲ್ಲ ಕೂಡ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗತ್ತೆ. And when we do that, this in this for 150 times 150 into 3 is 450. Therefore 0.083 into 450, and then we have into 50 again divided by 174 into 10 to the power minus 3. I just multiplied the 3 here. ಈ 2 ಈ 300 ನಲ್ಲಿ 150 times ಹೋಗುತ್ತೆ. ಈ 150 into 3 is 450. ಆ 50 into 10 power minus 3 is what we have here. So ನಾನು ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಲಿಕ್ಕೆ ಫಸ್ಟ್ 174 450 ನಲ್ಲಿ ಎಷ್ಟು ಸಲ ಅನ್ನೋದು ನೋಡ್ತಾ ಇದ್ದೀನಿ. So it is 2.174, maybe 8 or 9, let's check it out. That's too much, therefore maybe it is 6 times. Yeah, approximately 6. So we can take this as 2.6. Rest of the part calculation ಮಾಡಬೇಕೀಗ. ತೆಗೆದುಬಿಟ್ರೆ 2.6 into 5 ಈ 0 ಇದರಲ್ಲಿ 10 power minus 2 times. That is 13. So what we are left finally is 0.83 into 13 into 10 to the power minus 2. 83 into 13. If I do, so yes, we get 1079 here. 1079 into 10 to the power minus 2, which means 1.079 into 10 power minus 2, where I get approximately 0.0107 bar. ನಾನು ಇದನ್ನು ಇದಕ್ಕೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದರೆ I get this one. So statement 2 is definitely true. So let me explain this again. We have this semi-permeable membrane containing, osmosis tank being given here. ಈ osmosis tank ನಲ್ಲಿ ಫಸ್ಟ್ ಚೇಂಬರ್ ನಲ್ಲಿ 18 grams of glucose in 100 milliliter ತಗೊಂಡಿದ್ದಾರೆ. 30 grams of glucose in 250 milliliter ತಗೊಂಡಿದ್ದಾರೆ. ಇದರಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಲಿಕ್ಕೆ ನಾನು ಫಸ್ಟ್ ಚೇಂಬರ್ನಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ 1 ಮೋಲಾರ್ ಬಂದಿದೆ. ಸೆಕೆಂಡ್ ಚೇಂಬರ್ನಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ 0.667 ಬಂದಿದೆ. ಸೊ ನಮಗೆ ಲೋವರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇಲ್ಲಿದೆ, ಹೈಯರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇಲ್ಲಿದೆ. ದೇರ್ಫೋರ್ ವಾಟರ್ goes from second chamber to first chamber but not from first to second. So first statement is false. Second statement is a problem actually. The problem is to calculate osmotic pressure. Osmotic pressure calculation ke pi equals IRTC ಹಾಕಿದೀನಿ. I ಹಾಕಲಿಕ್ಕೆ ಕಾರಣ potassium sulfate is actually a kind of electrolyte. ಅದರಿಗೋಸ್ಕರ Van Hoff factor ಹಾಕಲೇಬೇಕು. ಸೊ 3 ಹಾಕಿ ಟೆಂಪರೇಚರ್ ಮತ್ತು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ. ಎಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 1079 ಇಂಟು 10 ಪವರ್ ಮೈನಸ್ 2 ಬರ್ತಾ ಇದೆ. ಅಂದರೆ ಖಂಡಿತ ಇಷ್ಟು ಬಾರ್ ಪ್ರೆಷರ್ ಅನ್ನೋದು ಬಂದೇ ಬರುತ್ತೆ. ಸೊ ಸ್ಟೇಟ್ಮೆಂಟ್ 1 ಇಸ್ ಫಾಲ್ಸ್ ಆ್ಯಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ 2 ಇಸ್ ಟ್ರೂ. ಇದು ಕನೆಕ್ಷನ್, ಇದು ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಒನ್. ಈ ಕ್ವೆಶ್ಚನ್ನಲ್ಲಿ at 27 degrees Celsius 0.1 molar 1 liter K4Fe CN 6 times. 27 degrees Celsius ಹತ್ತಿರ 0.1 molar K4Fe CN 6 times ತಗೊಂಡು ಅದನ್ನು 0.1 molar 1 liter ಫೆರಿಕ್ ಕ್ಲೋರೈಡ್ ಜೊತೆಗೆ ಜನರಲಿ ಆಸ್ಮೋಸಿಸ್ ಟ್ಯಾಂಕ್ನಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ. ಈ ಎರಡು ಸೊಲ್ಯೂಷನ್ಸನ್ನು ಆಸ್ಮೋಸಿಸ್ ಟ್ಯಾಂಕ್ನಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ. ಇದು ಇಲ್ಲಿದೆ, ಇದಿಲ್ಲಿದೆ. ಇವಾಗ ಸೆಮಿ ಪರ್ಮಿಬಲ್ ಮೆಂಬ್ರೇನ್ ಇದೆ ಎರಡಕ್ಕೂ ಮಧ್ಯದಲ್ಲಿ. ಈಗ ಕಂಪ್ಲೀಟ್ ಡಿಸೋಸಿಯೇಷನ್ನ ಎಸ್ಯೂಮ್ ಮಾಡ್ಕೋಬೇಕು, ಇದು ಕೂಡ. ಆವಾಗ ಕ್ವೆಶ್ಚನ್ ಏನಂತಂದರೆ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಆ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಏನನ್ನೋದು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಈ ಸೈಡ್ ಎಕ್ಸ್ ಅಂದರು, ಆ ಸೈಡ್ ವೈ ಅಂದರು. ಸ್ಟೇಟ್ಮೆಂಟ್ ಎ, ಬ್ಲೂ ಕಲರ್ ಈಸ್ obtained on both sides. ಫಸ್ಟ್ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕರೆಕ್ಟ್ ಇದೆಯಾ ಇಲ್ಲ ನೋಡೋಣ. ಬ್ಲೂ ಕಲರ್ ಎದಕ್ಕೆ ಬರುತ್ತೆ? ಬ್ಲೂ ಕಲರ್ ಬರಲಿಕ್ಕೆ ಕಾರಣ ಏನಂತಂದರೆ FeCl3 ನಲ್ಲಿರುವ Fe+3 ಅಯಾನ್ಸ್ K4CN6 ಟೈಮ್ಸ್ನಲ್ಲಿರುವ FeCN6 -4 ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಆದಾಗ ಪ್ರಷಿಯನ್ ಬ್ಲೂ ಕಲರ್ ಬರುತ್ತೆ ನಮಗೆ. ಈ ಪ್ರಷಿಯನ್ ಬ್ಲೂ ಕಲರ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಬಂದಿದರೆ ಆವಾಗ ನಮಗೆ ಬ್ಲೂ ಕಲರ್ ಬರುತ್ತೆ. ದೇರ್ಫೋರ್ ಇದು ಯಾವ ಸೈಡ್ ಬರುತ್ತೆ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್ ಇಲ್ಲಿ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಬಟ್ ವಿಷಯ ಯೋಚನೆ ಮಾಡಿ ನೀವು ಕರೆಕ್ಟಾಗಿ, ಇದರಲ್ಲಿ ಈ ತರಹ ಬ್ಲೂ ಕಲರ್ ಬರಬೇಕು ಅಂತ ಅಂದರೆ ಇಲ್ಲಿಂದ FeCl3 ಅಯಾನ್ಸ್ ಆ ಕಡೆ ಹೋಗಬೇಕು, ಅಲ್ಲಿಂದ ಫೆರೋಸೈನೈಡ್ ಅಯಾನ್ಸ್ ಈ ಕಡೆ ಬರಬೇಕು, ಆವಾಗ ಮಾತ್ರ ಈ ತರಹ ಪ್ರಷಿಯನ್ ಬ್ಲೂ ಕಲರ್ ಬರಲಿಕ್ಕೆ ಅವಕಾಶ ಇದೆ. ಬಟ್ ಸೆಮಿ ಪರ್ಮಿಯಬಲ್ ಮೆಂಬ್ರೇನ್ ಅನ್ನೋದು it's such a membrane which only allows smaller molecules like solvent molecules but not solute molecules which are larger in size. ಇದರಿಗೋಸ್ಕರ ನಮಗೆ ಎಲ್ಲಿ ಕೂಡ ಸೊಲ್ಯೂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ FeCl3 ಅಥವಾ FeCN6 ಟೈಮ್ಸ್ ಅನ್ನೋದು ಒಂದು ಕಡೆಯಿಂದ ಇನ್ನೊಂದು ಕಡೆಗೆ ಹೋಗೋದು ಆಗೋದೇ ಇಲ್ಲ. ಆಸ್ ಅ ರಿಸಲ್ಟ್ ಯಾವ ಕಲರ್ ಕೂಡ ಯಾವ ಸೈಡು ಬರಲ್ಲ. ಸೊ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇಸ್ ಅ ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಂತ ತಿಳ್ಕೋಬೇಕು ನಾವು. ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಗೆ ಹೋಗೋಣ. ಸೊ ಇಟ್ಸ್ ಅ ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬಿ. Ionic solutes in aqueous solution can pass through the semi-permeable membrane. Ionic solutes in aqueous solution can pass through semi-permeable membrane ಅಂತ ಒಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದು ಪಾಸಿಬಲೇ ಆಗಲ್ಲ, ಯಾಕಂದರೆ ಅಯಾನಿಕ್ ಸೊಲ್ಯೂಟ್ಸ್ ನೆವರ್ ಟ್ರಾವೆಲ್, ಓನ್ಲಿ ಸಾಲ್ವೆಂಟ್ಸ್ ಕ್ಯಾನ್ ಗೋ ಫ್ರಮ್ ಒನ್ ಸೈಡ್ ಟು ದಿ ಅದರ್ ಸೈಡ್ ಆಫ್ ದ ಸೆಮಿ ಪರ್ಮಿಯಬಲ್ ಮೆಂಬ್ರೇನ್. ಸೊ ದ ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ ಆಲ್ಸೋ ಫಾಲ್ಸ್. ದ ಥರ್ಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ಸೊಲ್ಯೂಷನ್ Y is hypotonic. ಸೊಲ್ಯೂಷನ್ Y ಈಸ್ ಹೈಪೋಟೋನಿಕ್ ಅಂತಿದ್ದಾರೆ. ಹೈಪೋಟೋನಿಕ್ ಅಂದರೆ ಕಮ್ಮಿ ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರ್ ಇರೋದು. ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರ್ ಕಮ್ಮಿ ಇರಬೇಕಂದ್ರೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕೂಡ ಕಮ್ಮಿ ಇರಬೇಕು. ದೇರ್ಫೋರ್ ಆ ಥರ ಐತಾ ಇಲ್ಲ ನೋಡೋಣ. ಇದು ವ್ಯಾಂಟ್ ಹಾಫ್ ಫ್ಯಾಕ್ಟರ್ದೊಂದಿಗೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. 0.1 ಇದ್ದೇ ಇದೆ, ಇದರಲ್ಲಿ ವ್ಯಾಂಟ್ ಹಾಫ್ ಫ್ಯಾಕ್ಟರ್ 5 ಬರುತ್ತೆ. ಸೊ 0.5 ಅಂತ ತಿಳ್ಕೋಬೇಕಿಲ್ಲಿ. ಈ ಕಡೆ 0.1 ಇಂಟು FeCl3 ಅಂದರೆ 3 + 1 4 ಅಂದರೆ 0.4 ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಈಗ ಖಂಡಿತ ಇಲ್ಲಿ ಕಮ್ಮಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬಂದಿದೆ. ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಮ್ಮಿ ಇದ್ದರೆ ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರ್ ಕೂಡ ಕಮ್ಮಿ. ದೇರ್ಫೋರ್ ಅದು ಖಂಡಿತ ಹೈಪೋಟೋನಿಕ್ ಸೊಲ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಈ ಕಡೆ ಇದ್ದಿದ್ದು ಹೈಪರ್ಟೋನಿಕ್ ಸೊಲ್ಯೂಷನ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಇಲ್ಲಿ ಆನ್ಸರ್ ಆಗುತ್ತೆ. ಲೆಟ್ಸ್ ಗೋ ಟು ಅನದರ್ ಕ್ವೆಶ್ಚನ್. ಸೊ ಇಲ್ಲಿ ಈ ಕ್ವೆಶ್ಚನ್ನಲ್ಲಿ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಕೊಟ್ಟು, ಅಂದರೆ ಸೆಮಿ ಪರ್ಮಿಯಬಲ್ ಮೆಂಬ್ರೇನ್ ಕೊಟ್ಟು ಇದರ ಸ್ಟೇಟ್ಮೆಂಟ್ಸನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದರಲ್ಲಿ ಏನು ಮಾಡಿದ್ದಾರೆ, ಸೈಡ್ ಎಕ್ಸ್ ಸೈಡ್ ವೈ, ಸೈಡ್ ಎಕ್ಸ್ ಈ ಸೊಲ್ಯೂಷನ್, ಸೈಡ್ ವೈ ಆ ಸೊಲ್ಯೂಷನ್ ತೊಗೊಂಡಿದ್ದಾರೆ. ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ನಲ್ಲಿ ಬ್ಲೂ ಕಲರ್ ಇಸ್ ಒಬ್ಟೈನ್ಡ್ ಆನ್ ಬೋತ್ ಸೈಡ್ಸ್ ಅಂತ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಬ್ಲೂ ಕಲರ್ ಬರಬೇಕಂದ್ರೆ Fe+3 ಅಯಾನ್ಸ್ FeCN6 -4 ಜೊತೆಗೆ ಕಂಬೈನ್ ಆಗಬೇಕು. ಬಟ್ ಆ ಥರ ಸೊಲ್ಯೂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನು ಟ್ರಾವೆಲ್ ಆಗಲ್ಲ ಆ ಕಡೆಯಿಂದ ಈ ಕಡೆಗೆ, ಕೇವಲ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಮಾತ್ರ ಹೋಗ್ತವೆ. ಅದಕ್ಕೆ ಬ್ಲೂ ಕಲರ್ ಯಾವ ಸೈಡು ಬರಲ್ಲ. ಎರಡನೇದು ಅಯಾನಿಕ್ ಸೊಲ್ಯೂಟ್ಸ್ ಕ್ಯಾನ್ ಪಾಸ್ ಥ್ರೂ ಸೆಮಿ ಪರ್ಮಿಯಬಲ್ ಮೆಂಬ್ರೇನ್ ಅಂದರು, ಬಟ್ ದ್ಯಾಟ್ ಆಲ್ಸೋ ಡಸ್ ನಾಟ್ ಹ್ಯಾಪನ್. ಸೊ ಇಟ್ಸ್ ಅ ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಸೊಲ್ಯೂಷನ್ Y ಆನ್ ದ ಸೈಡ್ Y ಈಸ್ ಹೈಪೋಟೋನಿಕ್ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಈಗ ಸೊಲ್ಯೂಷನ್ ಆನ್ ಸೈಡ್ Y ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದಾಗ ಅದರ ವ್ಯಾಂಟ್ ಹಾಫ್ ಫ್ಯಾಕ್ಟರ್ದೊಂದಿಗೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದರೆ 0.4 ಬರ್ತಾ ಇದೆ, ಈ ಕಡೆ 0.5 ಬರ್ತಾ ಇದೆ. ಖಂಡಿತ 0.4 ಇಸ್ ಅ ಲೋವರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ and hence I can say that it is definitely hypotonic. So third statement is correct. ಇನ್ನೊಂದು ಕ್ವೆಶ್ಚನ್ ನೋಡೋಣ. ಈ ಕ್ವೆಶ್ಚನ್ನಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ A is prepared by dissolving 1 gram protein with molar mass 50,000 in 0.5 liter water at 300 Kelvin. Solution B is prepared. So then the osmotic pressure is said to be X bar. Solution B is prepared by dissolving 2 grams of same protein in 1 liter water at 300 Kelvin. Then the value of that is Y. Solution C is also taken, where solution C is a mixture of solution A plus solution B. A and B ಗಳನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದರೆ ಆವಾಗ ಎಷ್ಟು ವ್ಯಾಂಟ್ ಹಾಫ್ ಫ್ಯಾಕ್ಟರ್ ಎಷ್ಟು ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರ್ ಬರುತ್ತೆ. XYZ ವ್ಯಾಲ್ಯೂಸನ್ನು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಇದು ಫೈಂಡ್ ಔಟ್ ಮಾಡಲಿಕ್ಕೆ ಪೈ ಈಕ್ವಲ್ಸ್ RTC ಅನ್ನೋ ಫಾರ್ಮುಲಾ ಹಾಕಿದರೆ R ವ್ಯಾಲ್ಯೂ ಬಂದುಬಿಟ್ಟು ಬಾರ್ನಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ದೇರ್ಫೋರ್ 0.083 ಇಂಟು ಟೆಂಪರೇಚರ್ 300 ಇದೆ ಇಂಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ 1 ಡಿವೈಡೆಡ್ ಬೈ 50,000 ಇಂಟು 1 ಡಿವೈಡೆಡ್ ಬೈ 0.5 ಲೀಟರ್ ಮೊಲಾರಿಟಿ ಮೋಲಾರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ಗೋಸ್ಕರ ಅದನ್ನು ಹಾಕಿದ್ದೀನಿ. ಈಗ 0.083 ಇಂಟು 300 ಡಿವೈಡೆಡ್ ಬೈ 50,000 ಈ 0.5 ಮ್ಯಾಲಿಗೆ ಹೋಗಿಬಿಟ್ರೆ 1/2 ಅಲ್ವಾ 2 ಟೈಮ್ಸ್ ಆಗುತ್ತೆ. ಸೊ ಐ ಕ್ಯಾನ್ ಮಲ್ಟಿಪ್ಲೈ ದ್ಯಾಟ್ ಹಿಯರ್ ಆ್ಯಂಡ್ ಕ್ಯಾನ್ ರೈಟ್ 600. ಸೊ ಅದರಲ್ಲಿ ಈ ಟು ಝೀರೋಸ್ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿ ಈ 6 ಇದರಲ್ಲಿ 120 ಟೈಮ್ಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ನಾಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಬಟ್ ಐ ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಎಸ್ 600. ಒಂದು ಕೆಲಸ ಮಾಡೋಣ, 5 ಇಂಟು 10 ಟು ದ ಪವರ್ 4 ಬರೆಯೋಣ ಇದನ್ನು. ಇದು ಇದರಲ್ಲಿ 120 ಟೈಮ್ಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಆ್ಯಂಡ್ ದೆನ್ ವಿ ಆರ್ ಸ್ಟಿಲ್ ಲೆಫ್ಟ್ ವಿತ್ 10 ಪವರ್ 4. ಆ 120 ಇಂಟು 83 ಮಾಡೋಣ. It is 996. So 83 into 10 to the power minus 3 into 12 into 10 power 1 into 10 power 4 is what we are left with. Then this is 5, this is minus 3, so we are left with 2. So 9.96. It becomes minus 4 when it comes to the numerator. So this is minus 3 and 12 into 10 power 1 and then 10 to the power minus 4, which means minus 3 minus 4 is minus 7 and then plus 1. So 10 power minus 6 is what I get in bar. This is the first thing calculation. Let's go to the next one. Innonsala verify madana. 0.083 in bar into temperature 300 and then 1 by 50,000 because 1 gram by 50,000 into 1 divided by 0.5 liter idu. 1 divided by 0.5 ಅಂದರೆ 2 ನೇ ಅದು. ಸೊ 2 ಇಂಟು 300 ಹಾಕಿದ್ರಿ, ನಾನು ಅದನ್ನು 600 ಅಂತ ಬರೀತಾ ಇದ್ದೀನಿ. ಆ 600 ಇಲ್ಲಿ 5 ಇಂಟು 10 ಪವರ್ 4 ಅಂತ ಬರೆದಿದ್ದೀನಿ. ಇದನ್ನು 0.083 ಅನ್ನು 83 ಇಂಟು 10 ಪವರ್ ಮೈನಸ್ 3 ಬರೆದು ಇದು 120 ಟೈಮ್ಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತಾ ಇದೆ ಇದರಲ್ಲಿ. Therefore, I can write it as 12 into 10 power 1 and then this 10 power 4 goes to the numerator. I'll get 10 power minus 4 there. 10 power minus 4 ಬಂದಿದ ಮೇಲೆ 83 ಮತ್ತು 12 ನಾನು ಕ್ಯಾನ್ಸಲ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಐ ಗಾಟ್ 996. ಆವಾಗ 996 ಇಂಟು 10 ಪವರ್ ಮೈನಸ್ 6 ಅಂದರೆ 9.96 ಇಂಟು 10 ಟು ದ ಪವರ್ ಮೈನಸ್ 4 ಬಾರ್ ಆಗುತ್ತೆ. ಇದು ಫಸ್ಟ್ ಪಾರ್ಟ್. ಈಗ ಸೆಕೆಂಡ್ ಪಾರ್ಟಿನ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಗೆ ಹೋಗೋಣ. ಸೆಕೆಂಡ್ ಪಾರ್ಟಿನ ಕ್ಯಾಲ್ಕುಲೇಷನ್ನಲ್ಲಿ ಕೂಡ ಇದೇ ತರಹ ಪೈ ಈಕ್ವಲ್ಸ್ RTC ಅಂತ ಹಾಕಬೇಕು. R ವ್ಯಾಲ್ಯೂ ಬಂದುಬಿಟ್ಟು 0.083, ಟೆಂಪರೇಚರ್ ಬಂದುಬಿಟ್ಟು 300, ಕಾನ್ಸಂಟ್ರೇಷನ್ 2 ಗ್ರಾಮ್ಸ್ ಹಾಕಬೇಕು. ಇನ್ 50,000ನಲ್ಲಿ 2 ಗ್ರಾಮ್ಸ್ ಹಾಕಬೇಕಾಗತ್ತೆ. ಇಂಟು 1000 ಡಿವೈಡೆಡ್ ಬೈ ಇನ್ ಹೌ ಮೆನಿ ಲೀಟರ್ಸ್, 1 ಲೀಟರ್, 1/1 ಲೀಟರ್. ನಾವು ಜಸ್ಟ್ ಕಂಪೇರ್ ಮಾಡೋಣ, ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡುವ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಇಲ್ಲಿ ನೀವು ಕರೆಕ್ಟಾಗಿ ಕಂಪೇರ್ ಮಾಡಿದರೆ ಇಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ನೋಡಿ 1/50,000 ಇಂಟು 1/0.5 ಅಂದರೆ ಈ 0.5 ನಾನು ಇಲ್ಲಿಗೆ ತೊಗೊಂಡು ಹೋದಾಗ ಅದು 2 ಆಯಿತು. ದೇರ್ ಫಾರ್ 2/50,000 ಇಂಟು 1/1, ಅಲ್ಲಿ ಕೂಡ 2/50,000 ಇಂಟು 1/1. ದೇರ್ ಫಾರ್ ಎರಡೂ ಕೂಡ ಸೇಮ್. ಹಾಗಾಗಿ ಎರಡರಲ್ಲಿ ಕೂಡ ಸೇಮ್ ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರ್ ಅನ್ನೋದು ಬರುತ್ತೆ. ಇದು ನಾನು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಇಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟಿದೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ? ಇದು 2 ಮ್ಯಾಲಕ್ಕೆ ಹೋದಾಗ 2/50,000 ಅನ್ನುವ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇದೆ. 2/50,000 ಅಂದರೆ 2/5 ಇಂಟು 10⁻⁻4 ಅಂತ ಬರೆಯಬಹುದು ನಾನು. ಅಂದರೆ ಇದು ಎಕ್ಸಾಕ್ಟ್ಲಿ 2/5. 2/5 ಅಂದರೆ 0.4 ಇಂಟು 10⁻⁻4. ಸೊ 4 ಇಂಟು 10⁻⁻5 ಮೋಲಾರ್ ಇದರ ಕಾನ್ಸಂಟ್ರೇಷನ್. ಇದು 4 ಇಂಟು 10⁻⁻5 ಮೋಲಾರ್, ಹಾಫ್ ಲೀಟರ್ ಸೊಲ್ಯೂಷನ್ ಇದು. ಇದು ಕೂಡ ಅದೇ 4 ಇಂಟು 10⁻⁻5 ಮೋಲಾರ್ 1 ಲೀಟರ್ ಸೊಲ್ಯೂಷನ್ ಇದು. ಅಂದರೆ 1 ಲೀಟರ್ ಪ್ಲಸ್ ಹಾಫ್ ಲೀಟರ್ ಮಿಕ್ಸ್ ಮಾಡಿದರೆ ನಮಗೆ ಹೊಸ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟು ಬರುತ್ತೆ ಅದನ್ನು ತಗೊಂಡು ಈ ಎರಡು ಸೊಲ್ಯೂಷನ್ಸನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದ್ದಾಗ ಎಷ್ಟು ಬರುತ್ತೆ ಅನ್ನೋ ಇದರಲ್ಲಿ ಹಾಕಬೇಕಾಗತ್ತೆ. ಸೊ ಹೊಸ ಕಾನ್ಸಂಟ್ರೇಷನ್ M3 ಈಕ್ವಲ್ಸ್ M1V1 ಪ್ಲಸ್ M2V2 ಡಿವೈಡೆಡ್ ಬೈ V1 ಪ್ಲಸ್ V2ದಲ್ಲಿ ಹಾಕಿಬಿಟ್ರೆ M1 ಫಸ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ 4 ಇಂಟು 10⁻⁻5, ಫಸ್ಟ್ ವಾಲ್ಯೂಮ್ that is 0.5 liters, and then second concentration is also 4 into 10⁻⁵. Second volume is 1 liter divided by total volume is 1.5 liter. So 4 into 0.5 is 2 into 10⁻⁻5 and 4 into 10⁻⁻5 divided by 1.5, that is 4 plus 2 is 6 into 10⁻⁻5 divided by 3/2 ಬರೆದ್ರೆ ನನಗಿದು 12/3 ಆಗುತ್ತೆ. ಅಂದರೆ 4 into 10⁻⁻5 ಮತ್ತೊಮ್ಮೆ ಬರುತ್ತೆ. Therefore when I consider that this and this gets cancelled for 2 times, 2 2s are 4 once again. So what I get is the same concentration once again. Therefore the value is going to be the same again. ಈಗ ಇದೇ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇರೋದ್ರಿಂದ ಪೈ ವ್ಯಾಲ್ಯೂ RTC ಹಾಕಿದರೆ ನನಗೆ ಮತ್ತದೇ 9.96 ಇಂಟು 10⁻⁻4 ಬರುತ್ತೆ. ಈ ಕ್ವೆಶ್ಚನನ್ನು ಇನ್ನೊಂದು ಸಲ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನೋಡಿ. ವೆನ್ ವಿ ಕನ್ಸಿಡರ್ ದೀಸ್ ಸೊಲ್ಯೂಷನ್ಸ್, ದೇರ್ ಆರ್ 3 ಸೊಲ್ಯೂಷನ್ಸ್ ಮೇಡ್. First solution is made with 1 gram of protein in 0.5 liters at 300 Kelvin. Hage second solution is made with 2 grams of same protein in 1 liter. But the third solution is made with a mixture of first and second solutions. So ನಾನೇನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಇಲ್ಲಿ ಪೈ ಈಕ್ವಲ್ಸ್ RTC ಈಕ್ವೇಷನ್ ತಗೊಂಡು R is 0.083, ಟೆಂಪರೇಚರ್ is 300 ಇಂಟು ಕಾನ್ಸಂಟ್ರೇಷನನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಕಾನ್ಸಂಟ್ರೇಷನ್ ವ್ಯಾಲ್ಯೂ 1 ಡಿವೈಡೆಡ್ ಬೈ 50,000 ತಗೊಳ್ತಾ ಇದ್ದೀನಿ ಇಂಟು 1/0.5. ಇದು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಇದೆಲ್ಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದರೆ ನನಗೆ 9.96 ಇಂಟು 10⁻⁻4 ಬಾರ್ ಬಂದಿದೆ. ಎಸ್ಪೆಷಲಿ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ ಅದು 4 ಇಂಟು 10⁻⁻5 ಬರುತ್ತೆ. ಇಲ್ಲಿ ಕೂಡ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅದೇ ವ್ಯಾಲ್ಯೂ ಇದೆ, ಇಲ್ಲಿ ಕೂಡ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅದೇ ವ್ಯಾಲ್ಯೂ ಇದೆ. ದೇರ್ ಫಾರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೇಮ್ ಇದ್ದರೆ ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರ್ ಕೂಡ ಸೇಮ್ ಇರುತ್ತೆ. ಹಾಗಾಗಿ 3 ಕೇಸಸ್ನಲ್ಲಿ ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರಿನ ವ್ಯಾಲ್ಯೂ ಇಸ್ 9.96 ಇಂಟು 10⁻⁻4. ಇಲ್ಲಿ ಥರ್ಡ್ ಕೇಸ್ನಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ನಾನು M1V1 ಪ್ಲಸ್ M2V2 ಬೈ V1 ಪ್ಲಸ್ V2 ಅನ್ನುವ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಿದ್ದೀನಿ. ಅಲ್ಲಿ ಫಸ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್, ಸೆಕೆಂಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇಂಟು ದ ಥಿಂಗ್ಸ್ ವಿಚ್ ವಿ ಹ್ಯಾವ್ ಹಿಯರ್ ಅದನ್ನು ತೊಗೊಂಡು ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದಾಗ ಮತ್ತೆ ನನಗೆ ಅದೇ ಕಾನ್ಸಂಟ್ರೇಷನ್ 4 ಇಂಟು 10⁻⁻5 ಬಂದಿದೆ. ಈ ಪ್ರಾಬ್ಲಮ್ ಈ ಥರ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ಗೆ ಹೋಗೋಣ. ಈ ಕ್ವೆಶ್ಚನ್ನಲ್ಲಿ 19.5 grams fluoroacetic acid. Fluoroacetic acid with molar mass 78 gram per mole ಕೊಟ್ಟಿದ್ದಾರೆ. This is dissolved in 500 grams of water at 298 Kelvin. The depression in the freezing point of water, delta TF calculate already our kottidare 1 degree Celsius. We need to calculate dissociation constant of the acid. Dissociation constant anna calculate ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ನನಗೆ ಫಾರ್ಮುಲಾ Ka equals C alpha square by 1 minus alpha. ಇದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂತಂದರೆ ನನ್ನ ಹತ್ತಿರ ಖಂಡಿತ ಆಲ್ಫಾ ಇರಬೇಕು. ಆಲ್ಫಾ ಸೊಲ್ಯೂಷನ್ಸ್ ಚಾಪ್ಟರ್ದಿಂದ ಬಂದಿದ್ದ ಕ್ವೆಶ್ಚನ್ಸ್ನಲ್ಲಿ ವ್ಯಾಂಡ್ ಹಾಫ್ ಫ್ಯಾಕ್ಟರ್ದಿಂದ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಈ ಫಾರ್ಮುಲಾದಿಂದ. ದೇರ್ ಫಾರ್ ನನಗೆ ಕೆ ಬರಬೇಕಂದ್ರೆ ಆಲ್ಫಾ ಬೇಕು, ಆಲ್ಫಾ ಬೇಕಂದರೆ ಐ ಬೇಕು. ಐ ಬೇಕಂದರೆ ವೇರ್ ಡು ಐ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಐ ಫ್ರಮ್? ಡೆಲ್ಟಾ ಟಿ ಎಫ್ ಈಕ್ವಲ್ಸ್ ಐ ಇಂಟು ಕೆ ಎಫ್ ಇಂಟು ಎಮ್. ನಾನು ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅವೇ ತೊಗೊಂಡು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಸೊ ಲೆಂಗ್ದಿ ಅನಿಸ್ಬೋದು. ನಾನು ಈ ಪ್ರಾಬ್ಲಮ್ ಎಲ್ಲ ನಿನಗೆ ಕೊಡ್ತಾರೆ ಅದನ್ನು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡು ಅಂತ ಹೇಳ್ತಾ ಇಲ್ಲ. ಬಟ್ ನಾನೇನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂತಂದರೆ, ಒಂದು ವೇಳೆ ಇದರಲ್ಲಿ ಒಂದು ಪೋರ್ಷನ್ ಆಫ್ ದ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟರು ಕೂಡ ಅದನ್ನು ಮಾಡೋಕ್ಕೆ ನಮಗೆ ಬರಬೇಕು. ಅದರಿಗೋಸ್ಕರ ನಾನು ಈ ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ಚೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಇನ್ನು ರೊಟೀನ್ ರೆಗ್ಯುಲರ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ನೀವು ಆಲ್ರೆಡಿ ಮಾಡಿದಿರಿ. ಸೊ ನಾನು ಸ್ವಲ್ಪ ಡಿಫ್ರೆಂಟ್ ಇದ್ದು ಏನಾದರೂ ಕೊಡಲಿಕ್ಕೆ ಚಾನ್ಸ್ ಇರುವಂತಹ ಮಾಡೆಲ್ಸನ್ನು ಚೂಸ್ ಮಾಡಿಕೊಳ್ತಾ ಇದ್ದೀನಿ. ಅವು ಖಂಡಿತ ಲೆಂಗ್ದಿ ಅದಾವೆ ಕೆಲವು, ಅದರಲ್ಲಿ ಡೌಟೇ ಇಲ್ಲ. ಆದರೂ ಕೂಡ ಈ ತರಹ ಲೆಂಗ್ದಿ ಪ್ರಾಬ್ಲಮ್ಸ್ನಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಪೋರ್ಷನ್ ಕೊಟ್ಟರೆ ಸಡನ್ನಾಗಿ ನಿನಗೆ ಸೊಲ್ಯೂಷನ್ಸ್ನಿಂದ ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂದರೆ ಬರಲ್ಲ. ಅದರಿಗೋಸ್ಕರ ನಾನು ಅದನ್ನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಕೆ ಎ ಈಕ್ವಲ್ ಸಿ ಆಲ್ಫಾ ಸ್ಕ್ವೇರ್ ಬೈ 1 ಮೈನಸ್ ಆಲ್ಫಾ ಅಂದರೆ ಆಲ್ಫಾ ಇದ್ದರೆ ನಾವು ಕೆ ಎ ಮಾಡ್ಬೋದು. ಆಲ್ಫಾ ಐ ಮೈನಸ್ 1 ಬೈ ಎನ್ ಮೈನಸ್ 1ದಿಂದ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. ಡೆಲ್ಟಾ ಟಿ ಎಫ್ರಿಂದ ಐ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಈ ಸೀಕ್ವೆನ್ಸ್ನಲ್ಲಿ ನಾವು ಫಸ್ಟ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ಫಸ್ಟ್ ನಾನು ಐ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಡೆಲ್ಟಾ ಟಿ ಎಫ್ ಈಕ್ವಲ್ಸ್ ಐ ಇಂಟು ಕೆ ಎಫ್ ಇಂಟು ಎಮ್. ಡೆಲ್ಟಾ ಟಿ ಎಫಿನ ವ್ಯಾಲ್ಯೂ 1 ಕೊಟ್ಟಿದ್ದಾರೆ. ವ್ಯಾಂಡ್ ಹಾಫ್ ಫ್ಯಾಕ್ಟ್ರಿನ ವ್ಯಾಲ್ಯೂ ಇದಕ್ಕೆ ನನಗೆ ಗೊತ್ತಿಲ್ಲ, ಸೊ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ವಿತ್ ಐ. ಕೆ ಎಫಿನ ವ್ಯಾಲ್ಯೂ ವಾಟರ್ಗೆ 1.86 ಅದೇ ಕೊಟ್ಟಿದ್ದಾರೆ. ವ್ಯಾಲ್ಯೂ ಆಫ್ ಕೆ ಎಫ್ 1.86. And then what we have is 1.86. Molality of the solution. Molality of the solution ಅಂದರೆ W2 by M2 into 1000 ಡಿವೈಡೆಡ್ ಬೈ W1 ಹಾಕಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ನಮಗೆ ಹೆಂಗಾದರೂ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬೇಕೇ ಬೇಕು, ಅದರಿಗೋಸ್ಕರ ನಾನು ಇದು ಸೆಪರೇಟಾಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. W2 ಇಂಟು 1000 ಡಿವೈಡೆಡ್ ಬೈ W1. So W2 value, mass of the substance is 19.5 divided by molar mass is 78. 1000 divided by mass of the solvent is 500. ಇದು ಇದರಲ್ಲಿ 4 times, ಇದು ಇದರಲ್ಲಿ 2 times. So the concentration is 0.5 molal ಅಂತ ತಗೋಬೇಕಾಗತ್ತೆ. So 19.5 in 78 for almost 4 times cancel ಆಗುತ್ತೆ. ಇದು 1000 by 500 is 2, therefore 2 by 4 is 0.5. Now coming to the point, molality is 0.5. ನೋಡಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಸಿಂಪಲ್ ಇದೆ. therefore I ವ್ಯಾಲ್ಯೂ ನಾವು ಇವಾಗ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. I ವ್ಯಾಲ್ಯೂ is 0. ಇದರಲ್ಲಿ ಹಾಫ್ ತಗೊಂಡ್ರೆ it is going to be 0.93. Then I have to find out 1 divided by 0.93 is how much? ಇದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ 93 in 100. 93 by 0.93, 93, 100 in what we need to write it as is 93 by 100 ಅಂದರೆ 100 by 93. ಈ ಥರ ಬರೆದುಕೊಂಡು 93 in 100 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದಾನೆ. That is almost 7 times 1.07 is the value. I value ಬಂದಿದೆ. ಸೊ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಮುಗಿದಿದೆ, I ವ್ಯಾಲ್ಯೂ ಬಂದಿದೆ. ಈಗ ಆಲ್ಫಾ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. ಆಲ್ಫಾ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಆಲ್ಫಾ ಈಕ್ವಲ್ಸ್ I minus 1 by n minus 1. Therefore the alpha value 1.07 minus 1 by 2 minus 1, which is 0.07. ಇನ್ನೊಂದು ಡೆಸಿಬಲ್ ಪ್ಲೇಸ್ ಹಾಕೋಣ for perfect calculation. 93 into 7, 7 3s 21. 5 times 7 5. So if I substitute the same here, 0.075 by 1, which is 7.5% actually. You can also write it like this. Second step ಮುಗಿದಿದೆ, third step ಗೆ ಮೂವ್ ಆಗ್ತಾ ಇದ್ವಿ. K equals C alpha square by 1 minus alpha. Ka ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ C value is 0.5. Alpha value is 7.5 into 10 to the power minus 2 whole square divided by 1 minus 0.075 ತಗೊಳ್ತಾ ಇದ್ವಿ. This is 0.5 into 7.5 whole square. ಅಂದರೆ ಮೊಲಾಲಿಟಿನೇ ಮೊಲಾರಿಟಿ ಅಂತ ಹಾಕ್ತಾ ಇದ್ವಿ ಇಲ್ಲಿ. (56.25) into 10 to the power minus 4 divided by 1 minus 0.075 ಅಂದರೆ 0.925 ಬರುತ್ತೆ. ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 1 ತಗೋಬೋದು ಅದನ್ನು. ಸೊ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದರೆ 28.125 into 10 to the power minus 4. Approximate answer for Ka value is this. ಈ ತರಹ Ka ವ್ಯಾಲ್ಯೂವನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಕೇಳಿದ ಕ್ವೆಶ್ಚನ್ ಏನು? 19.5 grams ಆಫ್ ಫ್ಲೋರೋ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ ತಗೊಂಡು ಅದನ್ನು 500 grams ಆಫ್ ವಾಟರ್ನ ಡಿಸಾಲ್ವ್ ಮಾಡಿದ್ದಾಗ ಎಷ್ಟು Ka ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಬರುತ್ತೆ ಅನ್ನೋದು ಡೆಲ್ಟಾ ಟಿ ಎಫ್ ಇಂದ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. Kaಗೆ ಫಾರ್ಮುಲಾ C alpha square by 1 minus alpha, ಆಲ್ಫಾಗೆ ಫಾರ್ಮುಲಾ I minus 1 by n minus 1, ಡೆಲ್ಟಾ ಟಿ ಎಫ್ಗೆ ಫಾರ್ಮುಲಾ I into KF into M. I ಬಂದರೆ ಆಲ್ಫಾ ಬರುತ್ತೆ, ಆಲ್ಫಾ ಬಂದರೆ Ka ಬರುತ್ತೆ. ಸೊ ಫಸ್ಟ್ ನಾನು I ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಮೊಲಾಲಿಟಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದೀನಿ. ಮೊಲಾಲಿಟಿ ನನಗೆ 0.5 ಬಂದಿದೆ. ಆ ಮೊಲಾಲಿಟಿ 0.5 ಹಾಕಿ KF ವ್ಯಾಲ್ಯೂ ಹಾಕಿ I ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದಾಗ ಸುಮಾರು 1.075 ಬಂದಿದೆ ಇಲ್ಲಿ. ಈ 1.075 ಅನ್ನು ಇದರಲ್ಲಿ ಹಾಕಿ ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ ಆಲ್ಫಾ ವ್ಯಾಲ್ಯೂ 7.5 into 10 to the power minus 2 ಬಂದಿದೆ. Ka ವ್ಯಾಲ್ಯೂ C alpha square by 1 minus alpha ಆಗಿರೋದ್ರಿಂದ ಈ ಆಲ್ಫಾ ವ್ಯಾಲ್ಯೂವನ್ನು ಅದರಲ್ಲಿ ಹಾಕಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ ಸುಮಾರು 28.125 into 10 power minus 4. ಅಂದರೆ ಕೆಳಗಡೆ ನಾನು 0.925 ಅನ್ನು ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 1 ಅಂತ ತಗೊಂಡಿದ್ದಕ್ಕೆ ನನಗೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಈ ವ್ಯಾಲ್ಯೂ ಬಂದಿದೆ. So this is what we need to solve this question as. Next question. ಈ ಕ್ವೆಶ್ಚನಲ್ಲಿ ಈ ತರಹ ಕೊಟ್ಟಿದ್ದಾರೆ. ಕನ್ಸಿಡರ್ ದ ಫಾಲೋವಿಂಗ್ ಸೊಲ್ಯೂಷನ್ಸ್. ಫಸ್ಟ್ ಸೊಲ್ಯೂಷನ್ is 2.2 grams glucose in 125 milliliter. Second thing, 1.9 gram calcium chloride in 250 milliliter solution. Third thing, 9 gram urea in 500 milliliter solution. Fourth, 20.5 gram aluminum sulfate in 750 milliliter solution. The correct increasing order of boiling point of these solutions will be another question. So ಇದಕ್ಕೆ ಕರೆಕ್ಟ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ಡರ್ ಆಫ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅನ್ನೋದು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇನ್ ಆರ್ಡರ್ ಇಟ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಸೊಲ್ಯೂಟ್ ತಗೋಬೇಕಾಗತ್ತೆ. ಎಷ್ಟು ಮೋಲ್ಸ್ ಸೊಲ್ಯೂಟ್ ಇದ್ದರೆ ಅಷ್ಟು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇರುತ್ತೆ. ಸೊ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು ಫಸ್ಟ್. ಅದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ 2.2 ಡಿವೈಡೆಡ್ ಬೈ 180 ವ್ಯಾಂಟ್ ಹಾಫ್ ಫ್ಯಾಕ್ಟರ್ದೊಂದಿಗೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ಬಿಕಾಸ್ ವ್ಯಾಂಟ್ ಹಾಫ್ ಫ್ಯಾಕ್ಟರ್ ಕೂಡ ಹಾಕಿಬಿಟ್ರೆ ನಮಗೆ ಕರೆಕ್ಟ್ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಬರುತ್ತೆ ಕಂಪೇರ್ ಮಾಡಲಿಕ್ಕೆ. ಸೊ 2.2 ಇಂಟು 180 ಗ್ಲೂಕೋಸ್ಗೆ ವ್ಯಾಂಟ್ ಹಾಫ್ ಫ್ಯಾಕ್ಟರ್ 1. ಸೊ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡುವ ಅವಶ್ಯಕತೆ ಏನೂ ಇಲ್ಲ. ಇದು 125. 125 1000ನಲ್ಲಿ 8 times. And then the rest of the calculation shall be done. 2.2 into 8. Looks like 17.6 divided by 180. ಅದು 1.76 ಆಗುತ್ತೆ. 176 into 10 to the power by 18 ಅಂತ ಹಾಕಿದರೆ .5 ಬರ್ತಾ ಇದೆ. So the concentration is 9.5 into 10 to the power minus 2, that is 0.095 molar. ಅಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇದೆ ಫಸ್ಟ್ ಒನ್. ಸೆಕೆಂಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ನೋಡೋಣ. ಸೆಕೆಂಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ 1.9 divided by 111. Molar mass of calcium chloride is 111. 1000 divided by 250 milliliter into ಎದಕ್ಕೆ ಹಾಕಿದ್ದೀನಿ ಅಂದರೆ ಎಕ್ಸ್ಟ್ರಾ ಕ್ಯಾಲ್ಶಿಯಂ ಕ್ಲೋರೈಡಿನ ವ್ಯಾಂಟ್ ಆಫ್ ಫ್ಯಾಕ್ಟರ್ ಹಾಕ್ತಾ ಇದ್ದೀನಿ. ಅದು 3 CaCl2. ಇದು ಇದರಲ್ಲಿ 4 times ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ 1.9 into 7. That is 13.3 in the numerator. 4 3s are 12. I took it as 7. So I should take it as this 38. Then 1 and 9, 8, 2, 2. 22.8. 22.8 by 111 is what we get. So if I also simplify that part, 2 times 60, not useful, 600, 5 times 2.05, 0.205 is what I get. Third case nalli urea 9 by 60 into 1000 by 500, and because it is urea you can take Van Hoff factor as 1. So 500 in 1000 for 2 times, so 18 divided by 60 is what we get. 3 6 are 18 and then 10 6 are 60. Therefore, it is 0.3 molar is what I get. Last thing, 20.5 divided by 342. 342 is the molar mass of aluminum sulfate. Sugar kuda ade. Sucrose in molar mass mattu aluminum sulfate in molar mass eradu onde 342 into 1000 divided by 750 into aluminum sulfate in a Van 't Hoff factor 5. Ashtu calculate ಮಾಡಬೇಕು. ಇದು if I take 250 3 times and then here it is 4 times. So 4 5s are 20 in the numerator and 20 into 20.5. That is 410 in the numerator. 410 divided by 3 into 342. One 1026, 410 and 1026. That's 1022 we have. Therefore, approximately 0. ಇದು 3 times ಹಾಕಿದ್ದೀನಿ 4 times ಹಾಕ್ಬೋದು. ಸೊ 0.4 molar ಅಂತ ಅಂದ್ಕೊಳ್ಳೋಣ ಇದನ್ನು. ಸೊ ಇದರ ಪ್ರಕಾರ ಕಂಪೇರ್ ಮಾಡಿದರೆ ನಮಗೆ ಹೈಯೆಸ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬಂದುಬಿಟ್ಟು 0.4 ಅಂದರೆ 4th one. ನೆಕ್ಸ್ಟ್ ಹೈಯರ್ ವ್ಯಾಲ್ಯೂ ಬಂದುಬಿಟ್ಟು 3 3rd one. ನೆಕ್ಸ್ಟ್ ಹೈಯರ್ ವ್ಯಾಲ್ಯೂ ಬಂದುಬಿಟ್ಟು 2 and the last one is 1. ಇದು ಆರ್ಡರ್ ಆಫ್ ಎಲಿವೇಶನ್ ಆಫ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆಗುತ್ತೆ. ಅದೇ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ಗೆ ಆರ್ಡರ್ ಕೂಡ ಆಗುತ್ತೆ. ಇದು ಈ ತರಹ ಸಾಲ್ವ್ ಮಾಡಬೇಕು, ಏನಿಲ್ಲ, ಪ್ರತಿಯೊಂದು ಕ್ಯಾಲ್ಕ್ಯುಲೇಷನ್ ಇಲ್ಲಿ ಅಷ್ಟೇ. ನೆಕ್ಸ್ಟ್ ಒನ್, ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ನೋಡೋಣ. ಈ ಕ್ವೆಶ್ಚನ್ನಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತಂದರೆ, ಇದು ಹೆನ್ರೀಸ್ ಲಾಗೆ ಸಂಬಂಧಪಟ್ಟಂಥ ಕ್ವೆಶ್ಚನ್. At 298 Kelvin, mole percentage of nitrogen in air is 80%. Mole percentage 80 ಅಂದರೆ mole fraction 0.8, 80 by 100. So mole fraction is 0.8. ಇದು nitrogen. Water is in equilibrium with air at a pressure of 10 atmosphere. ವಾಟರ್ ಇದೆ, ಏರ್ ಕೂಡ ಇದೆ. ಇದು 10 atmosphere ಇದೆ. ಎರಡು ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ನಲ್ಲಿ ಅದಾವೆ. ಬಟ್ ನಮಗೆ ಎಲ್ಲ ಏರ್ ಬೇಕಾಗಿಲ್ಲ, ಅದರಲ್ಲಿ ನೈಟ್ರೋಜನ್ ಮಾತ್ರ ತಗೋಬೇಕು. ದೆನ್ ವಾಟ್ ಈಸ್ ದ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ ನೈಟ್ರೋಜನ್ ಇನ್ ವಾಟರ್ ಇಫ್ KH is 6.5 into 10 power 7 mmHg. KH value 6.5 into 10 to the power 7 mmHg ಇದ್ದರೆ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ ನೈಟ್ರೋಜನ್ ಇನ್ ವಾಟರ್ ಎಷ್ಟು ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಹೆನ್ರೀಸ್ ಲಾ ಅಪ್ಲೈ ಮಾಡಿದರೆ ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು ಗ್ಯಾಸ್ ಈಕ್ವಲ್ಸ್ ಮೋಲ್ ಹೆನ್ರೀಸ್ ಲಾ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಂಟು ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ ದ ಗ್ಯಾಸ್. ಇದು ತಾನೇ ಫಾರ್ಮುಲಾ. ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು ಗ್ಯಾಸ್ ಎಷ್ಟು ತಗೋಬೇಕು? ಓವರಾಲ್ ಏರಿನ ಪ್ರೆಷರ್ ಇದೆ, ಅದರ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ 0.8 ಇದೆ. ಅದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾವು ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು ಗ್ಯಾಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೋದು. ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು ಗ್ಯಾಸ್ ಈಕ್ವಲ್ಸ್ mole fraction 0.8 into 10, which means 8 atmospheres. So ಅದು 8. Henry's law constant 6.5 into 10 to the power 7 and in mmHg. ಇದು mmHg ದಲ್ಲಿದೆ, ಅದು ಎದರಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ ನಮಗೆ? ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ನಲ್ಲಿದೆ. ಮತ್ತು ಒಂದು mmHg ನಲ್ಲಿ ಒಂದು ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ನಲ್ಲಿ ಇರಬಾರ್ದು. ಅದಕ್ಕೆ ಇದನ್ನು ಕೂಡ ನಾನು mmHg ಕನ್ವರ್ಟ್ ಮಾಡಿದರೆ 8 into 760 ಆಗುತ್ತೆ. Now into mole fraction of nitrogen. So 760 into 8 divided by 6.5 into 10 to the power 7, which equals mole fraction of nitrogen. So multiply madana. 76 into 8 ತಗೊಂಡ್ರೆ 6080 divided by 6.5 into 10 to the power 7. ನಾನು ಇದನ್ನು 608 into 10 power 1, 65 into 10 power 6 ಅಂತ ಬರೋದು. ಇದರಲ್ಲಿ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿ 10 power 5 ತೆಗಿತೀನಿ. ಸೊ 65 and 608 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. ನೈನ್ ಟೈಮ್ಸ್ ಅನ್ಕೋಬೋದು. ಈ ಸತ 3 ಟೈಮ್ಸ್. Next time 5 times. 9.35. So 9.35 into 10 to the power minus 5 is what we get as a mole fraction. ಇನ್ನೊಂದ್ಸಲ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನೋಡಿ. ನಮಗೆ ಕ್ವೆಶ್ಚನ್ ಏನಂದರೆ, ವಾಟರ್ ಏರ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ನಲ್ಲಿದ್ದಾಗ ವಾಟರಿನ ಟೋಟಲ್ ಏರಿನ ಪ್ರೆಷರ್ 10 ಅಟ್ಮಾಸ್ಫಿಯರ್ ಇದ್ದರೆ ಅದರಲ್ಲಿ ನೈಟ್ರೋಜನಿನ ಪರ್ಸೆಂಟೇಜ್ ಮೋಲ್ ಪರ್ಸೆಂಟೇಜ್ 80% ಇದ್ದರೆ ಮೋಲ್ ಪರ್ಸೆಂಟೇಜ್ ಅಂದರೆ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಇಂಟು 100. ನಮಗೆ ಮೋಲ್ ಪರ್ಸೆಂಟೇಜ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಮಾಡಬೇಕಂದ್ರೆ ಡಿವೈಡೆಡ್ ಬೈ 100. ಅವ್ರು 80% ಕೊಟ್ಟರು ಅಂದರೆ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ 0.8. 10 ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ನಲ್ಲಿ 0.8 ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ ಅಂದರೆ ಎಷ್ಟು? 8 ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ ಬರುತ್ತೆ. ಆ 8 into 760 ಮಾಡಿ ಈಕ್ವಲ್ಸ್ ಅದರಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. 760 ಯಾಕೆ ಹಾಕಿದ್ದೀನಿ? 1 ಅಟ್ಮಾಸ್ಫಿಯರ್ ಈಕ್ವಲ್ಸ್ 760 mmHg ಅಲ್ವಾ, ಅದರಿಗೋಸ್ಕರ ಹಾಕಿದ್ದೀನಿ. ಹೆನ್ರೀಸ್ ಲಾ ಕಾನ್ಸ್ಟೆಂಟ್ ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ. ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಸೊ 760 into 8 divided by 6.5 into 10 power 7, which equals mole fraction of nitrogen. ಈ ಎರಡನ್ನು ನಾನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ದಾಗ ಇಷ್ಟು ಬಂದಿದೆ. ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದರೆ 9.35 into 10 to the power minus 5 ಬರುತ್ತೆ as mole fraction. Let us solve another question. A solution is prepared by dissolving 0.3 grams of non-volatile non-electrolyte solute A of molar mass 60 gram and 0.9 gram of non-volatile non-electrolyte solute B of molar mass 180 in 100 milliliter. Calculate osmotic pressure. ಜನರಲಿ ನಾವೇನು ನೋಡ್ತೀವಿ ಕ್ವೆಶನ್ಸ್ನಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಸೊಲ್ಯೂಟನ್ನು ಮಾತ್ರ ಡಿಸಾಲ್ವ್ ಮಾಡಿದ್ದಾಗ ಎಷ್ಟು ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರ್ ಅನ್ನೋದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಂತಾರೆ. ಬಟ್ ಈ ಸತ ಎರಡು ಸೊಲ್ಯೂಟ್ಸನ್ನು ಡಿಸಾಲ್ವ್ ಮಾಡಿದ್ದಾರೆ, ನೋ ಪ್ರಾಬ್ಲಮ್, ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ತೊಗೊಂಡ್ರೆ ಸರಿ ಆಗುತ್ತೆ. ಸೊ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಫಸ್ಟ್ ನಾನು N1 ಫಸ್ಟ್ದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. W1/M1 ತೊಗೊಂಡಿದ್ದು 0.3 ಗ್ರಾಮ್, ಅದರ ಮೋಲಾರ್ ಮಾಸ್ 60 ಗ್ರಾಮ್. ಸೊ 0.3/60 ಗ್ರಾಮ್ ಅಂತಂದರೆ it is 3 into 10 to the power minus 1, 6 into 10 to the power 1. This in this for 2 times, therefore 10 power 0.5 into 10 to the power minus 2, which is 5 into 10 to the power minus 3 moles is what we get. N2 ಕೂಡ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. W2/M2 ಈಕ್ವಲ್ಸ್ ಅದರಲ್ಲಿ 0.9 ಗ್ರಾಮ್ಸ್ ಇನ್ 180 ಮೋಲಾರ್ ಮಾಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದು ಕೂಡ 9 into 10 power minus 1, 18 into 10 power 1 ಬರೆದ್ರೆ 1/2 ಬರುತ್ತೆ. 0.5 ಸೇಮ್ ಥಿಂಗ್, 5 into 10 to the power minus 3. ಈಗೇನಾಯಿತು, ಎರಡಿನ ಸಮ್ ತಗೊಳ್ಳಿ ಟೋಟಲ್ ಮೋಲ್ಸ್ ಬರಲಿಕ್ಕೆ. N1 plus N2 ಈಕ್ವಲ್ಸ್ 5 into 10 power minus 3 plus 5 into 10 to the power minus 3 ಅಂದರೆ ಟೋಟಲ್ ನನಗೆ 10 to the power minus 2 ಬರ್ತಾ ಇದೆ. 5 plus 5 is 10. ಸೊ 10 power minus 2 ಬರ್ತಾ ಇದೆ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್. ಇದು ಎಷ್ಟು ಸೊಲ್ಯೂಷನ್ನಲ್ಲಿ? 100 millilitersನಲ್ಲಿ. ಸೊ ಪೈ ಈಕ್ವಲ್ಸ್ RTC ಅನ್ನುವ ಕ್ವೆಶ್ಚನ್, RTC ಅನ್ನೋ ಫಾರ್ಮುಲಾ ಹಾಕ್ತಾ ಇದ್ವಿ. ಪೈ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿದೆ? ಪೈ ವ್ಯಾಲ್ಯೂ ಏನನ್ನೋದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. 0.0821 ತಗೊಳ್ಳಿ. ಟೆಂಪರೇಚರ್ 27 ಕೊಟ್ಟಿದ್ದಾರೆ, 300. ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್ ತಗೋಬೇಕು. ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್ ಈಸ್ 10 to the power minus 2 into 1000 divided by 100 milliliter. ಇದು ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಕ್ವೆಶ್ಚನ್ಗೆ ಈ ಥರ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ನಾನು ಒಂದೊಂದು ಸಲ ಕ್ವೆಶ್ಚನ್ ಡೇಟಾ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಡಿಫ್ರೆಂಟ್ ಸೊಲ್ಯೂಟ್ಸ್ ಎರಡು ಕೊಟ್ಟಿದ್ದಾರೆ. ಫಸ್ಟ್ ಸೊಲ್ಯೂಟ್ 0.3 grams with molar mass 60, ಸೆಕೆಂಡ್ ಸೊಲ್ಯೂಟ್ 0.9 grams with 180 molar mass. ಈ ಎರಡನ್ನ ಏನು ಮಾಡಿದ್ದಾರೆ, ಮಿಕ್ಸ್ ಮಾಡಿ 100 milliliter ಆಫ್ ವಾಟರ್ನಲ್ಲಿ 27 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಹತ್ತಿರ ಹಾಕಿದ್ದಾಗ ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರ್ ಎಷ್ಟು ಬರುತ್ತೆ. ಈ ಥರ ಎರಡು ಬೇರೆ ಬೇರೆ ಕೊಟ್ಟಿದ್ದಾಗ ಸಮ್ ಆಫ್ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ತೊಗೋಬೇಕು. ಸಮ್ ಆಫ್ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ತೊಗೊಂಡ್ರೆ ನಮಗೆ ಅದು ಕಾನ್ಸಂಟ್ರೇಷನಲ್ಲಿ ಹಾಕ್ಲಿಕ್ಕೆ ಬರುತ್ತೆ. N into 1000/V ಫಾರ್ಮುಲಾ ಹಾಕಿದ್ದೀನಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ಗೋಸ್ಕರ. ಇದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಕ್ಕೆ ಹೋದಾಗ ಇದರಲ್ಲಿ 10 times 10 to the power minus 1 time and this gets cancelled. So what I am left with is 821 into 10 to the power minus 4 into 30 is what I get. There again 10 power minus 3 I can cancel. Therefore 821 into 3 calculate ಮಾಡಿದರೆ 624. 2463 into 10 to the power minus 3, which means 2.463 atmospheres is what I get as an answer to this question. Okay, we shall stop here for today and discuss the rest of the things tomorrow. Tomorrow I'll come with more problems.